Hello, sir. Good morning, all. Hello, sir. Good morning.
Hello, sir. Good morning.
Good morning.
Sir, shall we start the session now?
Yes, we can start.
Yes,
Dr.
sir.
Dr. Chauhan has come.
Sir, he is come, but he's not connected with sound. So he has to connect with mic only.
Okay.
Yeah.
Because so he is going to chair the session. So once he comes and joins, we can start immediately.
Yes, sir.
Ananda sir, good morning. And
good morning, Nima. Good morning.
Good morning, sir. Good morning. And Jyoti sir, good morning.
You have very less participants, no?
Yes, sir.
Early morning always is a problem.
This is being live telecasted, sir. So participants will be joining through YouTube.
Okay.
So number will be shown here
Good morning.
very less.
Yeah. Namaskar. Good morning.
Namaskar, Jyoti.
Namaskar, sir.
Jyoti Tamang, yes. Namaskar.
Hello, sir. AFSTI Mysuru. Please connect with the computer audio. Dr. Vikas Singh Chauhan, sir, please connect with your audio. AFSTI Mysuru office, please connect with your audio.
Chauhan Saab? Dr. Vikas Chauhan, have you joined, sir? अभी ठीक लग रहा है?
हाँ जी। नहीं यार, we are connected भाई, that is why I am saying. Can you hear me now?
No, sir.
Okay. So can we start? Yeah. First they don't give permission and then they.
चुप रहना भी, बोलना मत कुछ. Hello, Dr. Chauhan, have you joined?
Yeah, Dr. Nema, good morning. I am here.
Okay. So can we start, sir?
Everybody has joined. I don't know, but they have to start this.
Yeah, Dr. Anand sir is there and Dr. Tamang sir is also here. So I think we can join. We can start. Hello.
Hello?
Yeah. So are we expecting some more people to join here, sir?
able to get the video.
मैनेजमेंट सब जगह नेट की समझ चाहिए.
So much sound. Hello? How many speakers you have switched on? Hello? It would come now, it was coming. Hello? Hello? 3, 3, 3, 3.
You're coming to FSTL, FSTL problem.
Hello, Dr. Nema?
Yes, yes.
Okay, we'll start. I think there's some audio problem we are facing right now.
Hello.
Properly?
Your voice is not clear, sir. Hello.
Can you hear me now, Dr. Nema?
Yes, sir. Your voice is breaking. It is not coming clearly.
Okay, okay. Can you just give me some time? We'll try to solve.
Okay, okay.
Hello, sir. Dr. Vikas, sir. Sir, there are multiple devices from same places. That's why that echoing the sound here.
Two side it is logged.
Then I have given only you.
Dr. Vikas Singh Chauhan, sir, you have joined from your personal device also. So you can speak from there also.
I have not joined.
Sir, here is one more participant whose name is Dr. Vikas Singh Chauhan. So I have co-hosted him.
Hello? Yes.
Can you hear me now?
Hello, Dr. Nima, can you hear me now?
Yes, yes.
Is it okay now?
Yes, sir.
Yeah, can we? Okay.
It is better, sir.
How to set up that screen now? That will be better.
So can we start, sir?
Yes, Dr. Nima, please. Sorry for this inconvenience. So we'll start now, and I will request Professor Nema, my co-chair, who is managing this session today with me, to please take charge of the session and start the session. Please. Over to you.
Okay, very good morning, everybody. And I welcome all of you to 28th Indian Convention of Food Scientists and Technologists, that is ICFOST. And this year, the theme of ICFOST is Emerging and Adaptable Technologies for Sustainable Agro-Food Industries and Economy. And we call it Eat Safe. This has started yesterday and it will continue till tomorrow. And today, the day with a plenary talk by two of the esteemed speakers of the country, and I welcome them as well. I welcome first, I would like to welcome Dr. Vikas Chauhan, who is going to chair the session. And I also welcome both the speakers and all the participants who have joined through YouTube and other media. I also welcome all the other delegates, media persons, press, scientists, and all the persons who are interested in ICFOST this year. So first, I would like to start the session by introducing the chair, Dr. Chauhan. In fact, he doesn't need that much introduction. He's already Honorable Secretary of the ICFOST and Honorable Secretary of AFSTI National. Besides, he's Chief Scientist and Head Plant Cell Biotechnology Department, CSIR CFTRI Mysore. He has done MSc, PhD, and MBA. He has more than 30 years of experience in research and teaching as well. He has a number of talks delivered in the country. To his credit, there are 46 and more number of articles at national and international journals. He has authored 5 book chapters, 1 patent he has obtained, and 2 more are there in the process. He has also developed know-how which have been transferred to industry in the area of his research. His area of specialization is algal biotechnology, and he has also been awarded the Best Research Paper Award by CSIR CFTRI for the year 2018, 19, and 1920. So with this little introduction, I invite chair of the session, Dr. Chauhan, to please take it forward. Thank you so much.
Thank you, Professor Nema. Now this is my duty to introduce my fellow co-chair, Professor Nema. As Professor Nema belongs to one of the topmost institute in India, that is NIFTEM. To give a very brief introduction of Professor Nema, he is presently holding the position of Dean Research and Professor at NIFTEM, Sonipat, Haryana. And he is a very active member of our AFSTI. Currently, he is the president at NIFTEM chapter, and he is holding the BTech degree in agriculture engineering, which he obtained in 1995 from JNKVV Jabalpur, and followed by MTech in 97 and PhD in 2008 in dairy and food engineering from IIT Kharagpur. And he has an excellent academic career throughout his after his PhD, and he started as the assistant professor at JNKVV in Jabalpur and RVS KVV Gwalior, lecturer in Itanagar, assistant technical manager at FIL Food Division, Calcutta, before shifting to the AAU Anand as associate professor 2019 to 11, and followed by his now association with NIFTEM. In 2011 onwards, first as associate professor and now as professor. And he is a renowned food technologist and who has been recognized by for his work. He has published more than 50 research papers, 7 book chapters, and he has authored 4 books on the subject. And he has been actively involved in the industrial interface also. He has been actively doing the consultancy services for the industry. And he has done 16 assignments for the NFP government Haryana, 7 assignments for MP government. And he is, as I told you, the member of not only FSTA, he is also member of IFT US, London, UK, life member of our association, and then New Delhi Indian Science Association, and so on. And he has been serving as the editor of our very prestigious Food Science and Technology Journal, JFST, since 2019. And he is the guest editor for Journal of Food Quality in 1718. He has earned several awards, to name just a few: Seligman, APV Fellowship.
I think, sir, you are not audible. Sorry to interrupt, but it seems there is some technical glitch. I don't know whether I am only not able to hear you or others as well.
No,
But
it is audible.
Audible? Okay.
Yeah.
Maybe then it is a problem at my end.
Okay, because we since morning we are having this glitch, so I don't. Okay. Dr. Nema, is it okay? Are you able to hear?
Yeah. Am I audible, sir? Clearly now.
Yeah, you are very clearly audible.
Okay. Thank you.
Yeah.
So,
yeah, just to end and Dr. Nema is, as I was telling, has earned several awards and travel grants, and he has visited several countries in his position as a food technologist. And with this, I request Professor Nema, I think this will be befitting to introduce the first speaker, that is Dr. Anand Ramakrishnan, to be introduced by Professor Nema, because they belong to the same organization, that is NIFTEM. So I request Professor Nema to Dr. Anand Ramakrishnan, that will be most effective. And so I invite Professor Nema to please introduce Dr. Anand Ramakrishnan and invite him to deliver the first plenary talk of today. Professor Nema, please.
yeah, thank you, sir. Thank you for elaborating so much about my biodata. In fact, I am trying to do whatever best I can do, at least for AFSTI, that is our own society. And today it is my great honor and privilege to tell something about Dr. Anand Ramakrishnan. He is from our sister concern, NIFTEM now. Earlier it used to be IIFPT. Now it has got the status of NIFTEM, in an institution of national importance under his dynamic leadership. So first I would like to congratulate him for taking IIFPT to the level of INI. Thank you, sir, and welcome to this session. Let me introduce a little bit about Dr. Anand Ramakrishnan. He is presently the director of NIFTEM Tanjavur from 2016, and before appointment to the director of NIFTEM, he was principal scientist and coordinator for ACSIR at CSIR CFTRI. He has experience of more than 2 decades in the area of research and administration in food processing institutions. He has obtained BTech in chemical engineering from AC Tech, Anna University, Chennai, and completed MTech at Anna University, Chennai. He has done his doctoral research in chemical engineering with a specialization in food engineering at Loughborough University at UK. During his PhD, he was awarded the prestigious Commonwealth Scholarship Program of the Government of the United Kingdom. His research area includes the design of engineered nano and micro-scale delivery system for the controlled and targeted release of food bioactive compounds, 3D food printing, engineered human dynamic gastrointestinal system, and glycemic index studies, spray drying and spray freeze drying of food products, and computational modeling of food processing operations. Dr. Anand Ramakrishnan is an active researcher with more than 2 decades of experience in research and administration. He has published research articles in the form of 160 plus impact factor publications with an average impact factor of 5.17. In the area of research, I think he is doing wonderfully well. He has got 2 international patents and 7 Indian patents. He is also author and editor of 10 books and 68 book chapters published by various publishers. He has supervised 13 PhD students and more than 50 bachelor's and master's students for their research. He is also fellow of many societies like the National Academy of Science, the National Academy of Agricultural Sciences, Royal Society of Chemistry, Royal Society of Biology, AFSTI, and many more. He is also editor of International Journal of Food Engineering, academic editor of PLOS 1 journal, international editor advisory board member of Drying Technology Journal, editorial member of Journal of Food Process Engineering and various international journals. Dr. Anand Ramakrishnan was awarded various awards like prestigious ICAR Rafi Ahmed Kidwai Award for Outstanding Research in Agricultural Sciences 2019, Tata Innovation Fellowship 2019-20 by DVT Government of India, National Design Award 2019 for Outstanding Contribution by the Institution of Engineers, National Design and Research Forum Award. He is also recipient of NASI Reliance Industries Platinum Jubilee Award 2019, Tamil Nadu Scientist Award 2018, IFA Special Platinum Jubilee Award for Development of Food Processing Technology and Innovation 2018. He has received several other awards including B.D. Tilak ChemCon Distinguished Speaker Award 2016 from the Indian Institute of Chemical Engineers, Dr. Sabir Oration Award 2017 by Indian Society of Veterinary Pharmacology and Toxicology, and Best Director of the Year 2018 and Visionary Leader of the Year 2018 by Integrated Chamber of Commerce and Industries. This is in nutshell about his, because it is so detailed and it is not possible to cover all the work which he has done and contributed in the area of food science and technology. So with this little word, sir, I would like to invite you, and I'm very sure, very confident that his talk on food architecture, which is going to deliver, is going to become very interesting, because not only the topic, but the way he delivers is also very amazing. And I am sure that all the participants and the audience who have joined here will be benefited from his talk. Thank you. And sir, please.
Thank you, Dr. Nima. It is nice to meet you in this forum, and thanks for the excellent introduction. And thanks, Dr. Chauhan, and accommodating me for today's talk. And really wonderful to meet our colleagues in the forum of ICFOST and AFST. Always I give preference for the AFST because that is the society we need to strengthen, because that is the connecting all the food technologies, food scientists, not only for the seniors and also our young generation students and all. So today I'm going to talk about food structure, especially under food architecture. And this is the new trend is coming up in our area of food science and technology, and how we can do the food architecture. That's what the next maybe 30 minutes I'm going to talk about it. And this what I try to do that architecture is, we know that well known this concept, but the food architecture, how to do that, and what are the components we need to understand before architecturing any of the food compositions. That's we need to have an insight in each and every component of the proteins, carbohydrates, fats, and all the micronutrients as well as the other biotic materials. Before going to that, see that Indian food industry right now, it's almost is going last 10 years, 10% growth rate. One of the very few segment in India is growing the double-digit growth rate more than 10 years is the food industry. And yes, the May month KPMG data is very clearly revealed that It's going to be a $535 billion market size in the 2025. It's a huge. Right now, we are almost 263 billion size. Is going to be a double in another 5 years' time. It's a phenomenal projection. And also, it's added for that export continue 2019, $32.5 billion US business has been exported the product. And this our segment is, if you look at 90-80% of our area, our industry belongs to MSME segment. That's what nowadays Ministry of Food Processing Industry give more focus to the MSME and small and medium industries, how to strengthen that one. Having said that, if you look at our last 1 year data from the last April to this February 21, and we are doing the phenomenal export in this time, because local market, our ready to cook product increased more than 35% demand in the local, and even export more than 43,000 crore worth of the food product we exported. The only industry I can say that not shown negative growth during the pandemic period is the food industry. And people are toast to ready to eat, ready to cook product, processed food. And that myth, what is the floated that like ultra processed food, we should not take it. That's what people try to advocate. But look at the numbers, what I shown here. It's clearly demonstrated consumers, our people start taking the processed food than the normal one. Not only that, we well aware of that during last 1.5 years pandemic period. 2 areas, pharma industry, yes, it's increased that like anything, the consumption of some of the pharmaceutical product. Along with that, our nutraceutical product, the supplements, increased a huge amount. Indian nutraceutical market growth rate is almost 35%. Can you imagine one segment is growing 35% increase? Like if you see the 2019 it was 280 billion, it's almost is projected to be going to be 1,260 billion in 2025. Under the nutraceutical, the Indian sports nutrition market also continuously increasing, and along with the herbal and traditional product. And the total global nutraceutical market expected to reach 228 billion. It is quite a lot. See, one side, our ready-to-eat, ready-to-cook product, traditional industry is growing very, very rapid phase. Another side, the specialty products like functional food and nutraceutical also increasing. Yes, these two are market. Come to our recent data, very recently released by NITI Aayog data about our health index score. We don't want to see such a report from our government. As a food technologist and food engineers, we need to work very, very closely with the government agencies to reduce this. You see the overall health index score, most of the largest states comes around 60%. But other states, if you look at less than 50% of our health index. This is what we need to think, how best we can make it our micronutrient available to our people. Look at our global burden of anemia. It's continuously giving the lot of issues for our country. Look at out of 1 lakh population, almost 45,000 population in India is anemic. Mainly they are looking into the iron deficiency anemia, IDA. And most of the developing countries, it gives a lot of pressure on the total GDP. They estimated around 4.5% of the GDP per annum. So huge. This burden is not only for the developing nation in India as well, and both pregnant women as well as the children's anemic prevalence is continuously increasing. Yes, one side, our market is going very well. Another side, consumer accepting our processed food. They wanted a new way of taking the food. And second one side, we are not healthy nation and we are leading to such a level. In this scenario, as a consumer like you and me, what is going in our mind? See, 100 years back, we used to take the food for the energy. 50 years back, we have taken for the nutrition. Now people wanted to take, they want to enjoy the food, food for soul. The consumers want customized food, the personalized nutrition, different range of product, the brand. If you look at last 1 year, so many new brands are established And even they crossed very rapidly to the 100 to 500 crore mark, very rapid in the food segment alone. In this scenario, how to feed our population with a nutritious product? That is the great challenge in front of us. Why anemic still existed in our country? Except selenium and vitamin C, most of the micronutrient absorbs less than 50%. Look at iron. Iron is absorbs only 10%. How to enhance this absorption in our body? That is the challenge what we are facing. That means how to deliver our structured proteins as well as the micronutrient to our body, and how to make sure this absorption level goes more than a 10%. If you're able to architecture the molecule like this, yes, we are the winner. Before going to that, what is that architecture, what I'm speaking about it? One is the conventional architecture. We know the building architecture, make it at the base structure, base design has to be made. Then you have the steels, the cement and all the things, then binding material, and you make the wonderful structure. Is it a similar way? Yes, it's similar way. So McClement has told the same thing and almost same. Like if you texturize the protein, you get the structure, then you have the DNA, and you have the all other macromolecules and the micromolecules. How to structure this macro and micromolecule in the particular manner to convince the customers over and above, increase the absorption of this molecule. That structuring is called a food architecture. Is it possible to do? Yes. If food scientists can't do that, who is going to do this? But only thing we need to understand both the way how the psychology and the sensorial properties of the people now, how they are accepting the food, one side. Second one is how to make this molecule, as the robotic molecule itself is decides how to absorb in our body. This is the two clear path we need to take. One side, consumer acceptance, another side, how to achieve the maximum absorption in our body. So it will look into two ways. One is that architecture of deliciousness. Like for example, flavor compound. That gives like when you release the flavor to your mouth and the taste buds, and then how our nose and how the brain is sensitizing your flavor molecules. If it's very good, yes, you try to take more food on that. So that one side, how to deliver that flavor molecules. Another side, sonic enhanced food has come into the market. See, normally we looked the flavor nose and eye, how it's food is prepared and presentable form. Then you put it in your tongue, taste is coming. Now ears also is coming into play. Now sonic enhanced food means like when you deliver the food, like for example, fish, along with the shisho sound, like a sizzler type. If the food makes the sound, people try to enjoy more. So how to create this type of sound with the molecules, whatever the existing molecule, what is the trigger mechanism to create the sound? So this is the what you need to architecture the product to make more delicious to the consumers. Another one is a structure, destructuring. How to do the destructuring in our body? That is the key element, like how our brain, the same manner, our GI tract, including the mouth, to the intestine, it's work the similar way of functioning. Then destructuring happens from the mouth, then disintegration takes place in your stomach, and then absorption takes place in the intestine. How to manipulate this? Is it possible this food molecule itself has to be disintegrate and makes the robotic molecule? That's what dissolution has come. So this is a two-way. One is you structure it, destructure it, how to play with these two things. So I'm not going for all the structure mechanisms. So I'll give some examples what I have worked on the last 20 years plus on the food structuring. One is the cellular architecture. Second one is the bottom-up approach. Whatever you wanted to say about nano food, Government of India, last year we brought the guideline how to use nano material in Indian food systems. Already it is available under the DOP, DBT, and 3D and 4D printing. Yes, how it is going to be a revolution under the gambit of food architecture. Then how to make the food analogues. Only these four areas I will touch with some examples. We'll go with the first cellular architecture. So, because you understand now we are not talking the matrix like a fiber protein. We are going beyond that. That molecule level, DNA level, how we structure the food matrix. That's what we try to do that. And one by one, we'll go that. First, before going to that, we need to understand why this segment is dominated right now. Is too high because of the plant-based matrix. People wanted to switch over from the meat to the vegan, especially after COVID. And the proteins, people understand protein is the important nutrient. We all should have it. Where we'll get the high amount of the protein? Yes, meat, more than 25%, you will get it. But can we get the similar amount of good quality protein from the vegan? That's what people try to get it. So that's what you look at the growth rate, 2018, 4.9 billion, and 2019, it's a 5.5 billion, and 20, it's 7 billion. And what is that expected? It's going to be a more than 27% growth rate from the 19 to 20. And it's going to be very high. And the US itself, 2x faster sales compared to any other product, the food product in the US itself. This is a very clear example. This may be going to repeat in the most of the other countries too. Then what are the mechanisms to create plant-based matrices? One is that plant-based meat analogues. Meat, yes, God created one. Anything you try to recreate a God creation is not that easy. One such example is meat, because it has the texture is entirely different, the cell structure, and it has the fat, proteins, and what you enjoy, the texture is entirely different. How to recreate the meat from the oilseed proteins, cereals, legumes, and how to do that? It's possible. We have some technologies there. One is the extrusion technology. We can texturize the vegetable proteins, then you can manipulate with along with the fats and oils and so on. And another technology is the shear, then spinning. Both the technology we can very well use to make artificial meat analogs, and we are also working on that, and whole world is working on that. That's what the market is going very, very high. But only thing, I put it down, what are texturized vegetable protein, proteins, flavor, fat, and binder. How to put all these molecules into the proper structure. That is the what food architecture come to play. This is the own art. We need to understand the science behind this one, and we have to understand what are the van der Waals forces and what is that energy it takes each molecules, how to make it this molecule withstand against gravity. For example, some of the molecules, if you are unable to do it against gravity, it's collapse. So how to avoid this collapse during the processing of any of the structure we wanted to make it? That's a great challenge. Another way of making in the meat is the cell meat. Take the stem cells from the animal, grow the meat in the lab, in the petri plate itself. Because you can avoid the carbon footprint, what the carbon dioxide released by the animals, that slaughtering. And apart from that, microbial load or antibiotics, all these things you can avoid. Yes, only one thing is it safe to grow animals meat in the lab? Yes, and already products are available. Hamburger has already 2019 is launched that one, and it's doing very well. It's a just marriage between the biotechnological approach as well as the food scientist, what we think as the food. So if you're able to marriage between these two, biotechnological approach and food science, test the way of looking at the food, so definitely the yield is the lab grown meat. But now trend is going to a little bit changed into this. One is the fully plant-based meat. Another one is the fully cultured meats or the cultivated meat. Now people wanted to merge both the things, because when we created the plant-based meat, the biggest challenge is the fat. The fat, what we get, the animal fat, that enjoyment, what you get, that saltiness, what you mix with our texturized protein, we may not able to get it from the what we try to recreate it. So what they try to do that, we'll get some portion of the animal fats mixed with our plant-based. That's what hybrid product has started coming to the market. If you look at future meat, Israel already blend with the cultured animal tissues, and the High Street UK, that company has started the plant-based proteins, fat, and starches from the cultured one, and Nissan Beeps. And this California, this factory also started working on this. So the trend not only the plant-based meat, cultured meat, the combination of the plant and cultured meat is growing very, very fast. One such company, if you know that, everybody aware of that, 2009, the Beyond Meat, the very startup company started. Now they signed an agreement with the PepsiCo. Even they launched the product Beyond Fried Chicken. They launched along with the KFC. It's purely plant-based, and the way in which they develop the product, the Beyond Meat, is unimaginable. Exactly the structure and texture is like a meat only. That's what most of the leading companies join hand with the Beyond Meat. Not only that, another company that redefined meat, and it's a very latest one. 2018 started this company, and the first company developed the food 3D printing methods, and you can see the redefined meat 3D printed stick. Exactly that meat. That is the advantage of food 3D printer structure it. So this is what somebody wanted to know, that how food structure makes your food is more appealing. This is the example. You can recreate steak exactly what it is there in the God created meat. It's possible to do that. So, but we need to understand what I explained about design first, then you need a structure, then you need to pack up, then you need a binder, then color and appearance and taste. But what is the composition? That is the great challenge in front of us. Even Niftam Tanjavur, we have done the similar type of work using the indigenous protein source. We developed the plant-based meat analogues. You can see that the structure. This is a 3D printed meat, what we develop from our side. It is exactly like a steak. And look at the protein content, what we develop our meat. 27% protein we could able to bring it. No isolation. We have not done the texturized. Little bit change in the whole structure, because that's the advantage of 3D printer. The layer by layer printout, it helps us to formulate the way in which our steak is there, our meat is there. So we could able to bring such type of products. Gelation, another one structure, architectures, for example, oleogels. You wanted to deliver the some of the nutrient. Oleogel is the better one, because you make the oil into the solid form. You can use the polysaccharide, protein, luteins, and other sodium alginates and other things. You trigger mechanisms which we use it. It's possible to do. Even, for example, curcumin is a fat soluble. You can put it in the curcumin MTC oil. You convert as a gelation and oleogels. It's easy to deliver the curcumin the normal form than this form. That is what people are now looked into, that how to structure the oil. Two way. One is the oleogels and oleoforms. Here, oil into the solid form, oil and the air system, the foam system, you can even create the gelation. And then spherification is the very old method, 1950s itself. People started using the sodium alginate along with the calcium chloride bath. And it's a very simple method, extrusion along with the emulsion techniques. We can use it to get caviar type of shape. Then you can pack inside that caviars like flavors or nutrient. You can deliver it. Some of the, for example, live bacterial cells or virus, we wanted to deliver through this. Is possible to do it in the spherification method. Texturization, we have an excellent extrusion. If you have that extrusion with the temperature control, yes, you can easily texturize the vegetable proteins. That's what we try to do that. But temperature, you need to reach out to close to 100 plus degree temperatures. Then texturize the protein, like a protein will denature in that above that particular temperature. Then you have the pressure difference from the dye coming out the material. That pressure difference, you can texturize your vegetable proteins. This is what most of the extrusion method, and we can make it a texturization. We can do that. Another areas, if food architecture, if you wanted to go for the micro nano foods, and one is the micro ionizations. Like once you particle size is become a very, very small, the surface area is increasing, means the solubility or absorption will go up. For one example, iron is 10% absorbs. If you make it a particle sizes not a nano size, if you go for even 400 to 500 nanometers, absorption may increase. That's what our own studies also demonstrated. But different techniques are there. For solids, we can go for the ball mill. But issue in the ball mill is the internal heat generation will takes place in the ball mill. Impact is there. But if you go for the microfluidizations, yes, but it's a batch process. You need to make it different cycles and hyperhomogenization and all. But again, when you go for the nano emulsions or nano droplets, you can reduce the 1/3 of the surfactant used in the emulsion, because the emulsion stability will be increased when you go for the nanocysts. Because of ionic strength, we are increasing it. And the encapsulation method, yes, I started working almost 20 years back in CFTRI. Still, is the one field is very, very growing very rapidly is the encapsulation. You have to pack these macro and micro molecules, because it has to pass through your mouth and the intestine, and it has to reach where it has to be reached, that particular form, and how to deliver it, where to deliver, when to deliver, and the rate of delivery. Everything can be manipulated using the encapsulation method. Now, what we try to work on that, the encapsulation, not in the outside encapsulation using the spray drying or any other methods. These molecules can act themselves as the delivery systems in the body itself. That's what we are right now. We are looking into that. And the advantage is, I don't want to explain the advantage of, we can go for the immobilized enzymes and bioactive deliveries. All these things is possible. But the nano delivery systems, we are not exactly going for 100 nanometers. Worldwide food scientists accepted till 1000 nanometer is the nano matrix, because our molecules, most of our molecules, not less than 100 nanometers. So that's what we kept it the scale till the 1000 nanometers, and worldwide accepted, including the liposomes, solid lipid nanoparticle, all these things we can do that. And different techniques are there. For example, electrospraying and electrospinning. This creates a web type of structure. You wanted to create that type of structure, as electrospinning will help. Only thing, you need to charge the molecule. Like, for example, protein, you charge it, and opposite charge is moves, and then you can have the web. So you create which is the web you want at X and Y direction, which is the manner you wanted to create the structure, you can do it. And the liposomes, nanogels, all these things is possible to create. I'll give one example. For example, curcumin, instead of delivering the curcumin to our body alone, you can add the resveratrol along with that. The synergistic effect of the both is increases, for the example, anti-cancer effect. But how to deliver both the molecules to whether the single micron size particles or nano size particles? What we tried in the conventionally, we have the 2 fluid nozzle in the spray drying. We changed it into the 3 fluid nozzle. So core cell formation exactly forms. Center portion resveratrol goes, outer layer curcumin goes, and then we put the binder material over and above. We made the encapsulates, and it delivers very well. Not only that, we use the similar concept for the electrospray to get the charged particle, zine protein we used to encapsulate, and we could able to deliver it. The same manner, the structure modifications, the reducing the size, for example, nano salt, because we need to reduce the salt. Right now, we are taking 9 to 12 grams of salts per day. It's quite high. We need to reduce to 50% of that. How to do that? We can't avoid the salt, because when we started eating with the non-vegetarian or salty, only most of the food matrix we are taking. But how to reduce it? Then we need to understand where is the salt taste bugs is sensitized from our tongue. So accordingly, we can manipulate. So we can use the 2 methods. One is the spray drying. Spray drying produces the macron size particle or micron size particles, and electrospraying can produce the nano size particles. Look at the controlled salt is the cubic size of 400 micron. Then we made the spray drying particles about 1.2 microns and 500 nanometer size of the electrospraying. What is the dissolution time? Electrosprayed particles, only 6 seconds in dissolution in your tongue. That means your brain will sensitize more salt is coming. For example, this salt can be treated in the chips. So we need only 30 to 40% less salt compared to the conventionally how much you are using. So this is the what we need to change the architecture of even molecule of sodium chloride. We are not changed anything. Just the morphological change help us to increase. Another one way of looking into the architecture is the foam. Foam architecture is it's a tricky one, because bottom is a liquid, top is the air. In between, you need to keep the foam intact. For example, cappuccino, they use the protein to create the foam. Espresso, without that, But is it possible to create a foam in the espresso? That's what we try to do that. And we use the coffee oil as a surfactant. Normally, without surfactant, creating the foam is the great challenge. We use the like a coffee oil. It has the chlorogenic acid as the head, the hydrophilic head and the hydrophobic tail. So we form the particular manner of this surfactant to form a patterning. And you look at the T20 and the coffee oil, both the stability of the droplets till 1200 seconds is really good. The stability is really good. So we use the same thing, and we packed a particular manner using the spray freeze drying method. You can look at that particles and the alignment of the droplet, the nano patterning, what is the effect. We use the spray freeze drying, spray drying, and freeze drying. All three methods we use to create foam in it. That's the what we know, well-known method for the foam boosters. How to create the foam booster is a spray dry with a high pressure. We can do that. But here we have done another method using the spray freeze drying and aligning the surfactant, the particular patterning manner. It releases the foam, and FESM analysis has very clear demonstrated how the foams are intact in the coffee itself. And other techniques of the encapsulations and advantage. I wrote the 4 books. You can refer in this book. We have the more detail about how to make this encapsulation, including the liposomal delivery systems. And functional food analogs as possible using the food architectures. I'll give only 2 examples. One example is what right now, August 15th, Prime Minister of India is announced, Government of India is going to be mandatory addition of fortified rice kernel in our PDS system. Yes, it's going to be happen. And what are the technologies are there? Is it a rice analogs is possible to create? Niftam Tanjavur is created the rice analogs. You can look at the rice exactly as it is, what is there in the rice kernel, the same variety, same size, shape, bulk density. We could able to create with the iron, folic acid, and vitamin B12. Recently, just 2 weeks back, Government of India releases the guideline how to use the fortified rice kernel in our system. Is the ratios 1:100 or 1:200, the equipment, all the things we already released it. But now technology is also ready. Now we need to make sure how to put it, this rice kernel mixed with the existing rice, but the varieties should be same. Like when you make this structure, analog structures for the rice, you should not leach out when your cooking takes place. That is the great challenge in front of us, especially iron. We can add even zinc and other micronutrient in the rice itself, what we develop this rice. So positive. That is the architecture we need to understand. The same starch base and the proteins and all the micronutrients is possible to add into that. And we have done the chia oil liposomal delivery. It's a phospholipids are one of the very nice delivery system. You can pack any nutrient into that. For example, we use the lipoic acid into the bilayer that where aqueous phase is there. Cyclodextrin, it's a bucket type structure. We added inside that bucket type structure of cyclodextrin, then chia oil in the fat molecules, then we added into the milk. This is a fortification of lipoic acid and linoleic acid into the milk is a great challenge because phase separation will occur. But what we did, we packed into the liposome, we added into the milk is possible to fortify. And other, I will complete another one is the 3D footprinting. And it is the one you can easily create a different structures using the 3D printer as a personalized nutrition, and you can customize and encapsulate. And we are the one first, we developed the indigenous 3D food printer, and also we brought first scientific articles. But the challenge in the 3D printing is the layer by layer printing. So once all the matrix like a starch or protein, you can't print. You have to convert into the printable form. That is the challenge what one should face it. Because the strength, the first layer to second layer to third layer, when the strength has to be there and the drying characteristics during the printability. So all these things one should take a rice as possible to do that. But is it possible to do fiber? That is the challenge what we faced it. Even we could able to do it the 17% fiber and protein makes the snacks, even microwave gives the better product after post-processing. So here slightly we changed the cell culture and artificial meat, what the combination. Similar one, we wanted to do it in a different approach. We have taken the direct chicken meat. Chicken does not have the fiber. So fiber we have taken from the other sources, from the dietary fiber sources, from the waste, from the pulse mills and other waste, and including the butter mushroom. We added back we made the chicken lollipop using printable form of that. Acceptability is very, very high. So this is the what we have to think. The new way of looking into the food architecture is that something is not there in the one matrix. Can we add from the other matrix to here? So that's what 3D food printer will help to do that. Even 3D printer can help to deliver the live cells. For example, probiotic cells. We are added into the probiotic cells with even after post-processing, we could able to retain the colony forming unit even 10 to the power 8 per gram. So quite high. We use the refractors windows drying to retain the cell viability, and also oleogels. We created MTC oil, oleogels, 3D printed oleogels could able to create. Again, rice. We have done the extrusion method. We developed our very clearly rice analogues at Neptam Tanjavur. But at the same time, when we go for the basmati rice, we have some challenge in that because the die size has to be changed because length is more means it's a very difficult to go with the extrusion line. So what we thought, can we do the printable like a 3D printing method to make a FRK? The same thing we have done the basmati rice in the 3D printed basmati rice. After cooking, it retains the same shape. Nothing has been lost from the encapsulation because we have the expertise of last 20 years how to make encapsulation. So just a matter of time to make a layer by layer encapsulation, putting into the another form of the rice. That's what 3D printed rice we have done, and we are working on the 4D printing shape change along with the color changes. When it is the, so for example, like a pasta, if a sheet shape is there, if you put the hot water twisted during the time and pH triggering mechanism, whichever the triggering mechanism temperature, it will do that. That's what 4D printing. We are also working on that. And waste utilization also, we are working in the different waste utilizations. For example, rice husk, we have taken, we converted as the different casing and other things from the particles, water comes from that. It's possible to print any case or the spoons and whatever it is. Right now, we are working, we want to take 3D printer to the every household. So that means one is the problem is the designing of what is the shape and other things. So now, right now, we try to do the cloud computing, all the designs, whatever you want, you can download from the net, then you can print it at our home. So this matrix and in-house 3D printer has been developed by us. And also we wrote the first book on 3D printing of foods. It has the end-to-end solutions and the matrix, what are the printable form, all the things. We want the miniature of the food processing. 3D printing is nothing but the miniature of food processing industry at home. So we wanted to take it that into that level is possible. Yes, we created the structure. Now come to the destructuring. That is the important. Architecture is once they make the building, it stays as it is. But food, it has to be created to make the appealing to the customers to take it themselves. But it has to be restructured in our systemic circulation. How to restructure it? One is that oral processing, then it goes for the stomach, the mechanical as well as chemical digestion, then it absorbs and takes place in the intestine. So we are also working on this destructuring of the matrix, because how fast we destructure and we can manipulate the destructuring, that will yield the better results. One is the absorption, another one is the slow release of the glucose. If you wanted to make a low GI product, glucose release should be slow. So that's what we try to do that. That means we need to understand how the oral processing takes place, because that is the first point. The grinding takes place. What is the cycle takes place in the your bite, average bite? When is the bolus is forming? This bolus is nothing but before swallowing yourself, what is the bolus is forms. So we try to do different formulations. We wanted to understand what is the maximum particle size the bolus is coming. So different biscuits we have taken along with the wafers and other things. It's clearly demonstrated uniform particle size we could able to achieve, and the 1 to 1.5 mm size of the particle size we could able to achieve. Then what is the interlinking between this particle size along with the GA? That also we tested. Yes, if you increase your bite, the oral behavior, the saliva absorption as well as the GA is a direct interlinking. So that it is surprised for us. That's what, that when you make it a food structure, destructure, both you need to understand before designing the any architecture in the product. So these are the different stomach already available in the market. We try to create a similar type of stomach for our country. When I was in CFTRI, this was made it 3D. We scanned the human volunteers and we taken the 2D images of the stomach. We convert as the 3D, and I think this is the first 3D printed stomach. And right now it is there at Niftam Tanjavur. This is the what happening in the contraction takes place in our stomach. We try to recreate the similar one here and look at the glucose absorption pattern. Engineered model as well as human, almost same. We made our own mathematical model to predict the GA, because very few techniques and few papers are available to calculate the GA. But some extent, some of the things are missed in the existing science. What we try to do, the mass transfer effort, how to bring into that. That's what we develop our own model. We inbuilt along with our engineered model. It can be predicted so close to the GI of any product. For example, we tried the different biscuits, plain biscuits of GI as 76. When we go for the finger millet biscuit, it's a 58. Then we can formulate the 45 days comes around the 41. And it's almost is a very close with the GI of others. This is the what a system right now available with us. We can use it for anyone. At the end, yes, food structuring is from 2.5 million years. We started the cooking, then sugar has evolved, cheese, mayonnaise, and the
Anand Ramakrishnan, sorry to interrupt, but
I'm completing now. And it has come food 3D printing right now, 2013, as the cultured meat has come. What is the future? Yes, this is the where we have to look into that, how to deliver this nutrient more bioavailable to our humans. That is the key challenge. Is possible to do with the food architecture. Thank you so much for inviting. And our aim is to make India as the world food factory. It's possible. And with the support of everyone, we can make it that dream comes true very soon. Thank you so much for inviting.
Thank you, sir. Thank you so much for leaving the multi-dimensional printing on the minds of audience. And with these thought, I think the audience will be motivated to start thinking in these directions as well, because now the time is changing and the traditional foods have to be looked into a new perspective. So these thought-provoking discussions will definitely help the audience, and they will particularly those who are going to take the research in the coming time, they will be thinking how we can incorporate these new thinking into the food architecture. So thank you so much. Now with the permission of chair, can I invite the next speaker, sir?
Namaste, you can invite.
Okay, our thank you, Anand sir. Thank you so much.
Sir, I would also like to request that maybe because now we are actually spilling over to the next session. So
yeah. So I will quickly go through the introduction about the next speaker, Dr. Jyoti Prakastaman. Sir, Dr. Tamang is a pioneer researcher in ethnic fermented foods and beverages of India and other Asian countries, which he scientifically studied and reported till date, focusing on food antiquity and culture, gastronomy, metataxonomic, metagenomics, metabolomics, bioinformatics, predictive functionality, starter culture, development, food safety, probiotics, whole genome sequencing, nutrition and health benefits for last 35 years. The findings of Professor Tamang have made significant paradigm shift from conventional microbial taxonomy to sequence-based taxonomy, providing the information of many functional microbiome in ethnic fermented foods and beverages of India. Currently, he is the prestigious International Center for Integrated Mountain Development chair. He has received several national and international awards, including Development of Biotechnology Bioscience Awards in 2005. He has published more than 190 research publications, including 3 books from Taylor and Francis and Springer Nature, with cumulative impact factor of 300 and citation of 6,250 with H index of 44 in Scopus. He also has one patent. Professor Tamang held several administrative posts in Sikkim University, first registrar 2011 to 13, Dean School of Life Sciences 2012 to 2020, and then active Vice Chancellor in 2017 and 18. So with these little words, I now invite Dr. Tamang. I really see Tamang as a great scientist in the area of fermented foods. I remember when I met him first time in 2003 during the first SASNET conference on fermented foods at Anand. So I know he has done a lot of work in northeastern states, particularly in Sikkim, and his whole life has gone into the fermented food, sir. So we are really, sir, very privileged to once again hear from you on the topic of ethnomicrobiology to genomic mining of traditional Indian fermented foods. So, sir, you are
Thank you.
invited, sir. Thank you, sir.
Namaskar. Thank you very much, Professor Chauhan and Professor Nima, the chairman and the co-chairman of this session. And my special thanks to my friend, Professor Uday, for inviting me to this AISTF, the conventions. I've tried to change my topic from Indian to the Asian fermented foods. I think my slide is visible. Is it visible? Professor Nima, my slide is visible.
Sir, your slides are visible and you are audible clearly.
Okay, thank you.
Yeah. You please continue, sir.
So before we go to the topic, the very important is the geographical distribution of ethnic fermented foods in Asia. You see, it's very interesting, the type of the fermented food, the consumptions and the productions in Asia is, there are two dominated fermented food. One is the fermented soybeans, which are mostly in the eastern part of Asia. Then it comes the entire Southeast Asia and all. Then covering to the Sikkim and the entire northeast of India, the entire Bhutan. Then only the eastern part, the eastern part of Nepal, and to the south and the northern part of China and all. This is mostly the fermented soybean product, both the bacterial and the fungal. And beside that, the alcoholic beverages, because wine is not a tradition in Asia, especially the Southeast Asia. The alcoholic beverages is prepared by the already traditionally prepared dry amylolytic starters and all. Then the milk, drinking of the milk and the fermentation of the milk products from the different domesticated animals, mostly seen in the Western and the West Asia and all, including the entire India and Sri Lanka and all this Asian part and all, and followed by the fermented cereals. The very unique type of the fermented food is being seen in the South India, including Sri Lanka, Maldives, Singapore, and Malaysia, where the majority of the Tamil peoples are being residing there for centuries and centuries and all. This is the fermented rice and legume. It is not a separate fermented rice, neither a fermented legume. It's a mixture of the protein and the carbohydrate that is commonly called the idli and dosa. And this type of the fermentation is being confined only in these regions in the world. These are the different the culinary, the recipes of the Asian foods. These are the Indian food, the Sri Lankan meal, Bhutanese meal, Chinese, and all. The rice is a staple food and all. So there are, what is fermented food is any raw material is subjected to the microorganisms which produce the microbial enzymes and produce a product which has which is organoleptically and socially and culturally accepted, with enhanced the flavor, textures, taste, and some nutritional values. These are called the fermented foods and the alcoholic beverages. There are more than 5,000 varieties of the major and minor fermented foods in the world, which are consumed as a staple, curry, side dish, and etc. The ancient people knew how to prepare the food products without the knowledge of the microorganism, microbiology, and the fermentation dynamics to obtain the desirable products with acetol sensory products. This is how we define the ethnomicrobiology in understanding the commentable indigenous knowledge of the ethnic people for production of the cultural and socially associated fermented foods by using or the culturing the beneficial microbiota during natural fermentations. There are, of course, in the human being also there are good guys and the bad guys. Same in the microbiota also there are good bugs and the bad bugs. Corona is, of course, is a bad bugs, but there are many good bugs or the beneficial microorganisms mostly in the fermented foods. One of the biological hubs for many beneficial life microorganisms. They enhance the nutritional value, fortify with the health promoting benefits, bio compounds, vitamins, and so on. Now, what is very important is what is metagenomics. One is the hydropod sequence and the shotgun sequence and all. This is the amplicons sequence and this is the metagenomic sequence. Then usually the hydropod sequence goes only for the one target gene. If we target the 16S RNA, it will go only for the bacteria. If it is the 18S, then it will go for, again, we have to do for the, if you want to target the fungi, then you have to target the 18S and so on. And it will do in the piecemeal and all, but it will not go for the virus and the archaea, which are also present in the food ecosystems. Now there is a latest technique which is called the shotgun sequence or the metagenomic sequences, where the DNA is extracted from the food and it codes everything, all the DNA, all the DNA present, all DNA present in that food is being decoded into the different domains. It includes the bacteria, it includes the fungi, it includes the yeast, it includes the virus and the archaea. Then we go to the metabolomics, as what Dr. Anand Ramakrishnan ji has beautifully clarified the food architect and mostly the bioactive compounds. And one of the very important nowadays in the food nutrition is foodomics, is the metabolomics. There are two types of the metabolites. One is the secondary metabolites, which are amino acid, fatty acid, and all. And another is the small molecules, biomolecules, which are untargeted metabolites. Now the scientists are more interested on the untargeted metabolites because it includes the bioactive compounds, some vitamins, and the immunomodulators, and some other compounds. Now what we do is that we integrate the metagenomics or the metabolomics mining of the approaches to understand more the microbiome and the metabolites relationship in the fermented food. This is how we do the metagenomic DNA extractions and all, and this is how we do the metabolomics by the LCMS analysis and all, with using the different pipelines in the bioinformatics and all. And this can validate the predictive functionalities of the different genes responsible for the metabolic pathways and validated by the metabolomics database. There are more than 10 varieties of the fermented food in Asia, the fermented vegetables, legumes, cereals, milk, and so on. So I'll just go an example of the cultivation of soybean in the Himalayas. There are two varieties of the soybeans, as what Dr. Anand Ramakrishnan has said, that many people now turning into the vegetarians and all the meat. But the good source of the protein is in the soybeans. As you know, that India is the fourth largest producers of the soybeans, but India does not have, except the Northeast, the Indian gastronomy does not have any history of the consumption of the soybean as a curry or the dal and all. I think this is a great challenge that only except in the Northeast, because we are just wasting the protein into the vegetable oil or giving the animal food rather than to modify it into the different types of foods and all. So these are the different ethnomicrobiology of the naturally fermented soybean foods in the eastern Himalayas, that is with the different particular names, Anema, Perian, and all. You see the northeast and especially the northeast, the eastern Himalayas is very rich the sources of the naturally fermented soybean product. I'll just give an example how this ethnomicrobiology knowledge of the ethnic people can be interpreted into the metabolomic channel. This is a traditional way of the preparation of kinema, which is a very popular fermented soybean, sticky fermented soybean product, and it is consumed as a curry. And this is being prepared traditionally and all. So we collected the different type of this the kinema from the eastern part of Nepal, the Sikkim, Darjeeling, in India and Bhutan. And we did the high throughput sequence and all. Because high throughput sequence, we targeted the 16S RNA for the bacteria and the 18S for the fungi and the yeast and all. Then again, we did a metagenomics shotgun sequencing and all. And it's so interesting results came and all. You know, it includes the bacteria, the virus, the eukaryote, archaea, and unclassified domains and all. So among these, the bacteria are the most the abundant domains and all. A total of 1,560 species of domains were detected. Among these, there were 1,451 bacterial species, 42 viral species, and 56 eukaryotic species, and 11 archaea species. Have been detected during the kinema fermentations. And the very interesting is that by the conventional method, we could identify only 4 to 5 species of the bacillus. But by the help of the metagenomic sequence and all, we detected 280 species by the depth learning of the genome mining in the kinema, with Bacillus subtilis as the most abundant species and all. Then you see the distributions of how they have been, how this the beneficial, the organisms are being mined and located, are detected in the different species, different the kinema of the different countries and all. This is how we did, and some of them are common, some of them are unique, and some of them shared. Then we did the metabolic studies and all. And this thing, there were more than categorized as an untargeted metabolites in kinema, which includes the immunomodulators or the immunostimulating effects such as the sonosins, the serotonin, the salivatone, and acesta. And there are bioactive compounds such as N-furotyramine, then harmolol, and acestas and all. This proves that the the kinema, the naturally fermented soybean product, is very rich in the untargeted metabolites. So this is how we have the correlated the each and every organism's the genome, the metagenome present in kinema, and their correlations with the production of each and every the untargeted metabolites and all. So we found that there is a better understanding in the strain of the targeting the metabolites of interest for the further studies. So this data, the experiment shows that it will give to if you would like to the developer starter cultures. I think this data will help us. The kinema is rich is very rich source of the microbiome with several bioactive compounds, immunomodulative vitamins, and the nutritional for the nutrition supplement as well as the therapeutic uses and all. Then we did the whole genome sequence of the Lactobacillus plantarum, which is isolated from kinema and all. And we found the red color immunity protein. It is a immunity, indicated the immunity protein and all. So this is a very interesting thing that the consumption of kinema may reduce the COVID, the pandemic mostly in the Northeast, but the study has to be done. This is just our hypothesis and all. So related bacillus fermented soybean foods in Asia are the Daoji of southern China, one of Thailand, Nato of Japan, and Chung of Jan. So this is how the sticky fermented food which I have told you about the kinema, and there are several naturally fermented soybean products in Northeast and in Daoji in China and these countries. And the sticky type of the fermented food, which are fermented by the bacillus, is being seen only within this triangle, which I propose is a kinema natto fauna triangle in 2010 and all. So this is the natto natural of 70 years ago. It was naturally fermented, but now they use the starter culture, which is the Bacillus subtilis variety natto strain, and it is marketed, and there are more than 500 companies in Japan. And PBOK is a naturally fermented alkaline product, which is very similar to kinema. And we collected the samples before the COVID in 2020 January. I visited there, and I collected the samples and all. This is all naturally fermented. And we also did the the metagenomic studies and all. And it also has got it's very rich in the microbiome and several the targeted, untargeted metabolites are present. And we also collected the Chungkokjang, a fermented soybean product, naturally fermented soybean product in Korea and all. This has, of course, the Korean scientists have done a lot of research on this Chungkokjang, but they have not done the metagenomic studies and all. So we collected this and we did in our laboratory and we reported and published in the Food Research International and all. So there are fungal fermented soybean products like miso. There are different types of like in miso, the Daoji of China and Sufu of China and shoyu and tempeh, soya sauce, doenjang of China. And tempeh, the Indonesia have historically invented the ethnomicrobiology of golden mold, Rhizopus oryzae. And tempeh has several functional properties, and the metabolism of tempeh was analyzed, and they have also done. And tempeh is a very popular food in Indonesia, also in the in Netherlands and all. Now I'm going to the very interesting part is ethnomicrobiology, fermented rice legume mixture products. I think most of you now, most of you are from South India. I think you had your breakfast, idli and dosa and all. So we know that the Leuconostoc mesenteritis is the main bacterium and all. It is the classical taxonomy and all. But recently with the high throughput sequencing, it has changed that it is the Vishela, which has appeared as a 9-hour and Enterococcus tuberculosis at 15-hour. Then it means where Vishela was not reported as the main initiator of Italy fermentation earlier. So now again, we are working on the shotgun sequencing. It may give the paradigm shift of the entire microbial changes. And we are also working on the metabolomics. It may also give us some additions of the new information on the untargeted metabolites. Whatever it is, the ethnomicrobiology knowledge of the ethnic Indian people might have standardized the natural fermentation processes of carbohydrate-rich rice and the protein-rich legume mixtures as a healthy and a balanced tasty food, which is yet to be studied to interpret the real mechanism of fermentation with advent of the new sequence-based taxonomy and the proteomics. And there are different types of milk products like dahi of India, lassi, shrikant, and arak of Mongolia, tarak of Mongolia, or kumish of Kazakhstan, and dadi of Indonesia. They call it not dahi, but dadi of Indonesia, which is prepared from buffalo milk. And there are varieties of the naturally fermented milk products in Northeast India. And we did both the culture limited and cultural independent methods and all. Then these are, and we did, I'm not going into details of that. And many probiotic microorganisms have been isolated from naturally fermented soybean products, and some of them have been selected. And we designed a selection method by using the omics and all. And it has, we are still working on that. I think this the methodology will be helpful for any researchers to select the best probiotic candidates isolated from the traditionally fermented foods. And besides that, as I told you that the alcoholic beverages is being prepared by using the ethnic amino acid mixed starters in Asia, and they are known by the different names in the different countries, but they look very similar, like matcha of India, then ragi of Indonesia. There are varieties of the starter cultures in India, the ragi of Indonesia, nuruk of Korea, the Lokpang in Thailand, the Yakyu of China, the Min in Vietnam, and all. Then if you see in the Northeast only, there are varieties of the amylolactic starters. And very interesting is that it contains the filamentous molds, it contains the amylolactic alcohol-producing yeast, it contains the flavor and the probiotic lactic acid bacteria. So this is the consortiums of all the domains present in the, this is very, very, and we must appreciate the ethnomicrobiological knowledge of the ethnic people who have cultured this, and we have decoded this all. Then we put isolated by the high throughput sequencing more than 594 species of the 83 species yeast and the 111 mold species and all. Then these are the different type of the yeast molds bacteria, and we published several papers on these amylolactic starters, and we also reported some probiotic properties of lactic acid bacteria isolated from this amylolactic starters and all. Now I'll come to the, this will be my last slide. The changes in the the food product, the changes in the microbial communities and the predictive functionality in the fermentation of toddy. The toddy, as the several papers have been published, but no paper has been published on the amplicon sequencing. Now we are still working on the metagenomics and will be publishing very soon. And what we found, as you know, that the toddy is very important, and Kerala government has already legalized it, and they have got the toddy the boat also. And in the FSSI, where I am a member in the alcoholic group, and we have already prepared a white paper and to commercialize and to regularize this, and we are now working on the standards to how to promote the alcoholic, some of the alcoholic beverages in India. And we did, and we found a very good correlations among the microbes participating in fermenting of toddy and the different predictive genes, which shows that this toddy is very healthy and it imparts the health promoting benefits and all. Now, the COVID versus fermented foods. Variation in death rates due to COVID among countries and among the regions of the same country. Example, very low rate, death rate countries in East Asia, Central Europe, or the Balkans, probably due to the consumption of the large quantities of the fermented foods. Even in our country also, if you see the death rate in the Northeast and others, though there is no such report and all, this is only our hypothesis, because the consumption of the fermented food in the Northeast is very high, comparable to other parts of India. SARS-CoV binding ACE2 downregulation enhances the angostin-2 receptor type, also associated with the oxidative stress. The nuclear factor erythroid-derived 2, like NRF2, is the most potent antioxidant in humans and can block, in particular, the AT1R axis. Fermented vegetables such as kimchi of Korea may enhance this NRF2 associated antioxidant effect, helpful in mitigating COVID severity. This is the recent papers by the Bogus and his team. And immunomodulators present in some Asian fermenters may also combat against the COVID. This is what we are working on that. So we believe that the fermented foods may help in combating the COVID-19. The conclusion, ethnomicrobiology knowledge of the ethnic people is highly commendable and ensures the choice of the substrates and creates a conducive food ecosystem to obtain the desirable sensory acceptable and the nutritive food products based on the ethnomicrobiology knowledge of the ethnic people, the application of modern food microbiology, including the sequence-based taxonomy and the analysis of the bioactive compounds and the immunomodulators present in the ethnic fermentation is necessary. Hence, the integrative approaches of metagenomics, metabolomics mining may validate the worth ethnomicrobiology knowledge of the ethnic people of India. Dhanyavad.
Thank you so much, sir. Thank you for bringing fermented food products in the knowledge of our audience. And very good to know that we are less affected by COVID because of the habit of taking more fermented foods in our country as well as in the whole South Asia. And I'm really very impressed, and I think the audience must have also got benefited. Sir, you have really set up a milestone in the traditional fermented food of not only Northeast, but the whole South Asia continent. So it's really wonderful to hear from you. And now, as the time is running fast, I would like to invite our chair to summarize the session so that we can move on.
Thank you, Professor Nema, for a wonderful summarization of the talks you have already done. And the talks were excellent, as you have mentioned, and both the talks were excellent, giving the perspective and the current development which is taking place in the areas covered by our both eminent speakers. Dr. Anand Ramakrishnan covered all the current, ongoing, and the developments which are taking place in the food architecture, and then Professor Jyoti Tamang covered all the ongoing developments and understanding which he is trying to develop on these fermented foods of not only Northeast India but all throughout the South Asia. So it was extremely informative, and I'm sure our audience must have understood a lot of the scientific intricacies which are involved, and would have given them the various possibilities in which the research can be taken in these areas. So with this, I thank both our eminent speakers, Dr. Anand Ramakrishnan and Professor Jyoti Tamang, for being with us and giving us this overview as well as the insight of the research taking place in their areas. And I also thank my co-chair, Professor Nema, for really conducting the session in a very organized manner. And I will also take this opportunity just to thank our sponsors who are without them this sessions and this whole conference would have not been possible. So I thank our major sponsors, AP Organics, and then Aromex Creation, then Hexagon Nutrition, Perkin Elmer, Marico, and other sponsors who have supported generously with their finance to conduct this program. And without taking any further time now, I would like to close this session with Dr. Nema, and we will now immediately move to the next session, for which our chair, co-chair, and speakers are already waiting. So again, once again, thanks to our eminent speakers and Professor Nema. Thank you very much.
Thank you, everybody. So we can, I think, close it so that we can move on to the next session. Thank you so much.
If you don't mind, I have a small query here. This is generally after the session, do we have any questions sessions? Of course, maybe we are running short of time. I do understand that. Do we have that? Because I just asked as the secretary, Dr. Vikas, is there on the screen. So can you just clarify that? Is there any questions hours generally after the presentation or not?
Means the audience or the participants can post their questions, and those questions we will try to take up depending on the time, or otherwise we'll forward them to the speaker.
Okay. Which means generally we don't address here, but it will be addressed later on, post-effective. That's what I understand.
Thank you. So now I'll request Professor Dr. Anand and Dr. Jaideep, they are here with us. So take us to the next session, please. Which already we have, and we have encroached into their session. So, so I request Dr. Anand and Dr. Jaideep to please take over.
Good morning, everybody. Am I audible?
Yes, Dr. Anand, you are audible.
You are audible to me?
Yes, sir.
Then we will start the session.
Yes, sir.
Yeah, good morning, everybody. Myself, Dr. Session. This technical session 10 on food additives, dietary supplements, and nutraceuticals. Dr. Anand DRDO, DFR is the chairman. So before handing over the mic to Dr. Anand, I shall introduce him. So Dr. Anand is scientist of Health, Nutrition, Biochemistry and Toxicology, Defense Food Research Laboratory, Mysore. And his areas of expertise in biochemistry and nutrition and development of health foods. He has more than 60 scientific papers and guided more than 60 students and 26 postgraduates. And Dr. Anand was also awarded the DRDO Technology Award and the Rensselaer Institute. With this short introduction, I am requesting Dr. Anand to chair this session and take it forward. Thank you.
Good morning, everybody. I'm happy to be a chair of this session. Now, there are 4 speakers in our session. And now my turn is, the first I will share my views and ideas about the nutraceuticals, then followed by Jaideep sir and 2 more speakers. So without taking much time, I will start the scientific slide sharing.
Excuse me.
Yes,
so,
sir.
Anand, we will go as per the schedule. So in that one, first speaker is Shan Sablani, second is yourself, third is myself, and fourth one is Professor Shah.
Okay, right, sir. So now I will invite Dr. Shan.
He is having. You can.
So I would like to introduce Professor Shan Sablani. He is basically worked as a senior marketing service engineer, OMC Computers, New Delhi in 1989 to 92. After his PhD, he moved to McGill University, Montreal to do PhD. Then he is joined as a lecturer in the same university from 94 to 95. Then joined as a research associate, McGill University, Canada, 1996 to 97. Then he has upgraded himself as a research associate in the field of agriculture and agri-food, Canada, in 1997. Then he has become assistant professor and later he became associate professor in the Washington State University from 2013 to 19. Then he has become full professor at Washington State University from 2019 onwards. So he has a long career and he has done a lot of research activities in a manner of joining as a research assistant, then a research associate, then a assistant professor, associate professor, then later he become professor. Now he is a member of several committees, graduate committee members, more than 50 places he is a committee member, and he has developed a lot of technologies. He is collaborating with the polymer companies, and he has designed and developed a thinner wall semi-rigid packaging material for sterilized and pasteurized food. Then he has developed a colorimetric sensor for monitoring the shelf life of dairy milk. He is working in the USDA National Need Fellowship Program to broaden the participation of underrepresented groups in food engineering. He is currently serving as a scientific editor for Journal of Food Engineering as a premier journal in the food. And he has received several awards. I will name 1 or 2 words like a Freezing Research Award, Frozen Food Foundation International Association of Food Protection in 2021, Excellence in Advising Award, Washington State University in 2018, Marcel Lonsin Research Prize, Institute of Food Technologies in 2016, a distinguished lecturer of the Food Packaging Division in 2016. So he has guided students. He has published very reputed articles in peer-reviewed journals. With a brief background, I request Dr. Shan Sablani to deliver his talk. Thank you.
Thank you, Dr. Anand, for the introduction. Am I audible?
Yes, sir. Yes, yes.
Okay. Thank you. Yeah, thank you once again, Dr. Anand, for your kind introduction. Good morning, everyone, and welcome to this presentation. Before I start my presentation, I would like to thank the entire organizing committee of this conference, and especially the chair of AFST, Dr. Udayana Pray, for inviting me to this meeting. And I can see that you have very, elaborate and very excellent program and very repeated line of speakers for this meeting. Well, my talk is going to be focused on designing of microcapsules for enhanced oxidative stability of micronutrients, as one of the talks in the morning on food architecture briefly mentioned about architectural design of food using the encapsulation technology. Before I okay, all right. Yeah, before I move on to my technical talk, I would like to briefly mention where I come from. So as Dr. Anand mentioned, I'm a professor at Washington State University. The university is situated in the state of Washington. Many of you probably know in US, we have two Washingtons. One is the capital city on east side, and state of Washington is located on the northwest of the US. Within the state of Washington, our university is located on the east side of the state at bordering Idaho. On west side, we have city of Seattle. Many of you probably know that city. The city is home for many brand name companies such as Amazon, Boeing, Microsoft, and Starbucks. Our state of Washington is really blessed with the agriculture and fisheries industry. On the West Coast, we have very big fisheries industries, even though a lot of fish is caught in Alaska, but most of the fish processing and packaging is done on the west side of the state of Washington. In the central, we have production of a lot of tree fruits such as pear, apple. We have grapes. We produce a lot of wine. On east side, we produce hay, wheat, and lentil. It may be surprising to Indians that state of Washington on the east side also produce a lot of lentil. The city of Pullman is very beautiful, has a very good, surrounding in terms of the countryside. And as I mentioned, our state of Washington produces a large amount of lentils, and in fact, our city of Pullman is known as the lentil capital of the U.S., and we celebrate the National Lentil Festival every August. As you can see some of the pictures here, our university president and first lady, they also participate in the festival. This is the aerial view of our university. So with this brief, I focus on my presentation. The macro encapsulation industry is very big globally. The market is going to reach about $20 billion by 2025. The major drivers for the macro encapsulation industry is 45 food products, as also mentioned in one of the talks by Dr. Anand Ramakrishnan in this morning, along with the pharmaceuticals. In addition, personal care, textile, and home industries also drive the microencapsulation industry. The major motivation for this microencapsulation industry is that the microencapsulated products provide excellent physical and chemical stability to active ingredients, which are really encapsulated in the wall materials or the carrier materials. This kind of a architecture or configuration not only helps to stabilize the active ingredient, but also facilitate the controlled release of the active compounds such as drugs, pesticides, as well as flavors. Encapsulation also helps to improve the handling of sticky materials, which may be sometimes problem in low glass transition active substance, or many times sugars. Encapsulation can also help change the sensory qualities such as the bitterness or masking of taste and odor in some of the products. Now, encapsulated product, it could be in the emulsion form, or it could be a reduced water system such as dehydrated fruits, vegetables, cereals, and powders. For such low reduced water systems, the way we analyze their stability, which means in terms of physical as well as chemical. In literature, we followed many different approaches. For example, water activity concept or idea has been utilized to explain the stability of reduced water systems. We have used glass transition, molecular mobility, or enthalpy relaxation type of concept to explain the stability of low water system. However, in literature, the physical and chemical stability of the encapsulated ingredient is not very well explained by either glass transition or water activity. Most of the time, the stability of encapsulated system is explained by the property of the wall material. So if some products are less stable, it is related that the wall material may have a higher oxygen diffusion, and this transport of oxygen is maybe oxidizing the active compound, and that's why they have lower stability, or vice versa. However, there is no direct approach to quantify the oxygen diffusion of wall material. However, in the literature, some scientists such as Obing and Rush from Germany and Europe, they have explained the stability in terms of the free volume property of the wall material. So if the free volume of the wall material is higher, you have higher rate of oxygen diffusion, and if you have a higher rate of oxygen diffusion, you may have the lower physical or chemical stability of the active compound. And free volume typically refers to the volume not occupied by the molecules. So it's the empty space in the material through which oxygen can get transported. Again, this is a very indirect approach, so there's no direct approach to quantify the oxygen diffusion of the wall material. So how does the microencapsulant industry designs or develop the microencapsulates? So generally, it is considered as a mixture of art and science approach, where the scientists or engineers working in the industry, they have significant knowledge of the material properties. Material property we mean by the property of the wall material. They also have prior experience of developing products. Together, it guides the formulation of the wall material. So typically what they do, they identify a few wall materials. Using those wall materials, they develop the microcapsules, and they store it for weeks or months, and they monitor the rate of oxidation. And based on that, they decide which formulation is working better than the other. And based on that, they probably might want to further adjust the formulation. And they do, again, do the storage studies. So this whole process is very iterative, and multiple iteration will take us to really design and really finalize and select the wall material. So we recognize that this takes very long period of time in order to optimize the entire microencapsulation process. So there is a really need to develop a methodology where we can rapidly screen the encapsulating material. So if you are, few materials are given or presented to the industry, they can quickly screen and develop using a methodology, and then we can identify and select a given wall material for the selected active ingredient. So what we developed a fluorescence-based methodology to directly estimate the oxygen diffusion in microcapsules. In this approach, we prepare the emulsion, and the preparation of the emulsion is a very standard protocol. You take the wall material. Sometimes it's necessary to incorporate some emulsifier, and in terms of the encapsulating ingredient, these are the oil soluble ingredients. So we select flaxseed as an oil for a carrier of the active ingredients. But rather than initially including the active ingredient, we incorporate the ruthenium dye, which is the oxygen scavenging. So when it is exposed to the oxygen, it absorbs the oxygen and changes the fluorescence. So that was really a contribution from our lab, that we incorporate that dye. And then using the standard spray drying method, we produce the microcapsules. And of course, if the encapsulation efficiency is not very high, there is always some surface oil which will be removed, because that dye would be also presented to the surface oil. And once we remove the surface oil from those microcapsules, as typically known, whether it's spray drying or freeze drying, we produce a range of particle size. And in order to control the particle size, we sieve them and tightly control the particle size range. And then we store those microcapsules at certain water activity, because the moisture content or water activity of encapsulants may also influence the oxygen diffusion. And once we have the stored sample or control sample at just selected water activity, we put in a instrument for the fluorescence measurement, where we initially expose these microcapsules to nitrogen to remove all the oxygen and get the highest fluorescence intensity. And then we expose this to oxygen, atmospheric oxygen, and monitor the fluorescence, how decay with time. In terms of the material selection, we selected two formulations, one based on the maltodextrins with a different DE, dextrose equivalent, and the second formulation where we had a high cap, which is the modified starch, again, commonly used for the wall material for the microencapsulation. And then that was supported by maltodextrin or other matrix former materials such as maltose. So in terms of the experiment, when these microcapsules were exposed to the nitrogen, you get the maximum intensity. And then when these microcapsules are exposed to atmospheric oxygen, you see the decay in the intensity with time. And we collect such data and then transform these data using some mathematical equations, and using the concept of or the fixed second law of diffusion, and knowing the particle size, we can identify the oxygen diffusivity in those microcapsules. Because we were developing this methodology, we didn't know what is the sample mass we should select to put into the fluorescence instrument. So we selected from very small 6 milligram to 30 milligram to see how it can affect our oxygen diffusion measurement. And then we noticed that if you have very small sample size, then you have a lot of variability in terms of the oxygen diffusion measurement. But the sample size 10 and above, you get quite consistent reading in terms of the oxygen diffusion. And we also noticed that if we have the narrower particle size, for example, between 30 to 45 micron, we get more accurate or better consistent diffusion measurement results. So now in terms of the macro encapsulation efficiency, we had two different formulation. The maltodextrin based formulation, they have lower macro encapsulation efficiency because they have very poor emulsification capacity, whereas a high cap, which has a better macro encapsulation efficiency because the modified starch acts as a emulsifier or oil stabilizer. And we also noticed that in some cases, the particle size is more spherical, and in some cases we have the shovel particles. So in terms of the diffusivity results, we noticed that as we had two formulation, the different formulation, the high cap based formulation has the higher oxygen diffusion, and maltodextrin based formulation, they have the lower oxygen diffusion. Now, lower oxygen diffusion means that it can be more stable in terms of the active ingredient because the less amount of oxygen is getting to the active ingredient through the wall material. And this characteristic is based on the molecular packing. So the lower molecular weight material, you have a less free volume, and they are more molecular packing. So they give the lower diffusivity. We also did some storage study to see whether the rate of lipid oxidation can correlate the oxygen diffusion property of the wall material. So this is how we collected the lipid oxidation data for those microcapsules. And once we collected the lipid oxidation data, we tried to correlate with the oxygen diffusion of those wall matrix. As you can see that it gives the increasing trend. So if you have a higher the oxygen diffusion of the wall material, you have more the lipid oxidation. So that tells us that the chemical stability of the active compound correlates very well with the oxygen diffusion of the wall material. So now this gives us a confidence that if you are able to measure the oxygen diffusion, then you don't have to do the storage study to see whether what would be the oxidation of those active compounds. We also try to validate or verify that kind of approach with freeze-dried matrix, because we know that the freeze-dried matrix tend to produce more porous morphology. In order to verify that, we also measured the oxygen diffusion coefficient in the freeze-dried matrix. So as you can see that the freeze-dried matrix and the microcapsules had a higher oxygen diffusion compared to the spray-dried matrix. So then the freeze-dried matrix tend to give the lower chemical stability because they allow higher oxygen transport within those microcapsules. So overall, with this study, it give us an indication that the fluorescence method we can use in real time to measure the species transport, and this can help us to rapidly screen the wall material for their protection efficiency. And this way we can minimize the need of shelf life of storage studies, and this approach can reduce the design time for designing or developing the microcapsules. We went ahead and validated this fluorescence method, what we developed with some other matrix former materials such as cellulose nanofiber-based microencapsules. We know that the cellulose-based nanofibers can improve the oxygen barrier property of the packaging film. This has been very well documented. In some cases, the cellulose nanofiber have been also incorporated into the food to modify the texture, for example, in case of a low fat foods. However, there is very little research done to incorporation of cellulose nanofiber in microencapsulation. So our hypothesis was that these nanofibers may be able to improve the oxygen barrier property of the microcapsules. And if that is the case, whether we can use our fluorescence-based approach to quantify the oxygen diffusion of microencapsulant incorporated with the cellulose nanofiber. So again, we developed the microcapsules using the cellulose nanofiber and without cellulose nanofiber. In this case, we selected guar gum arabic as well as with maltodextrin of different DE dextrose equivalent 4 as well as 25. And in addition to measuring the oxygen diffusion, we also measured the physical property of those microcapsules. So in terms of the results, of course, different matrix formers, they give you different physical property, but we were more interested in the oxygen diffusion. As you can see, for two different formulations, maltodextrin 4 base and maltodextrin 25, the maltodextrin 4 without nanocellular fiber, it has the higher oxygen diffusivity compared to when you incorporate the nanofiber. So nanofiber is able to improve the barrier property of the wall material. And the similar results we obtained with the different maltodextrin DE25, where again, incorporation of the nanocellulose fiber can reduce the diffusivity, thus increase the barrier properties. And as you can see here also, the glass condition temperature of these capsules are not really affected by incorporation of the nanocellulose fiber because the amount incorporated is 0.05%, which does not change the molecular mobility of the wall material. So it tells also that the glass transition temperature-based concept actually does not really work very well to characterize the stability of the microcapsule. It is the oxygen diffusion, which is the primary mechanism for the chemical and physical stability of the microcapsules. And the way we explain the mechanism is that if you don't have the cellulose nanofiber, then it is the maltodextrin and gum arabic. They are creating some resistance to oxygen flow to the active ingredient. Whereas if you incorporate a cellulose nanofiber, it increases the path of diffusion by increasing the toxicity of the oxygen flow through the wall material. Hence, it takes longer time for oxygen to reach to the ingredient, and thus you have the lower oxidation or maximum protection to the active ingredients. So, in final, the approach we develop in our lab is able to monitor or quantify the oxygen transport in microcapsules. And recently, we validated this methodology with some of the commercial formulation developed by one of the nutraceutical company in Europe, as well as another company in the US. And in future, we want to continue this work to correlate the oxygen diffusion property by developing a microcapsule with the various different type of morphology, such as shown here. With that, I would like to acknowledge the assistance of my graduate students who were really driver and contributed to this work. And I also want to acknowledge the funding for this research came from the IFT Marcel Lonson Research Prize, as well as some of the funding coming from the nutraceutical companies. With that, thank you very much. I'll be able to answer any questions, or you can post a question in the chat box and I'll be happy to answer those questions. Thank you.
Thank you, Dr. Shan Sablani, with very good slides. I think you have guided more than 20 students, and the work what you have shown was it's a gist of your activities. You have received many awards. You have written book chapters that will definitely help the student community of the world. Working with a nano encapsulation, it is a bit risky and tricky. What I can say, because we are also working on that one. Most of our antioxidants and tannins, saponins, these are having a bitter in taste. To bring it to the market, it is a challenging job for any researcher. My next talk is on that one, how to bring this nutraceutical into the market. So once again, I thank you very much for your elaborative and information. Your technique will definitely come into the market. I hope that it should be commercialized and that the instrument also should come with a user friendly. I thank you once again. I thank the organizers. Thank you very much.
Yeah, thank you. And looking forward to your presentation. Yeah.
Sir. Jaydeep sir.
Hello.
Yes, madam. Am I audible, madam?
Yes, sir, you're audible.
Yeah. Can I start my session? My talk?
Yes, sir, yes.
Yeah. Are you able to see my slides?
Not yet.
Now, madam?
It is.
Yeah. Are you able to see the slides?
Yes, it is.
Yeah. Can I proceed? Yeah. Good morning, everyone. I'm very thankful to the organizers for giving me an opportunity to share my views on these nutraceuticals. Dr. Chauhan, Dr.
Excuse me, Dr. Anand, you can make it full screen.
Yes, sir. Full screen only.
Now we are seeing partial screen only.
Sir, please click on the presentation mode.
You can stop.
Right
Share.
one. Yeah.
Now it's
now
all
it's
right.
okay.
Go ahead.
Yes.
Now it's fine, sir.
Fine, sir. You can go ahead.
Yeah. Good morning, everyone. Dr. Chauhan, Dr. Jaydeep, and other organizers, thank you for giving me an opportunity to share my views on these nutraceuticals. So my topic is that the nutraceuticals and commercial perspectives. So what is the role of a researcher to identify nutraceuticals, antioxidants, other things? So now what is the role of industry? How it will come into the commercial application? These are my major subheadings to share and discuss. The definition for this nutraceutical was coined by Stephen D. Felles in 1989, almost 30 years back. The nutraceutical is any substance that is a food or a part of a food and provides a medical or health benefits, including the prevention and treatment of a disease. This is the definition for a nutraceutical. Now, based on the nutraceutical function and the characters, we can classify these into three categories. One is natural source, from where the nutraceuticals are available, and pharmacological condition, how this nutraceutical will help to reduce the lifestyle diseases. And the third category is classification is based on the chemical constitution. What is the chemical? It is like a protein or any supplement which is having polyphenols, flavonoids, these things. So nutraceuticals based on their characters, natural antioxidants, These are phytochemicals available in the form of fatty acids, polyphenols, isoprenoids, lipids, proteins. In that fatty acid categories, omega-3 fatty acids, omega-6 fatty acids, these are available from the natural source. So polyphenols are majoritarily flavonoids, polyphenols available from tea, coffee, other natural source. Isoprenoids are available in the form of carotenoids, which are from carrot and other fruits and vegetables. Lipids are available from sphingolipids. These are from seeds. And the proteins, like a majority of the protein so far we are bringing to the commercial level is soya proteins. Now next category is that plant itself is having nutraceuticals which can be used as a food. Majoritarily these are the functional foods available as a plants. The antioxidants are three categories. One is true antioxidants. The second category is reducing agents. And third category is antioxidant as a synergistics. So deficiency of these antioxidants intake will lead to some of the cancers, arthritis, Alzheimer's disease, and the cardiovascular disease because of the latest lifestyles and stress on human beings. Now the source of antioxidants, vitamins in the form of vitamin C, vitamin E are available from citrus fruits, grains, nuts, and oils. Carotenoids are available from tomato, beta carotene from carrots, sweet potato. These are the source of antioxidants. Xanthophylls are available from mango, papaya, oranges. Flavonoids are available in the form of rutin, lutein, quercetin, camphorol. These are also available from plum fruit, lemon, red pepper, olives, onions, apple skin, black grapes, grapefruits, tea. Now as a herbs, like a plant as it is available as a functional food is one of the best example is flax seeds. Linum uticosaceum. The chemical constituents available is gamma linolenic acid and alpha linolenic acid. These are the major source from flax seeds, which are having health benefits of preventing memory, colon, and rectal cancers, reduce blood pressure in hypersensitive patients, reduce diabetes and coronary heart diseases by consuming these flax seeds. Another example is turmeric. Rhizomes of turmeric, Curcuma langa, having curcumin, desmethoxycurcumin, bis-desmethoxycurcumin. These are the chemical components which are available from turmeric, which are having antimicrobial activity, and it is used for the centuries. The next one is tomato lycopenes, which is available from Lycopersicum esculentum in the form of lycopene. It prevents the prostate cancer, reduces risk of cancers of digestive tract, pancreas, cervix, bladder, and skin cancers. Ginseng. This is one of the memory boosting nutraceutical, which is having in the chemical form of protoperoxidase, polysaccharides, starch, sterols, polyacetylens, choline, vitamin B1, B2, B12, pantothenic acid, and biotin. This ginseng extract is having this many nutraceuticals in the form of vitamins, sterols, and polyacetylens. The health benefit of this ginseng is to cope up with the stress and fatigue, relieves hypertension, hypoglycemia, modifies the liver function, metabolism. So now spices. Spice principles are having health benefits. The antioxidant activity of curcumin is a chemopreventive, anti-inflammatory, anti-angiogenic, anti-adaptogenic, and anti-tuberogenic. Gamma oryzanol, isolated from Cinnamomum zeylanicum reduces the dyslipidemia. Nutraceuticals such as ferulic acid, caffeic acid, gallic acid, flavonoids, epigallocatechin, curcumin, lutein, isoflavonoid, anthocyanins, lycopenes acts as anti-cancer agents. Against the anti-obesity, we have identified so many nutraceuticals such as linoleic acid, chitosan, psyllium fiber, vitamin C, catechin, methyl epigallocatechin, trihydroxyflavin, catechin, astagalin, quercetin, isoquercetin, sulfoside, pseudoprotodiazine, etc., etc. So many are identified from the natural source, which is working against anti-obesity. Now, when it comes to the cardioprotective, vitamin C, vitamin E, beta carotene, lycopene, lipoic acid, glutathione, coenzyme A, Q10, SOD, selenium, these are also identified and proved it as a cardioprotective. In addition to this, genistein, glycorrhizin, isoflavones, phytosterols, flavonoids, limonene, pectin, stibulin, these are also identified from natural source which are working for cardioprotectiveness. Anti-diabetic nutraceuticals such as isoflavones, docosahexaenoic acid, omega-3 acids, lipoic acid, dietary fiber, magnesium, chromium, calcium, and vitamin D have found to possess anti-diabetic activities. Other nutraceuticals include polysaccharides such as beta-glucan, polyphenols, flavonoids, also helps in reducing the diabetes. Now, these nutraceuticals are present in most of the food ingredients with varying concentration. The concentration, time, and duration of supply of nutraceuticals to the human beings influence the human health. Manipulating the foods, the concentration of active ingredients can be increased or decreased. Diet rich in nutraceuticals along with regular exercise, stress reduction, and maintenance of healthy body weight will maximize health and reduce disease risk. Now, this is the role of researcher. Like most of the scientists, academicians are participating, identifying all these nutraceuticals from various sources. Now, what is the role of industry now? Now, the nutraceuticals are ready for introduction into the food matrix. Most of the time, industries are accepting or taking technology at the matured stage. This is what just my view. I just would like to point out that the commercialization has just with the researcher activity will not come into the market. So researchers could participate in the feasibility studies in collaboration with food industry only will help us. Our nutraceuticals will come into the market. Industries also must participate with the researcher to develop the nutraceutical products. How? The industries are so far is taking a mature technology which is in the form of products. Industries also should show some interest to collaborate from the beginning with the researchers or institutes where they can also support the researcher to identify the best nutraceuticals which are edible, which are going to be having market potential. Encouragement also must come from industries also. Now, what is the regulatory authority says? One best regulatory authority in India is Food Safety Standards Authority of India. It gives guidelines to develop novel foods. The guidelines are mainly involved in chemical composition of engineered food. How the food is developed by using chemical composition from the natural source. Then surface modification, surface chemistry should be disclosed. Primary particle size, like a previous speakers, they have told that they have nano encapsulated nanoparticles. They made nutraceuticals. These things also should be taken care. The solubility of the product. When it comes to the digestibility and the bioavailability, also is one of the criteria before designing and developing the nutraceutical food. and the authority is asking to declare the amount of nanomaterial, if anything, any food product is having, how it is specific, and how much they are adding into the food matrix. And when it's come to the last point, what is the specific claim that we are claiming, whether it is anti-diabetic or cardioprotective or anti-obese, these things should be very specific with the scientific proof. Now, nutraceuticals shall contain any of the following ingredients in the food, that is vitamins and minerals, essential amino acids, list of plants or botanical ingredients, list of probiotics, prebiotics. These things can be called as nutraceutical foods. Now, FSSAI has given guidelines not to use the following ingredients because of lack of scientific data. This is raspberry, ketone, silica, Angelina sinensis, Paulina, Upana, palmetto, not ginseng, chlorella growth factor. These are some of the examples the FSSAI has given not to use and to claim it as a nutraceutical food. Now, my request or opinion that there should be joint venture with the academia, research institute, and industry collaboration would result in fruitful outcome where the nutraceuticals can come into the market, and the researcher also will be benefited by the outcome of his research. He will be motivated to do further. Otherwise, what happens? Like, we publish a paper or we patent a file, we get a number, then our products will be in a shelves only, cold storage. It will not come into the market unless the both parties are agreed and put forward to bring these nutraceuticals into the market. Thank you.
Yeah, Dr. Anand, it was an exciting presentation. So regarding the commercial perspectives of nutraceuticals, so you have covered a number of aspects like nutraceutical classification and sources of nutraceuticals from foods, herbs, and spices, and its health effects and disease-specific nutraceuticals. And finally, you have emphasized the role of industry. So that means industries should come forward, especially for the feasibility studies, because that can be done only in the R&D organizations, and it cannot be directly conducted by the industries. So the nutraceuticals which we are making, as well as the industries are coming forward, can be tested further with respect to the feasibility studies, and that will give authenticity to its health effect. So in that perspective, you have emphasized that industries should come forward with the R&D organizations for the sponsored projects. Yeah, these are very good points, and hope our industries will take it forward. So with this, I wish to thank the Dr. Anand for giving an excellent presentation.
Thank you, sir. Now the next speaker is Dr. Jaydeep. Can I introduce, sir?
Yeah, you can.
Yeah, please, sir.
Yeah. So Dr. Jaydeep is a senior principal scientist, professor ACSR, former head Department of Brain Science Technology, CSIR, CFTRI, Mysore. He's a basically PhD in biochemistry. Since 1999, he is working in CFTRI in various capacities as a senior principal scientist, former head, professor ACSR, industry sponsor, coordinator, several things. He is a committee member of BOS and BOE, chairperson, chairman, member, doctoral advisory committee member, national committees on rice fortification and breakfast in schools. And for his credit, he has received UGC Research Fellowship Award, John Hopkins University Overseas PDF, then IUBMB Indian Institute Award, International Nutrition Foundation and Kraft Foods USA, Visiting Scientist Fellowship, Best Technology Transfer Award, Best R&D Department Award, Oral Presentation and Poster Presentation Awards. He has given more than 50 international and national talks, invited talks in various conferences. He has published more than 50 papers, and to his credit, he has contributed 3 book chapters. He has transferred more than 10 technologies to industry. He has guided 4 PhDs and 5 students are working under him for PhD. And he has guided more than 25 MSc and MTech students, received several awards. And his area of specialization is grains, nutraceuticals, biochemical and health effects of grains, health and wellness foods. And he was former vice president and treasurer of AFSTA and editor of IFI magazine. So with his tremendous and long experience in the field of biochemistry and grain science, so I request Dr. Jaydeep to deliver his talk. Welcome, sir.
Thank you, Anand, for an elaborate and exhaustive biodata. We are coming to the topic. So since we have short of time, so I will try to condense in 15 minutes. So coming to the topic of Bran from rice diversity, a potential source of nutraceuticals. So whenever we hear about rice, what may be coming into our mind is that rice is the soft white material just to satisfy our hunger. Actually, rice is more than that. So rice is actually a nutraceutical bundle, but unfortunately, because of the human desire to have everything fair, white, soft, and smooth, so we subject it to a high degree of milling, and that is resulting in the white starchy endosperm. Coming to the concerns on food and health, so the past 2 days sessions are going on these aspects. So one is one of the reasons for the present day problem is the lifestyle and the stress, and also the hidden hunger. So due to the consumption of refined rice, refined wheat, refined oil, refined sugar, refined salt, everything is refined. So because of that one, we are losing a lot of micronutrients and phytocomponents. So that is responsible for the current day lifestyle disorders like diabetes or hyperlipidemia or the cardiovascular problems and the gastric ulcer and also the cancer. So because of these health concerns, currently there's a lot of interest in the health foods like nutraceuticals, dietary supplements and functional foods or wellness foods. So under that category, the foods demonstrated to improve the state of well-being. So well known is that the green tea, which is rich in epicatechin, then oryzanol rich rice bran oil, and whole grain cereal is also now considered as one of the important functional food. So then what is whole grains? So actually whole grains are the dehusked grains. So for example, it's a paddy, after removal of the husk, we will be having the brown rice with the bran and germ layer. So but during the process, we are removing all these things and we are consuming the starchy endosperm. Similarly, in the case of wheat also, this is the old wheat wherein that bran and germ are there, but unfortunately maida means the starchy material. And with respect to the millets like ragi, so wherein you can see the cross section wherein the seed coat as well as the endosperm. So consumption of food with the bran, germ and endosperm, at least minimum 50 grams daily is reported to reduce the incidence of lifestyle disorder. So why? Because you can see, for example, the nutritional composition of whole grain rice or the brown rice. So wherein you can see a rainbow of nutrients. So like B vitamins and the nutraceuticals like oryzanol, tocotrienols, and macro elements, micro elements. But unfortunately, because of the refining process, we are removing all these colors and finally we are consuming the white starchy material. So that is the problem for the many of the lifestyle disorders. So in this respect, if you see the global efforts to enhance the nutritional quality of grain products, so for example, in USA, they are all the time promoting only the old wheat or fortified wheat flour. So in fact, in India also in the public distribution system, now it is made mandatory that wheat flour should be fortified. Then there is a AACC is there in US. They are also concentrating on promotion of whole grain based food products. And Europe also there is one group called Health Grain Forum. So wherein they are working on the phytocomponents in the oats, maize and barley and such kind of exotic grains. Whereas in the case of rice, people are not concentrating much. Fortunately, in the United Nations has declared the 2004 as the International Year of Rice. And some German scientists have also worked with respect to the genetical modification of rice and development of keratin-rich rice. But as you know, that genetically modified foods are not permitted. So there is now people are looking for the fortified rice. In fact, under the World Food Program, they have been doing the fortified rice. Additionally, in India, also now new techniques with respect to the fortified rice kernel is coming, wherein from 2023. So in the public distribution system, the rice has to be fortified with the vitamins like B vitamins, B12, and folic acid and iron. And coming to the R&D in CFTRI, so the CFTRI as well as the Grain Sensitive Technology Department. So research activities are going on in the rice and millets and pulses with respect to phytocomponents, bioactivity, and functional foods. So coming to the rice diversity, so worldwide previously around 40,000 varieties of rice were there. And in India also is a land wherein that 6,000 different varieties are there. But unfortunately, after the Green Revolution and hybridized rice only is mostly available. Even now, some of the farmers are still holding some native varieties. So around 1,000 varieties are still there, conserved. So this rice diversity can be classified based on the brand color, like red, black, brown, white, and other things, as well as the length and stickiness, like Northeast rice or Japanese rice is considered as sticky, whereas South Indian rice is considered non-sticky. Then aroma, like basmati, jeera rice, and such kind of things. Then medicinal rice, like navara. So like that, diverse varieties of rices there in India. So this is from white rice, red rice. This is also from medicinal rice and black rice and basmati rice. So after removal of the paddy, this is what you are getting is the dehusked rice. This is known as actually the brown rice, wherein you can see the natural brand color with all the phytocomponents. But unfortunately, since our habit of subjecting it to a degree of polishing, so it is ultimately becoming white and everything is going to the bran. So there is a need to utilize the bran. So what is rice bran? Already I have mentioned that is the outermost covering with the bran and germ layer. So this is a scanning electron microscope showing a brown rice with the bran and the germ part. And this after polishing up to 5 to 8%, you will be seeing a white material which is very smooth. That is our rice grain. So this bran is actually a number of phytocomponents are there. Studies have been carried out by us with respect to the phytocomponents in that one. So for example, we've collected the different bran from different varieties like white rice, medicinal red rice, black rice, and red rice. Then analyze for the various nutraceutical components like phenolic acids, flavonoids, anthocyanin, and also the tocopherol, tocotrienol, oryzanol. So this is just an information for the student community who is attending this one. So that what is phenolics and the structures are there, different types of phenolics like non-flavonoids and flavonoids are there. So all of us are familiar with the phenol non-flavonoids like the gallic acid and the caffeic acid, ferulic acid. So these are all come under the nutraceuticals. So coming to flavonoids, that is with more than one phenolic ring structure. So like flavonols, like epicatechin, which is present in the green tea, or the quercetin, which is present in onion, or anthocyanin, which is present in this wine or grapes. So these are all coming under the nutraceuticals. So with respect to the studies in the bran of different varieties, so we found that in the phenolic fraction, so the black rice bran is having high content of stearinic acid, ferulic acid, and whereas in the case of red rice bran, we found another component called catechin is found to be high. So each one is having its own unique antioxidant and health effects, like already I told. So that it depicts the potential of these brands to be further utilized by the industries. So coming to the anthocyanin, so this is the ethanolic extract of the black rice, showing the pink color, wine colored this is solution. So this is actually the anthocyanin, which is found only in the black rice, not in the other rice varieties. So that makes the black rice and its brand unique. So this, for example, this anthocyanin, after further characterization, found to have cyanidin-3 glucoside and pyridine-3 glucoside, and these have been reported to have unique health beneficial effects. And coming to the health effects of phenolics, so phenolics are actually strong in vitro and in vivo antioxidant activities are there. And among the phenolics, anthocyanins is reported to have vasoprotective, anti-inflammatory, and anti-cancer properties have been reported. So that is the reason there is a French paradox. French people are consuming a lot of meat and also the fatty foods. Along with that one, they are consuming the anthocyanin-rich wine. So that is giving the health beneficial effect to the French people. That's known as French paradox. Similarly, the rice bran or the black rice also can be extracted and utilized as a nutraceutical ingredient in the food products. So coming to the next health beneficial nutrient, that's tocopherol, and health beneficial nutraceutical called tocotrienol. So they are all different types based on the saturation of the side chains. And there are exist in different forms like alpha, beta, gamma, and delta forms. So characterization of the different brand has been carried out, and it is found that these are the various tocopherol components, and these are the various tocotrienol components. And we found that the red rice bran is found to be rich in gamma tocotrienol, gamma tocopherol, and alpha tocopherol. So coming to the health effects of vitamin E, so vitamin E as well as the other its classes like tocopherol, tocotrienol is reported to beneficial for prevention of coronary heart disease, Alzheimer's disease, cancer, and especially tocotrienol is of late reported to have a number of anti-cholesterol as well as neuroprotective action, because tocotrienol is not present in many of the food products. Only few grains as well as the palm oil is rich in the tocotrienol. So coming to next major phytocomponent or the nutraceutical present in the rice, it's a gamma oryzanol. Yesterday you had a nice presentation from Ricella. So it is actually rich only in the rice, and the other grains are not having the oryzanol. And as a chemistry, it is having a ferulic acid and it's ester with the triterpene alcohol or sterol. And this is the characteristic spectrum of the oryzanol showing the absorbance maxima 314 to 320. So further characterization by HPLC, it was found that it is major oryzanol components are cycloartinyl ferulate. It is having high antioxidant activity than any other vitamin E components. And 24-methylene cycloartinyl ferulate, it is reported to have high anti-inflammatory properties. Then cambasterol ferulate and the beta-sitosterol ferulate. So these are also reported to have a number of anti-inflammatory properties. And these components were found to be high in the medicinal red varieties. And whereas it was next, the black rice, white rice, and red rice also is having the component. So one important point is, in addition to the pigmented bran, even the white bran is rich in the oryzanol component. So coming to health effects of oryzanol, it's a powerful antioxidant than vitamin E, and is a free radical scavenger, anti-inflammatory in nature, and it prevents atherosclerosis, and it will reduce the plasma cholesterol, and it can prevent skin cancer also. Because of that one, oryzanol is widely used in sunscreens. So coming to a short conclusion regarding the aspects of the potencies of various types of bran. So pigmented bran is dominated in the bioactive components, and among the pigmented, red is having high content of total phenolics, catechin, and vitamin E components, whereas medicinal red is having high oryzanol components, and black is unique to have the anthocyanin component. So coming to the last point of the mechanism of action, okay, so these nutraceuticals are there in different rice bran varieties. So what the role it is playing? So all of you know that many of the current day diseases is basically because of one is oxidant stress, because of the metabolic reactions as well as the environmental pollutions. So that is resulting in the formation of free radicals. So that will attack our plasma membrane and also our proteins and also DNA. So that is responsible for the many of the diseases, cataract, cancer, etc. And then how our antioxidants are playing? These our antioxidants and make the imbalanced lipid radical to normalcy, and it will later get regenerated in our body through this glutathione and ascorbic acid system. So like that, our natural antioxidants which we consume is protecting us from the oxidative stress. So coming to next issue is the lipid metabolism. So nowadays the problem with respect to hyperlipidemia is a major problem. So that is elevated level of cholesterol, elevated level of LDL cholesterol and triglyceride, and reduced HDL cholesterol. So how our grain nutraceutical is controlling the fat metabolism? So one is in the intestinal absorption. So in the intestinal absorption, when there is a competition between the plant sterols and our non-vegetarian cholesterol, plant sterols will get always absorbed and taken to the liver. So in the case of the vegetarians also, we are seeing that a lot of cholesterol issues is there. That itself shows that cholesterol is not only because of the dietary intake, but also because of the liver synthesis. So liver synthesis of the cholesterol is reported to be reduced by the oryzanol components. That is the mechanism of action of cholesterol lowering action of oryzanol as well as the tocotrienols. So coming to the deposition of cholesterol in the arteries, so which is responsible for the atherosclerosis, you can see a normal cross-section of the artery. There is no fat streak. As a result of hypercholesterolemia, it will lead to the deposition, and ultimately it will constrict our artery, and it will lead to the complete closure of our aorta, and it will lead to the cardiovascular problem. So basic reason for this one is actually because of the oxidized LDL. So in the circulating LDL, particles will get attacked this one, and it will get deposited within the artery, and later it will attract the immune slates like macrophages, and finally it will lead to the formation of fatty streaks, and that is exactly the reason for the deposition of the this artery and the cardiac problem. So in that respect, our antioxidants present in the grain bran can protect. And another last aspect is with respect to inflammation. So inflammation is one of the major for the diseases. So inflammation is actually the body mechanism to what is it? The external stimuli such as the damaged cells, pathogens, toxins, oxidative stress. So now all of us are familiar with the viral attack. Actually, that is also is resulting in the what is it? This inflammatory stress. And when inflammatory stress happens in the lungs, it will result in the formation of cytokines, and that is responsible for the formation of cytokine storm, and ultimately the damage to the lung. That is what is happening in the case of our corona. So similarly, other types of chronic inflammation will lead to other diseases like diabetes, Alzheimer's disease, neurological disorder. So now inflammation is considered as one of the greatest risks, and our anti-inflammatory agents, which is present in the bran in the form of nutraceuticals, can protect through arresting the reactioxin species or through preventing the NFKB formation and the subsequent gene expression in the formation of the cytokine genes and the formation of cytokines. And also it will affect the cyclooxygenase pathway and prevent the inflammatory reactions. So then the similar way, if it happens, the inflammatory reactions which is happening in the macrophages, that is actually responsible for the this inflammatory reactions. This is what I told need to be arrested in the case of the viral infections and other things. So in that respect, also studies in our laboratory has shown it has the ability, our rice bran nutraceutical has the ability to reduce the synthesis of interleukins, TNF alpha, and also the expression of the COX-2. So like that, in all aspects, the rice bran phytochemicals are useful with respect to the prevention of the lifestyle disorder. So we can conclude with the statements. So whole grain rice are phytochemical bundles. Indian rice diversity offers wide possibilities for nutraceutical security. Nutraceutical components in bran give health beneficial effects. More R&D need to be undertaken nutraceuticals and bioactive in bran from rice diversity. Through the optimization of technologies, biofunctional ingredients could be made from the bran for health and wellness. So thank you for the patient listening. Thank you. Over to Dr. Anand, please. Dr. Anand, mic to be unmuted.
Yeah. Thank you, Dr. Jaideep, for your informative and elaborative talk on rice varieties, rice bran, health benefits of rice bran, original, all these things. This is we should rethink that how much nutraceuticals we are able to bring into the market. As a researcher, we are spending our whole career to identify some of the nutraceuticals, and it is difficult for us to bring it to the market. So this, as a researcher, I have a strong feeling that the industries should collaborate, sponsor, identify the resources to bring these nutraceuticals into the market. So once again, I thank Dr. Jaydeep for his elaborative and most informative talk on rice brands. Thank you very much. Now over to next speaker, I think, Professor Nagendra. I'm very happy to introduce Professor Nagendra. He has done his BBSc in Animal Husbandry from Rajendra Agriculture University, India. And immediately after his graduation, he has moved to MSc. And he has done MSc from South Dakota University, USA, and PhD from University of Alberta, Canada. Now he has worked in various places. One such is that Victoria University, Australia, from 1991 to 2011. Almost 20 years he worked in various capacities, and he has become a full professor from 2003 to 2011, and has been affiliated with the University of Hong Kong as a tenured professor in food science since 2012 onwards. Sir, I am very happy to introduce that you have published more than 320 articles, 20 book chapters, 220 conferences, abstracts, and 3 books you have contributed. And your area of interest is that dairy products and quality control, probiotics, prebiotics, technology, stability and benefits of human health, and yogurt in health and disease prevention. These are your research areas. Sir, you have given more than 170 keynote addresses and invited presentations in international conferences. And I am happy that you are serving as an editor for several journals and very reputed journals, LWT Food Science and Technology, Associate Editor in JFSTI, and Journal of Probiotics, Prebiotics, and editorial board member for several other journals. And you are listed one of the top 1% list of scholars, and your citations has taken place in Thomson Reuters. ESI has been one of the top 10 highly cited researchers from 2015 to 19. It's a very big achievement, sir. According to Google Scholar, you have received more than 30,000 citations, and with H index of 85. It's one of the good achievement in your career, sir. And you are the fellow of Institute of Food Technologies, fellow of American Dairy Science Association, fellow of Australian Institute of Food Science and Technology. It is my great privilege to introduce you as one of the speakers, sir. With a short time notice, you have accepted our invitation, and you are able to deliver your talk. Now I request you to proceed to deliver your talk. Thank you very much.
Thank you, Dr. Anand. Also wanted to thank the organizers for inviting me. Let me sort this out first. Let me bring my slides. Can you hear me and can you see my
Yes,
slides?
sir. Yes, sir. Yes, you can go ahead.
Thank you.
We are able to see your slides also.
Sorry?
We are able to see your slides also, sir. Go ahead.
Thank you for inviting me and for a very kind introduction, elaborate introduction. The work I'm going to present has been carried out partly in Australia and partly in Hong Kong over the past 2 decades. So I'm going to look at role of cysteine on survival of probiotics and also in improving GABA production by non-proteolytic Lactobacillus brevis. The name has changed. This is called Levi Lactobacillus brevis now in co-culture with Streptococcus thermophilus. It's a very complex work. So let me take you through step by step. So as you know, the viability of probiotics has been a very contentious issue. And we all know that to realize health benefits, we want to have about 10 to the power 6 CFU per gram of the food. However, fermented milks and lactic acid bacteria beverage association in Japan has a requirement of 10 to the power 7. So viability is very crucial for any product in order to achieve health benefits. We have looked at many ways that can affect viability of probiotic microorganisms. For instance, acid and hydrogen peroxide produced by Streptococcus thermophilus and Lactobacillus bulgaricus post acidification after making the product, particularly in yogurt type product, the type of nutrients, growth promoters, the amount of oxygen you have, oxygen permeation after making the product, and many other factors can affect the viability of probiotic microorganisms. We have also looked at the early part of my work in Australia. We also looked at many ways of improving viability. And this is the time when people started to add probiotic microorganisms. And a lot of people didn't know how to add probiotics and how to make them survive for throughout their shelf life. So we looked at many ways of improving their viability, selecting strains, for instance, and also the amount of inoculum, microencapsulation, stress adaptation, ascorbic acid as oxygen scavenger, addition of cysteine. So this is where the cysteine addition idea came from. So I'm going to very briefly look at what happens when we add cysteine. So we had problems with some starter cultures. They were not growing. The probiotics were dying off during 35 days of storage. So what we see here is that once we add cysteine, we obviously reduce redox potential, measured in millivolts. So we can see here, okay, this is, let me move this. Okay, this is control, okay. This is 25, and this is 50, so 250. This is 500 milligram of cysteine being added. So as you can see here, during storage, the pattern had changed. So redox potential reduction hasn't helped here. So they're all positive now, okay? So this is what happens when oxygen permeation takes place during storage. So I don't know whether you can see the numbers here, but this is the survival of Lactobacillus staphylococcus during 35 days of storage in various starter cultures. So we have starter culture 1, 2, 3, 4. I'm not allowed to tell you what microorganisms are there, but as you can see the numbers here, they are 10 to the power 5, and they start to decline. At the end of the storage of 35 days, very few microorganisms are left behind, okay? So let me look at, let me go back. This is the fate of bifidobacteria. As you can see, we have same 4 starter cultures. Bifidobacterium has been added to these starter cultures. I just want to draw your attention to this one here, starter culture number 3, okay? These ones are 10 to the power 5, 10 to the power 5, 10 to the power 5, but this one is just CFU per gram, okay? So initially we had about 700 CFU per gram, dropped down to about 200 CFU per gram, whereas the requirement is 10 power 6. So we had a lot of problems with the company that makes these, had a lot of problems with this starter culture. So you can see here, once we add cysteine, this is 50, this is 250, and this is 500. The viability was quite substantial. The viability of probiotics was in the range of 10 to the power 5, 10 to the power 6. So that was a very big achievement that they were not able to do. The company had about 200 people working with them. They were not able to see what is happening. We were able to find out the reason why there is a decline in the viability and how we can improve the viability. So this work was published, as you can see, as I mentioned to you, the work has been done back in Victoria University when I was working. Viability of yogurt and probiotic bacteria in yogurts made from commercial starter cultures. This was published in International Dairy Journal in 1997. We also wanted to see what sort of ingredients we can add to improve the viability. Again, I don't want to go into details. I haven't got a lot of time in my hand. ingredient supplementation effects on viability of probiotic in yogurt. Again, this was published the following year, Journal of Dairy Science in 1998. So we wanted to see whether WPC and other ingredients that we can add can improve the viability. There was a lot of interest from dairy industries to see how we can improve the viability of probiotic microorganisms. All right, so when I moved to Hong Kong, I developed some interest in GABA. Okay, and as you know, GABA is a non-protein amino acid. It's a major inhibitory neurotransmitter of central nervous system. If you take GABA, okay, there are a lot of benefits. For instance, it can depress elevation of blood pressure. It has anti-hypertensive effect, as I said, anti-anxiety, antidepressant effect, anti-diuretic effect, and so many other benefits. So this is why we developed some interest in this. Particularly fermented foods like Korean kimchi and Chinese pho chai are natural habitat of GABA producing lactic acid bacteria. This is primarily because of the distribution of glutamate and GABA system in these lactic acid bacteria. And this system reduces proton by enzymatic bioconversion of glutamate into GABA. So basically GABA production is a byproduct of this, okay? And this basically contributes to the intracellular pH homeostasis. So the pH of these products will be something like 2.5, 2.4, very low. So unless they have this mechanism, they are not going to have homeostasis, they will all die off. So they will use this mechanism to increase the pH to close to where they can survive, okay? So this glutamic acid decarboxylase catalyzes into conversion of alpha decarboxylation of glutamic acid to produce GABA. And so basically what is happening here, as you can see, the pH here is about 2.5, a lot of hydrogen ions, of course, that is going to reduce the pH to 2.5. GAD enzyme is involved. Here, the pH is something like about 4.2. Of course, glutamate is needed. With the help of GAD enzyme, GABA is produced and CO2 is produced. So we can basically use CO2 as an indicator of GABA producing microorganisms. So here we have a lot of GABA producing lactic acid bacteria, Brevis, for instance, Parachygi. Primarily Lactobacillus brevis is the highest amount of, they produce highest amount of GABA, and they are isolated from kimchi or pho chai as a Chinese fermented product. And in these products, we have a high level of glutamate being added as a flavor enhancer. So obviously it works in their favor to produce GABA. So one thing I have to remind you that when we isolate these microorganisms from plant origin, they are not going to grow in milk. Okay, so the purpose here was to see whether we can make them to grow in milk, force them to grow in milk. Okay, so we have, let me talk about this first. So many Lactobacillus brevis have been isolated from Japanese fermented vegetables to beer, sourdough, and silage, and they lack extracellular enzyme. So this is simply, they don't have proteolytic enzyme. And we have also looked at genomes of some of the Lactobacillus brevis. So simply, they don't have any extracellular enzyme. They are not going to break down protein. They are not going to grow in milk. End of the story. Okay, so how do we make them to grow in milk environment, given the fact that they don't have any proteolytic enzyme? Okay, so I've listed here some high GABA producing Lactobacillus, and primarily Lactobacillus brevis. I didn't want to work on their microorganisms, so I wanted to isolate my own. So considering the role of GAD in pH resistance, LAB with high GAD activity have potential applications as probiotics. And as I said, probiotics can only be effective if they can remain viable as they can pass through the stomach and colonize the intestine. How do we add GABA to products, to food products? Adding synthetic GABA is not allowed in many countries, including Korea. So if you are producing GABA naturally, or if you are producing GABA through lactic acid bacteria, that's allowed. Okay, and for this, glutamic acid is needed. So selection of strains based on high GAD activity is the key. So this one here was published in 2015. Gas release based pre-screening combined with HPLC quantification of efficient selection of high GABA producing lactic acid bacteria. So back in Hong Kong. So basically, briefly what you do is, these things are bothering me. I don't know how to move this one. So basically, you have glutamic acid here, you have GABA here, okay, and you can do the separation and quantification of amino acids by reverse phase HPLC. And when you are doing profiling, when you are running your experiments, so obviously here this is before fermentation, MSG before fermentation. This one is after fermentation. This is the GABA producer. This is a control producing carbon dioxide, and this is the profiling of amino acids. So basically, this you can find out which ones are producing high level of GABA, which ones are not producing high level of GABA. So we had several isolates, and these are all our isolates that we had in our disposal. And we wanted to add MSG and look at the production of GABA during 24, 48, and 72 hours of fermentation. Okay, so basically this is our most favorite one, 145, and this is the one we subjected to complete genome sequencing. We have a lot of information on this microorganism, and produces high level of GABA. So we also wanted to genetically identify these microorganisms, making sure that we are on the right track. So these are some of the strains of L. brevis, these ones here. And if you align them, we have some conserved regions here, then you can basically use to confirm their genetic identity. So basically, we use these primers for GAD gene in L. brevis, 1014 base pair, and this one we use a specific primer for 16S RNA gene in L. brevis, and this had 289 base pair. So basically, what we see here is all these isolates that we had, they had these two genes. Okay, so look at the starter bacteria. So these are the L. brevis. Okay, and these are starter bacteria. They don't have this gene in the starter bacteria. Streptococcus thermophilus as well as Liposomal Delivery. This is again L. brevis. So look at the similarity index. So we had basically about 99%. Some of them had 95, 96% similarity. This is the one we are talking about 99% similarity, L. brevis. And pardon me. So let's look at GABA production in milk by high GABA producers. As I said, they don't produce any proteolytic enzymes, and they will not grow in milk. They will not produce GABA. So that's the end of the story. So here we wanted to see whether we can use lesser Streptococcus thermophilus that can produce some peptides and amino acids, and whether we can induce Lactobacillus brevis to produce GABA in milk, in fermented milk. Okay, so we use several strains of Streptococcus thermophilus and Lactobacillus bulgaricus. This is the Lactobacillus brevis I was talking about, and milk-based medium. We grew L. brevis individually and along with thermophilus, and also with Lactobacillus bulgaricus. So quite interesting study. And let me go back. And we also remember I had to add some MSG in order to produce GABA. Okay, so basically this is what we did. Okay, so we added MSG and grew in 10% skim milk and 24 hours, 37 degrees Celsius for milk samples. We had to do counts of these microorganisms, look at the sequence of glutamic GAD gene. So measuring pH and counts of these microorganisms, the starter bacteria as well as L. brevis, and quantification of GABA and gene expression. Okay, so here we wanted to show that the counts of each dairy starter culture in milk with or without MSG are not significant. Okay, these are the counts of thermophilus, these are counts of Lactobacillus bulgaricus. not significant. Here, if you look at, okay, Lactobacillus brevis in milk, okay, that's milk, that's 145. The pH is about 6.5, 6.6. That's the normal pH of milk. So nothing has changed. Okay, you have a lot of MSG left in the fermented product, and no GABA is being produced. Okay, so as I said, it's not going to ferment milk, not going to produce GABA. This one here, we wanted to look at, this is not fermented milk. We wanted to look at the effect of addition of glucose, galactose, and other sugars. And this is the viable count, and that's the pH. So again, you can see here, pH has not changed with in fermented milk, non-fermented milk, and milk. So nothing changes. Doesn't grow, doesn't like to grow in milk. Okay. So here again, what we see here is that the pH is about 4.5 when we add Streptococcus thermophilus. So this one has brevis and thermophilus. You can see here the pH is very close to that of yogurt, final product about 4.5. So obviously we were able to bring the pH to 4.5, but brevis again by itself will not grow.
Excuse me, Professor Shan, excuse me. Could you another 5 minutes?
Give me a few more minutes, okay?
Okay, thank you.
Okay, all right. So here again, just no MSG added 2 grams per liter. pH is quite low, close to that of yogurt. And you can see some of them, especially thermophilus and brevis, has produced quite substantial amount of GABA. Okay, here no GABA is detected. So quite interesting. Adding thermophilus does the magic. Okay, so if you add vulgaricus, again here no supplementation of MSG. Here 2 grams per liter. pH is quite low when you add vulgaricus. Okay, but hardly any GABA is being produced. Okay. When you add both thermophilus and vulgaricus, this is without supplementation. This is with MSG. Again, not much MSG GABA is being produced. Okay. So basically, this is the viability of L. brevis with and without supplementation. If you look at the table here, some of them has produced quite substantial amount of GABA here when you add thermophilus. This is thermophilus, and this is brevis. And once again, that's another thermophilus, quite substantial. Not much GABA is being produced. This is another strand, and again, quite substantial amount of GABA is being produced. Look at the GAD-A and GAD-B M RNA level. So obviously, GAD-A has been stimulated. This one was published in scientific reports, I think 2015. Daily Streptococcus thermophilus improves cell viability of Lactobacillus brevis and GABA GABA biosynthesis ability in milk. Okay. We also found that when you add a Streptococcus thermophilus, that can activate glutamate decarboxylate gene in Lactobacillus brevis to improve the GABA production. Okay, now we had to look at what sort of amino acids are being released, what sort of amino acids are being consumed. A very thorough work. You can see here, comparative peptidomic and metatranscriptomic analysis reveal improved GABA production. Machinery in Lactobacillus brevis, co-cultured with the Streptococcus thermophilus. This is the strain of the thermophilus during milk fermentation. So very thorough study. We precisely has to map out what peptides are being released, what peptides are being consumed with or without thermophilus, with or without vulgaricus. Okay, so let's look at the role of cysteine in GABA production. So we chose to work with cysteine out of 21 amino acids in improving GABA production. And we can see here that cysteine has improved GABA production by L. brevis when co-cultured with the Streptococcus thermophilus and to some extent with Lactobacillus vulgaricus. So these are the peptides, peptide numbers, okay? And these are the percentage of peptides of this one, alpha casein and beta casein and all those caseins. So So you can see quite elaborate study. Okay, look at this one here. Okay, so I just wanted to take you through this table. It's very complex. Now remember, we didn't want to have a lot of residual MSG in the product. It doesn't give you very good flavor. So the goal here was to make sure that we have very little or no MSG left. And look at this one here. 145 is the brevis. This is Thermophilus, and a lot of MSG is left behind. Some GABA is being produced. As we add cysteine here, you can see most of the MSG has been consumed, and a huge amount of GABA is being produced. So quite interesting role cysteine is playing when we add into the medium. Okay, and look at the cysteine also protects L. brevis from oxidative damage from H2O2. So obviously H2O is going to kill them. So here we have 145 L. brevis. This is MSG. That's with cysteine. And that's with catalase. Catalase, of course, is going to break down hydrogen peroxide. And here with cysteine, and this is with hydrogen peroxide. So obviously you're going to kill them. And you don't see any colonies here. Here you see plenty of colonies there. So what we found is that cysteine was successfully selected from 21 amino acids to improve GABA production. Cysteine protected L. brevis from oxidative damage. Cysteine also accelerated glucose consumption and GABA production by L. brevis. Cysteine promoted long-chain fatty acid synthesis in L. brevis. Cysteine was involved in glucose-based fatty acid-mediated GABA synthesis, and also was successfully applied in fermenting GABA-rich milk with minimal MSG. Cysteine also improved GABA production by L. brevis, co-cultured with S. Thermophilus and L. vulgaricus. I didn't show you this data. Okay, this is going to be published soon, has been accepted in Journal of Dairy Science, the role of cysteine in the improvement of GABA production by non-proteolytic Lactobacillus brevis in co-culture with Staphylococcus thermophilus. So probably next month is going to appear. So the work started in 1997 and going to finish in 2022. Okay, so I'm just going to conclude my presentation that cysteine improved viability of certain probiotic bacteria. Two GAD genes were identified in L. brevis. Dairy Streptococcus thermophilus improved the viability of L. brevis. Thermophilus metabolized more glutamate supplemented with supplemented milk than L. vulgaricus. Certain S. thermophilus improved GABA yield from L. brevis. Certain S. thermophilus strains enhanced GAD-A mRNA gene level in Lactobacillus brevis. With this, I thank you for listening to my presentation.
Thank you, Professor Nagendra.
Dr. Anand?
Yeah, thank you, Professor Nagendra, for your elaborative talk on production of GABA using cysteine and other bacterial species, which is very much important for the society. With your excellent information, our students group as well as scientists will get a new ideas. I hope this information will reach to all corners of the world of food scientists and technologists to improve the products. Thank you very much. Now, once again, I thank all the speakers, Dr. Jaideep, Dr. Sablani, Dr. Nagendra Shah, and sponsors for this program is Raisella Health Foods, Ludhiana, and organizers and co-organizers of this session, and overall AFST. Thank once again Dr. Vikas Singh Chauhan, Dr. Naveen, Dr. Sethi, for providing me opportunity to share my knowledge as well as to chair this session. Thank you very much once again to everyone.
Thank you.
Thank you all. This session is ending. We are closing. Thank you.
Good afternoon, Dr. Chaurasia. I think we should start the session.
Sure, madam. Okay. Good afternoon, madam.
So welcome everyone. Thank you for joining us for ICFOST conference and this technical session number 13. This technical session is on sub-theme that is novel, emerging and adaptable food processing technologies. I am Dr. Anupma Singh, co-chair of this session. So for this session, we have talented panel of speakers, 3 speakers, Dr. Manoj Kumar Chaurasia. He's from Krishi Vishwavidyalaya, West Bengal. The second speaker, myself, I'm from NIFTM. The third speaker, Dr. Amrit Barandas, he's from Tejpur University. The session is being chaired by Dr. M.K. Chaurasia and co-chaired by myself. So it's my honor and privilege to introduce our chair. Dr. Manoj Kumar Chaurasia, currently he is professor and head at the Department of Food Engineering, Faculty of Agricultural Engineering, BCKVV, Mohanpur, Nadia. He is PhD from IIT Kharagpur and BTech MTech from IIT Kharagpur and Jabalpur. He's having professional experience as a 24 years and has been a member for different committees as an external expert for central and state government committees, and also handled many research projects as a PI and co-PI. He has invited talks in the conference, 5 invited talks, and he has 34 papers published to his credit. And his area of specialization is computational fluid dynamics, food refrigeration, and cold storage. So today he is going to present on the topic applications of computational fluid dynamics, technique in design, operation, and management of cold chain facilities. So without wasting time, I invite Dr. Chaurasia on the board and share his knowledge with us. So Dr. Chaurasia, please.
Okay, thank you, madam. As a chairman, it's now my responsibility also to introduce our co-chair. So it's Dr. Anupma Singh, who is I am very much happy to introduce her because she is wearing many crowns on her head. She is the international fellowship of many organizations. Presently, she is serving as the Dean PG Studies, and she is also the head of the Department of Food Engineering in the NIFTM. She has done her PhD in the process of food engineering and has a wide experience of around 28 years. And in that, she is also a fellow of National Fellow and Norman Fellow, and delivered around 59 talks. 96 papers has been published, and also the 10 books she has written. She has filed 2 patents and guided 29 MTechs and 4 PhD students. And is area specialization processing and food engineering. So I'm very happy, and she's a very talented. She's senior to me, so I should not say many things about her because biodata itself is very enriched. It speaks a okay, madam. So it's all about that. Hello. Yeah, madam.
Yes, sir, you're audible. So thank you so much for a nice introduction. And I invite you to share your experiences and knowledge with us. So by sharing your presentation. So you may start now. So let me say that each speakers will be given a time slot of 15 to 20 minutes. We are already running short in time. So within 15 to 20 minutes, you can summarize your work and share your experiences. Thank you.
I will try to summarize in 15 minutes, and last 5 minutes video I will just have it for the discussion. If there
for
is
discussion. Right. Okay. Please continue.
So the slides are visible to everyone?
Yes, sir.
Can you see the slides, please?
Yes, Dr. Visible.
Okay. Thank you very much. I'm thankful to the organizing committee who has given me an opportunity to just interact with so many scientists and persons. just to share my inventions or whatever I have done in the last 20 years. So just giving a brief of that. So today's this topic is mainly under the session of novel, emerging and adaptable food processing technologies. And this the topic which I have selected is applications of computational fluid dynamics technique in design, operation and management of the cold chain facilities. So it's a we have heard and we have read in the various newspapers almost every day. We are this is coming to our notice that India is having a huge wastage of the agriculture commodities, and mainly there is a lack of the infrastructure facility in the agri-allied sectors. So there are some of the sectors I have highlighted here. Those are generally called the agri-allied sectors. And the purpose of all these sectors is mainly to bring the product from farm to the place of the consumption. Okay, so that is the main function of the different agri-allied sectors, and these includes your supply chain services, warehouses, silos, packhouses, sorting grading units, cold chain, primary processing centers, and ripening chambers. Now, in all these type of the your agri-allied sectors, I have just selected the cold chain for the today discussion, and that too some additional that is how we can improve the cold chain facilities by introducing it or by applying a novel technique, that is more or less mathematical simulation techniques, to just address some of the problems. And what are the flip sides of this agri-allied sectors are mainly there, because agriculture products mainly they are the fruits and vegetables and other like milk and meat, they are the very much perishable in the nature. Okay, and we have heard that because of a lack of adequate post-harvest management, there's a huge wastage, and that we have also seen the glut and shortage of the agriculture produce from time to time, especially for the onion and potato. Sometimes you will find the price of the potato will just they are throwing in the on the roads, or in the they are just disposing in the Ganga river, and sometimes the price are touching the 40-45 rupees per kg. The same thing with the onion. So this all happens because of lack of efficient storage and marketing infrastructure for these perishable products, and that are the missing linkage in the supply chain management. So to cope up with this problem, this cold chain is found to be a play a very crucial role. So cold chain is nothing but it is actually basically we are having a full-fledged supply chain. Now in that supply chain, if somehow we can maintain or control the temperature or humidity conditions throughout that supply chain, then it will become a cold chain logistic. Okay, and that include the different stages are there, which are the part of the which will constitute a cold chain logistic. They are the at the farm, like pre-cooling and this procurement, then the transport from the farm to the temporary storage or long-term storage, that has to be done by refrigerated trucks, cargo or railway wagons, then storage in the refrigerated warehouses like cold storage, then again transport from the cold storage to the market. So throughout this movement, we have to precisely maintain the temperature and humidity conditions around the product. Then at the end of this, at the end point of this cold chain and then the supply chain, we can get a very you can say this product which is more or less just like we can say farm fresh product, because we are all interested.
Excuse me, Daksab, can you put it on display mode, that your slides?
No, slides are not changing.
No, it's display mode, so that font size and everything is appearing very small.
No, it is the display that mode.
Okay, but your video is
actually in the presentation mode is there.
Yeah, presentation mode it should be. You can switch off your video, and that could be on the whole screen.
Sure.
Yeah.
Okay. Is it
No,
larger slides?
it's still not in presentation mode.
In the sharing. Shall I send it to the organizer or somebody that can you help me? No, it is in the presentation mode.
Yeah, here only.
Presentation.
Presentation.
Hello, sir.
Yes, please.
Sir, right bottom, there is a presentation mode.
This is not appearing on the whole screen.
Sir, please allow me.
Just a minute. So shall I send this PPT to email?
Sir, click over there only. Hello, sir.
Yes, please.
Don't close it. Just allow me remote control.
Pardon?
Just allow me to control your screen, sir.
Okay. Oh, just I'm slow. Approve. Shall I approve it?
Yes, sir. Approve it.
Okay.
Hello.
Hello.
Sir, please stop the screen sharing and then again share screen.
Okay. Again, shall I share it?
Yes, please share it.
Is it okay?
Yes, sir. It is visible now.
Okay.
Hello, sir.
Yes, please. Hello.
Please start your lecture, sir.
Okay. So let it. Okay. So I'm just summarizing the cold chain concept briefly in the 4 points. Especially the purpose of this cold chain is just to reduce or just to minimize the further deterioration of the product quality within the acceptable limit, and that is done by the maintenance of the prescribed storage conditions like temperature, humidity, and circulation around the product. And certainly for the maintenance of these conditions, we require a very efficient, operated, and well-designed efficient system. Next, please. At present, this cold chain sector is striving with the 2 types of the problem, and these are the high energy consumption and product losses beyond the permissible limits. So because of these 2 problems, the cold chain concept is not getting the wide acceptability or popularity in the India. Okay, so there is immediate issue to discuss all these things. And as far as these two problems are concerned, so I'm just giving a brief that what happens due to this. So these losses which we can talk about this, these are mainly the rotting, cold injury, weight loss, sprouting, and nutritive value degradation. So these are the form of the losses. And one thing that has been that I have been found it that the problem of the energy consumption and losses, these are not the isolated problems. Actually, these are the interlinked problems. If you are having the problem of one energy consumption, then certainly it will also have a problem of the losses and vice versa. And that is because these are related with the interaction among the four main parameters like storage air temperature, relative humidity, velocity, and the product temperature. So these four conditions are ultimately you're affecting or deciding the fate of the product throughout the storage. And these four conditions mainly depends upon the various parameters, though you can say the operating as well as the your geometric parameters of the facility, like stack size, arrangement, density, area available for the heat transfer, and many other like this. And because these ultimately all these parameters is affecting the mechanism of heat and mass transfer process. Whatever we are maintaining in the storage facility, all those depends upon the heat and mass transfer process, which happens within the storage facility. Now, whether it is the cold storage or your refrigerated transport or even a small pack house facility, whatever may be there. So, in all these type of a facility, the heat and mass transfer within that storage facility plays a very important role. Next, please. So, the possible solution is quite obvious. That certainly we have to we should have a precise control and measurement over the air flow, temperature, and moisture throughout the storage facilities. So if we can have a precise availability of this data, then certainly we will be able to identify the problems or lacunas in the existing cold chain facility by analysis of this data. Okay, and once we can analyze that data, then we can optimize about the storage conditions. So our main aim is that is the solutions behind all these problems is there the analysis and collection of the data. That is the main challenge. Okay, next. So, as a solution approach to get this data and analysis part, we are having the two techniques. First is either by experimentation or by the mathematical simulation. So, experimental techniques certainly will be very much time consuming and costly also because it's very difficult. The industry will not allow you to do so many experiments when they are storing the product, and also at least during the refrigerated transport transit facility, when you are transporting the material from one place to other place, it will be difficult to get the you can say this reliable data on the temperature and humidity. Okay, so certainly the another alternative left is the mathematical simulation, by using which you can predict the temperature or the product at different stages. So as far as the mathematical simulation is concerned, there are the three obvious, the well-known techniques are there, like finite difference, finite element, and finite volume. So this computational fluid dynamics techniques is mainly on the finite volume based technology. Okay, mathematical. Next, please. I'm just giving a very brief idea of this computational fluid dynamics, what it is there. Basically, it is the art replacing the integrals of partial derivatives. Okay. And there are many commercial packages are available. So actually earlier, whenever you are applying any mathematical simulation, you have to write your own code. So that was a quite cumbersome and time consuming. But nowadays, various commercial codes are available. Using those codes, you can do your simulation. Okay. So in the simulation, that is called the CFD tool. CFD tools are called all these facilities, and the packages are called the CFD tools. So this CFD tools can be applied for 2-dimensional or 3-dimensional. Both types of the geometries can be used, and for the all types of the flow, compressible flow, steady state, transient, and Newtonian, non-Newtonian, laminar, turbulent. For any type of a flow, they are applicable. And here you can also do the both types of the heat transfer, whether it is the natural or forced or the coupled. Okay. Along with this transport, you can also do the analysis for the chemical species mixing and reaction. Suppose if there is any reaction taking place during the storage, like the color change, sugar change, and many other which are chemical changes or biological changes are occurring, you can simultaneously do all those incorporate the effect of this on the quality of the product. Okay, and also you can incorporate or associate with some your own design or own defined programs with those simulation tools. So ultimately, it's give a very much flexibility, and they say more or less user friendly. These are the tools. You can supply your information and you can attach your required information, and you will get the desired result. Next, please. Okay, I'm just skipping. Next, come to the next. The time is less. Okay, I'm coming to the main application. That means what are the different applications in the cold chain sector where you can apply the computational fluid dynamics techniques. So the very first obvious is that to get an inside view of temperature, humidity, and gaseous composition and air movement in bulk of the product during transient cooling and subsequent storage period. That means you are having a suppose any container. So in that container, during the transient from one place to other place, whatever temperature and humidity changes takes place on gaseous composition takes place, that can be simulated provided you are supplying the precise boundary conditions or the prevailing conditions around that product. That can be mathematically done. Second is to identify the loopholes in the design and operation. Suppose there is any problem of the localized your sprouting, rotting, or any type of the problem is there. So those spots of the problem like hot spot, cold spot, your rotting spots, all those in a bulk huge size cold storage you can predict by this mathematical simulation techniques. And once you can predict, then you can also investigate the effect of the air velocity, temperature, humidity, and also you can optimize all these storage conditions. Apart from that, you can also investigate or you can also study the effect of the quality of the product. Suppose if the initial quality of the product is not good, it's a raw product, immature product, or if the product is injured, or if the size and shape is different, even that small size, but a small concept you can incorporate in the simulation, and if you get the effect over the storage ability of the product. Next, please. And one more thing, actually, what I have observed here till now in the India, we have not much concentrating on the design of the package. As far as this cold chain sector is concerned, we are storing our grapes and many other products in a simple cartons which are available in the market. But as far as when you are storing these, you are bringing those cartons to the cold storage, it should have a well-designed vent holes so that it should get a sufficient amount of air flow through the product. And one more thing is there, it's not only the velocity of the air, magnitude of the air, the direction of air is also very important as far as the quality of the product and energy consumption aspects are concerned. So you can design the vent holes by the simulation, and you can find the best direction of the product with respect to the airflow. So ultimately, you can also design or optimize the stack dimensions, stacking arrangement, gap between the stacks. All those parameters can be simulated. Next is that you can also regulate the refrigeration cooling. That you can control the cooling. That if whether the product has to be suppose if you want to cool your product in 4 hours, then what should be the refrigeration load required and what should be the conditions here? The reverse calculation, the reverse simulation, you can do it. Okay. Earlier we are doing the applying some conditions and getting the product, get it cooled down. Now, if you want to cool the product in a certain period of time, then what are the prescribed conditions which has to be maintained? What should be the size of the refrigeration facility? That also can be calculated. And you can also do the necessary arrangements in the orientation and design of the fans and other air circulation devices which are used in the cold chain facility. And next is you can also simulate what are the different conditions of the temperature and humidity which will lead to the deterioration of the product. Okay, so if you know that without doing any experimentation, you are able to simulate the conditions which may lead to the deterioration of the product. Okay. So you need to do experimentation, but before that you can get some idea about that particular. Suppose this temperature for this one period of time is detrimental to the product, so this can be simulated. And at the last, you will be able to design a new refrigerator transport facility and storage facility by using this computational fluid dynamics techniques. Next, please. I'm just giving you a brief one example that you can say this how this technique was applied in a potato cold storage for the to predict the temperature and the profile. So I have just shown you one vertical cross-sectional view of the cold storage, potato cold storage. So at the top, you can find some fans, cooling coils, and there are the potato stacks are there. You will find the 3 vertical heights of the potato racks are there. Okay, and above that, there is the fans are there, and you can find a small holes. These are the cooling coils. Those are also called the evaporator coils. So this whole cold storage chamber simulation has been done at a time. Okay, next please. Okay. Now, in that simulation, in that cold storage, how the airflow will be there. So you can just calculate the magnitude as well as the direction. And the left-hand side, you can see the color. So the blue color is the 0 and the red is the 3.5 meter per second. So throughout the cold storage chamber, along the height, from the bottom to the top, what is the prevailing velocity and its direction? Because as I told you, that it's not only the velocity, magnitude. The direction of the airflow is also playing a very important role, because in the cold storage, we are storing the product at a far away from the cooling coil. Okay, and the transfer of heat between the product and your reference system takes place by virtue of the movement of the air. So if the air is moving properly around the product, and there is a continuous cycle or loop between the reference system and the product, then we can say our product, this cold storage will run efficiently and will consume the minimum energy. So direction of air is also equally important. So by this simulation tool, you will be able to predict the not only the direction magnitude, but also the direction of the airflow in the cold storage chamber. Next, please. So, and these are the velocity values. So you can see that where the velocity is high, where the velocity is less. Again, the same thing. From 0 to 0.3 meter per second is there. So you can also get the idea about the magnitude of the velocity. Next, please. Okay. Now, corresponding to that velocity, how the temperature will prevail at different parts of the cold storage. Okay. So the minimum is that blue is around 0 degree centigrade, and the maximum is around 7 degree centigrade at the storage. Because generally in the potato cold storage, our required temperature is around 2 to 3 degree centigrade. That's around 275 Kelvin. Okay. Now, corresponding to that 275 Kelvin, you will see that somewhere the temperature is remaining around 280 degree Kelvin. That means around 7 degree centigrade. So it's far above than the required temperature. That means it is around 7 degree centigrade, and we require the 2 to 3 degree centigrade. So you can understand from this that certainly in our cold storage, these are our probable points where the product can get deteriorated by the simulation technique. So all the red spots are the problematic spots where you may get the chances of the rotting as well as some other temperature related problem. And if you find any bluish point, then that is the area which is prone to the cold injury, because there the temperature is coming below the 0 degree centigrade. Okay, so you may get a chances of the product may also get freeze. That means the same cold storage, you will have the chances of the product freeze as well as the rotting due to the high temperature. So the range of the complete range of the temperature can be made available. That is a pictorial view of the whole cold storage. That is called the X-ray of the cold storage. You can get it beforehand. Next, please. Next slide, please. Now, corresponding to that temperature, how the relative humidity distribution will be there. So that is also available here. You can see where the blue spots means the humidity is less, and red spots means humidity is high. So if the relative humidity remains low, then there will be more loss of the moisture from the product. So all the blue spots are concerned, it's a matter of the concern, because in these areas your product will lose more amount of the moisture. Next, please. Next slide, please. Okay. So this is the spatial variation of the moisture loss. Let me suppose in a particular cold storage where the moisture losses are occurring maximum, so that is the red spot, and where the moisture losses are minimum, so those are the blue spot. So you can get the locations where the product is more susceptible to the loss of the moisture. Next, please. And the last one, that is the gaseous composition. That means you can also predict the CO2 concentration, oxygen concentration, or concentration of any species throughout the cold storage. That means where the carbon dioxide level is high and where the carbon dioxide level is low. So this also can be predicted. So this I have just given you one example. Okay. Next, please. Next slide, please. The next is the existing design modification. That means I have seen you in that just the previous slide I have shown you that there are some problems of the hot spots were there. Okay, so and the topmost was their existing system where the cooling coils and stacking arrangement was there. Now in that arrangement, I have just incorporated 3 types of the changes. So B, C, and D. There are 3 more, you can say, design modifications, which I have done the simulation technique. So if we change the orientation of these, our cooling coil and stacks within the same chamber or in the same design, if we incorporate some other devices, how the temperature profile and moisture profile can be changed. So that also can be done by CFD. So you can see in the next slide, please. In the next, you can see here that in the design modification, top left was the existing system. So you can see that the red spots were there. Okay. Now, if we make the incorporation, if we just reverse the direction of the stack and cooling coil, then you will see that in the second top right hand side, you will see our red spots have disappeared. Okay, so that means their placement of the cooling coil was wrong. Okay, so if you just change the direction, that is possible only in the new cold storage. So in the if you can put some obstructions there, then by those obstructions you can just change the direction of the airflow, and once you can change the direction of the airflow, you can just eliminate the hot spot from the in the chamber itself. Okay, so last 2 that we bottom right and left, these are the modifications done in the to identify the problems as well as to rectify those problems by the simulation technique itself. Okay, next please. So this is just because the shortage of the time, I could not go in the detail. If you have any further query, you can ask me. Thank you, sir.
If no questions, so let me take this opportunity to thank you, our speaker, for sharing his experiences on this applications of cold food dynamics in cold chain sector. So this is very interesting and very informative topic, especially for me, because this storage has always been a interest research area for me. And especially this technique would be used for assessing the quality of the products during storage, for simulation, for airflow pattern, and for velocity distribution, for isotherms pattern, and that quality of the grain or food, whatever it is in the storage. So thank you so much. And if any question from the audience, so they may put in the question box. So I think let's move to the next. That is my lecture. So should I start? Dr. You can stop the sharing of your presentation.
Yes, ma'am.
Yes, madam. Please.
Okay.
You can go ahead.
So I'm going to start.
Okay.
Slides are visible?
No, ma'am.
Ma'am, your screen is
share screen, and then screen. Then I'm sharing my slides. ICFOST presentation. Is it visible now?
No, ma'am.
Oh, what's the problem? Share screen, and then that screen I have to share, no? So that way I used to present.
Let's select the window that showing that PPT.
This one. Is it? Now is it visible? Is
Yes,
it
ma'am.
visible?
Yes, ma'am.
Okay. Okay. So good afternoon, one and all present here. Before I start, let me take this opportunity to thank to the organizer of this conference for giving me this opportunity to share my work at this platform. So the topic of my presentation is green techniques for retaining stability of natural pigments. So the topic is quite relevant to the sub-theme, that is novel, emerging and adaptable food processing technologies. So let me start. The entire presentation has been divided into 3 segments. So initially, I'm going to quickly cover all these things that comes into our mind, that what are the pigments, what are the factors which affect the pigment stability, and why this pigment stability is important. And then the main section is green techniques to retain the stability. What are those techniques? What are the parameters that need to be studied and to retain the stability? And the last, I'm going to discuss my research work that is quite related to this topic. So the first thing is pigments. What are the pigments? Pigments, basically, these are the natural chemical compounds, and these are synthesized in the plants to form the colors. And because of this presence of the pigments, the color is imparted to leaves, flowers, and fruits. So color, we can say this is one of the most important quality attributes, quality parameters, which affect the consumer's acceptance. Because जो दिखता है वही बिकता है. So because it gives the first impression of food quality.
Madam, excuse me, your slides not getting changed. I think it's the same slides are right.
Is it? Now it's okay?
The same slide, first slide जो आपने दिखाया था वही आ रहा है. It's not getting changed.
Oh. What could be the reason?
Ma'am, slideshow पे कीजिए, ma'am, slideshow. Full screen. Yes, ma'am.
Yeah. Now it's okay?
Yes, ma'am. Yes.
So this is the second slide. Pigments and
Yes,
overview.
Yes, ma'am. This is second.
Fine. So color, that is the indicator of appeal, the first thing. The second thing is, this is important for identification. Identification of what? For indication of the quality and indication of the freshness. Quality and freshness, whenever we go to the market. So the first thing that we see, that is how does it look? Suppose we want to purchase the tomato. So it should be red in color. If it is black in colors, nobody want to buy it. So the color of the food, that is important, and this color is because of pigment. Apart from this, pigments have antioxidative, anti-cancers, and other health benefits. So this is about pigments. Then I'm talking about plant pigments only. So natural pigments, they are plant pigments, and pigments, they can be classified into 2 categories, mainly 2 categories. The first one is based on this structural affinities. That means classified according to the structural classes. For example, tetrapyrols, tetraterpenoids, or quinones. And the second classification, that is based on natural occurrence of the pigments. According to this system, pigments in plant materials, they are classified into chlorophylls, carotenoids, and anthocyanins and betalains. For chlorophylls and carotenoids, we need the solvents which have low polar characteristics. But for anthocyanin and betalains, we need solvents which has high polar characteristics. Chlorophylls, they are oil soluble and they are responsible for green color, of course, for photosynthesis. Carotenoids, they are lipid-soluble pigments. Color varies from red, orange, yellow, color of fruit. Is vegetables, flowers, the color in the fruit, vegetable and flowers, that is because of carotenoids. Anthocyanin, this is the most important plant pigment which belongs to the phenolic compounds, and phenolic compound, that is basically flavonoids. These are water soluble pigments and they are found in flower, fruit and leaves. So anthocyanin, they are characterized by wide range of the color tones varying from orange, red, purple and blue. Betalains, these are water soluble pigments and the color varies from red, purple, yellow, and these are found in fruits, vegetables and flowers. So what are the reasons for loss of pigment stability? As I have told you in the previous slide, see, these pigments, these are very sensitive. So they have very low stability to the environmental conditions, and second, to the physical and chemical factors. Environmental conditions.
Sorry, ma'am. Still, we can't see your presentation mode. So please stop once sharing screen and then again share the screen.
Okay. Voice is audible?
Yes, ma'am.
Okay, then share screen and
then select
again,
the presentation mode.
Select. So I'm selecting the presentation mode. So this is presentation mode. Right. Is it visible?
Not that way.
No, madam, just can you are you changing some slides, because it's showing the second slide, pigments and overview.
Yes. I am changing the slides.
But it's after
I'm
it's
on
always
third
showing the
slide.
same. No, it's the second slide then. Pigments and overview. This we are invisible. I
don't know what is the problem, because simply I am sharing the screen. This is the way I used to present, and this
then madam,
I'm selecting this one.
Madam, then you can do the same thing. Whatever I done, actually, just you hand over your this control to the this person, to the they will do it accordingly. That will be better.
So what I need to do? Approve.
Hello?
Okay, approve. I have approved. Hello? Should I continue? Should I start?
Hello?
Yeah.
Actually, the person they are those who are controlling, they have to say, they should say.
Okay. So I think I'm on the third slide. So should I continue?
No, ma'am, just wait for
Come to this third slide, reason for loss of pigment stability. Is it okay now? Hello?
Hello, ma'am.
Yeah, is it okay now?
Not yet, ma'am. Ma'am, will you please stop the screen sharing?
Okay.
Ma'am, now you please go to the slideshow. Then start from current slide.
Share screen, then slideshow. Is it okay? So this
Yes,
is the
ma'am.
current
Now,
slide. Reasons
yes,
for loss
ma'am.
of, and should I put it in display mode?
Okay, ma'am.
Okay. Is it okay now? Is it okay?
No, ma'am. Not.
What's the problem? This is the way I used to present for.
Ma'am, without going to presentation mode, you can manually select it, these slides only.
Share screen and then presentation. Is it okay?
Yes, ma'am. Don't go to the presentation mode. Just manually select the slides.
Okay. So this is the third slide, reasons for loss of pigment stability. So should I start from here?
Yes, ma'am. You can start.
Okay. So I was discussing the reasons for the loss of stability. Low stability, and this is because of environmental conditions, physical and chemical factors. Environmental conditions, these conditions are faced during processing, consumption and storage. The physical and chemical factors, they are responsible for this losing pigment stability. So they are temperature, relative humidity, pH, light, presence of other enzymes, oxygen, and concentration of the pigments. So these pigments, they are not stable under different environmental shocks like heat, and this stability needs to be improved, shelf life needs to be improved, and so that color stability or pigment stability may be retained. Then why we need to focus on pigment stability? What are the reasons that we should retain the pigment stability? So as I have told you earlier, that pigments, these are very sensitive to heat and environmental conditions, and these are very, very vulnerable compound. So it's very compulsory to encapsulate it. Why? There are 2-3 reasons. Firstly, that mostly what happens that food colorants, that pigments, they are in use, they are in the industry and they are in use, and they are basically derived from minerals and they are diverse in colors, they have vibrancy in colors, and but their consumption, that has very adverse effect on health. Secondly, for better use and application of natural compounds, if we want to replace this synthetic colors, so we want to replace it with natural compounds. So if we would have a better stability, so then application and better use of the natural pigments would be there. Thirdly, as a stable encapsulated product, if this natural pigments are encapsulated, so of course they would be stable, more stable. So as a stable and encapsulated product, that pigments can offer more therapeutic health benefits to the consumer. So for these reasons, that stability studies needs to be done. So there are many techniques for retaining the stability. So they are pre-treatment, addition of chemical reagent, metallic ions, co-pigmentation, drying methods, processing methods, storage. And basically these techniques are suggested to enhance the stability and modify the plant structure. So I'm going to discuss about pre-treatments. Pre-treatment methods, they are divided into 3 groups: physical, chemical, and biological. Under physical group, again, there are green techniques, which I'm going to discuss. Chemicals, acid and alkali, they are proposed to enhance the stability of the pigments, and biological enzymes are used to hydrolyze the cell wall and enhance the extraction efficiency. So what are the extraction methods for retaining the stability? So there are 2 methods, conventional methods and non-conventional methods. Conventional method, these are very much used in the industry, and they are used to extract crude proteins and other bioactive compounds. They are simple, they are inexpensive, they are very, very easy to handle, but they have certain limitations. That limitations that we need more solvent to use, and that lead to environmental issues, that pigment quality is degraded, then they need long extraction time. So all these, because of all these limitations, we go to green techniques, non-conventional techniques. So here I would like to emphasize that whatever be the pre-treatment, whatever be the extraction techniques, the main purpose of these techniques or these methods is to modify the structure of the plant, just to enhance the extraction and to retain the stability. So these are the green pre-treatment techniques which are used for extraction of pigments for retaining the stability. The first is microwave assisted extraction techniques. This technique is very much used for extraction of plant pigments, basically water and oil-based pigments. Because of this microwave radiations, this heating takes place, rapid heating takes place, and this leads to expansion of plant cell structure. When the plant cells are expanded, so what happens? That leads to a rupture of plant cell walls, and that compounds, that cell wall retains the compound including pigments, they easily migrate out, they easily flow out from the cell, which results in enhanced extraction rate. So then comes ultrasound assisted pre-treatment. This is non-thermal technology, and in this ultrasound waves are used. So these ultrasound waves pass through the medium, and these waves create alternative compression and decompression cycles. And because of this alternative compression and decompression cycles, this results in cavitation phenomena. Cavitation phenomena, this is nothing but expansion of bubbles, and these bubbles collapse. And because of this collapse of bubbles, cell wall that is inside the cell constituent that is inside the cell wall, cell material, that is disrupted. And as a result, release of all intracellular compound that comes out, that is extraction efficiency is enhanced. The third one is the pulse assisted pre-treatment. Basically, this is pulse electric field assisted extraction technique. Again, this use short and high voltage electric field. And because of this short and high voltage electric fields, that pore information is induced in the cell wall of the plant material. And this leads to better release of cellular constituents, and extraction efficiency is enhanced. Then comes to supercritical fluid extraction. Supercritical fluid extraction, this again utilizes the supercritical fluids. And supercritical fluids, how it is, how does it work? This fluid, actually, this is produced by when the solvent is subjected to combination of temperature and pressure beyond the critical point. So supercritical fluid in that way possesses high diffusivity, and because of high diffusivity, that cellular constituent comes out, and this extraction efficiency is affected, that is enhanced. Then enzyme assisted treatment. This is non-thermal technology, and here enzymes are used to enhance the extraction of bioactive compounds or these pigments. Enzyme like pectinase, cellulase, hemicellulase, these are used to hydrolyze the cell walls. These cell walls are basically cellulosic cell walls, and these cell walls are hydrolyzed, and which results in a better release of cellular constituents. So enzyme assisted treatment, that's hydrolyzing the cell wall, and again that this coupled with the green technique, so that could affect the extraction efficiency or this quality of the pigments. And apart from this, all these green techniques could be coupled with each other. That microwave could be hello, am I audible? Hello?
Yes, ma'am, you are audible.
Yes, connectivity was showing poor. So because, sorry. So because of all these techniques could be coupled with each other, microwave assisted with ultrasound assisted with pulse electric field, so and enzyme aided, of course. All these green techniques have merits over these conventional techniques. They have short processing time, less consumption, low energy consumption, and they are more flexible and adaptability for different uses. So once the pigment is extracted, so we need to coat the pigment against the adverse conditions. That I have already explained, that light, heat, humidity, O2 and other interactions. So basically emulsification or encapsulation techniques is used for coating the pigments. Encapsulation is nothing but this is a packaging technique that uses thin polymetric coating that forms small particles that are called microcapsules. So these polymers act as a protective film in isolating the core from the wall material and thus avoiding the effect of adverse conditions. So there are many methods which are used for encapsulations, that are spray drying, extrusion, emulsification, co-aeration, melt injection, crystallization, freeze drying, microwave drying. So I'm going to discuss the use of microwave drying for my research work. But encapsulation, that is the most efficient method to protect the pigments from adverse condition. So these are the research gap on the basis of what I have planned my research work. So we have seen that there is a lack of optimized processing techniques for black soybean hull utilization. Black soybean hull that is found in Uttarakhand. So this hull, they consume this black soybean as their staple food. So that hull, how this hull could be utilized, because this is black in color. So there is no work has been reported so far for this. And of course, green techniques for microencapsulations. I'm going to use this technique for microencapsulation. Then very limited research on use of plant-based material for coating of this anthocyanin-based pigments. Based on this, I have planned this work. So the main aim of the study was just to evaluate, to assess the potential of optimum processing conditions for microwave-assisted encapsulated pigment characteristics and its stability during the storage, because that pigment which is extracted from this black soybean hull, that loses its stability with the respect to storage period. So this was the objective of this study. So the entire experiment has been divided into 2 phases. The entire work was carried out in 2 phases. In the first phase, the anthocyanin-based pigment, which was extracted from black soybean, was microencapsulated using coated wall material. For development of coating wall material, we selected plant-based ingredients, and we optimized the ratio of these plant-based ingredients using soya protein isolate and gum arabic. Then design experiments were conducted to see the effect of these parameters on characteristics of these pigments. In the second phase, that applicability of this optimized wall material, that in the first phase that was optimized, so that was checked, and stability of the micro encapsulated pigment was determined by conducting the storage study. So up to 21 days of storage, we kept this encapsulated pigment, and then changes in total anthocyanin, total phenolic content, and antioxidant activity of microencapsulated pigment were recorded for the assessment of stability parameters. So these were the responses with respect to independent parameters. These were the parameters selected for microencapsulations: coating wall material, then core material, and particle size of the encapsulated pigments. So why we selected these 3 parameters? The choice of this suitable methods and encapsulation.
Dr. Anupma, please, just Dr. Anupma.
Yes, Doctor. Yes.
I think which number slides you are presenting right now?
16.
No, it's showing still 10th. I'm not sure whether everybody is seeing the same or not, because I'm seeing the 10th number slide.
In my screen, it is 16. 16.
Okay, then I don't know
Is it?
Some problem. Okay. Now it's okay. Now it's coming. Okay. Actually, there was some instability in connection of my mind.
I don't
Okay,
know
now it's
what
coming.
happened. What is happening actually?
Okay,
Should I
then
continue?
okay, continue. Please continue.
Okay. So
Yeah,
why
it's
these
continue,
three?
yes,
Why
please.
these three parameters were selected? So the choice of actually suitable methods and encapsulation efficiency, that depends on many factors. Firstly, the type of the core. Type of the core means which pigment it is, whether it is anthocyanin or betalain or carotenoids. So the type of pigment is very important. Secondly, the size of the particle. The size of the particle is important for the diffusion process. And thirdly, the wall material. The wall material is important for release of the core material. For core release, it is important. So correct choice of wall material, that is important as it affects the encapsulation efficiency and stability of the capsules. So it should, whatever be the wall material, it should give maximum protection against the adverse conditions, and it should release the rate which depends upon the interaction of this core and the wall material. So based on these conditions, we selected the parameters. Then constant and dependent parameters, whereas because we took the microwave drying for drying of this encapsulated pigment, so wall material, that was kept as constant, microwave power and drying time was kept as a constant. Then dependent parameters were encapsulation efficiency, total phenolic content, and antioxidant activity, because these characteristics decide the stability of the pigment. So observation, very briefly, I am going to cover all these. The observations were like this, that optimum conditions which were observed for these parameters were encapsulation efficiency that ranged from 74 to 90.5, and phenolic content ranged from 0.34 to 0.40. And similarly, antioxidant activity, there is so much difference between maximum and minimum value, and the condition with respect to independent parameter that has been reported here. And this is the observations during storage studies. So we can clearly see here that there is a big difference between the microcapsules and pigments. So the characteristics, that total anthocyanin retention, total phenolic retention, antioxidant activity. See, for pigment which are not encapsulated, that is 57.58 at the end of the storage period, while for encapsulated pigment, it was 87.45, which clearly indicates that microencapsulation using this microwave drying could retain the stability of the pigment. Similarly, for TPC, and at the days are increasing, that see the stability is going down for this pigment, and for this microcapsule there is a very minimum difference between the stability. So through this graphs, we can see the trend of this stability going down with respect to storage period. But for encapsulated, it is much higher. But for pigments, it is a bit lower than this encapsulated one. So the key findings, the key takeaway is that total anthocyanin content, phenolic content, and antioxidant activity that were found to be 29.9, 8.54, and 7.04. And this is more stable in microencapsulated pigment compared to control sample. So we can easily conclude that, yes, this microwave drying could be used for retaining the stability and for retaining the characteristics of the pigment, and that could be used in the industry if these pigments are encapsulated, and if these pigments are extracted from this soybean hull, so that could replace the synthetic color in the industry, which is being used for this other purpose, coloring this. So that's all for my presentation. So if any questions, so that I welcome. And thank you all for this patience listening.
Thank you, madam, for such a nice presentation and very, very informative one, because nowadays we all are concerned about that fresh. So your topics seems to be very much relevant as far as the freshness and this story is related to that. So I have delivered about the cold chain aspect, and we are talking about the freshness. So the indicator of the freshness is the pigment. So your
Not audible, sir.
Actually, there's some disruption in the connection.
Yes,
Some problem is
yeah,
the
connectivity
internet
issues are
connection.
always there.
So thank you very much. It's a very nice presentation.
Thank you, Dr.
And if audience, they can ask if there is any. So am I?
Yes.
Hello, madam.
Yes.
Hello. Madam,
Yeah,
just can
audible.
you continue because some tech. Okay, so just can you continue with that next speaker, Amit Baran?
Okay. Okay.
I have
So
some issues.
I think we should go ahead and invite our next speaker, that is Dr. Amrit Barendas. So let me take this opportunity to introduce our speaker, Dr. Amit Barendas. He is assistant professor at Tezpur University. He is PhD and having 9 years of professional experiences. He's member of 9 committees, and he has 4 national awards and 1 international award to his credit. He has 8 invited talks. He has delivered 8 invited talks in the conferences, and he has 32 publications in his credit and 1 book chapter, 7 book chapters, 2 patents, 2 technologies developed, and he has guided 21 MTech students and 19 BTech students. So, and his area of specialization is extrusion, food rheology, food gel, and functional food. He's also the editorial board member for 2 journals. So with this, I invite Dr. Das to deliver a talk on his topic, Natural Deep Eutectic Solvents, a tailoring tool for modification and extraction of biomolecules. So welcome, Dr. Das, and I invite you to share your slides and with audience and us. So welcome.
Thank you, ma'am. Thank you, Professor Chaurasia and Professor Anupama Singh, ma'am, for chairing the sessions. And I also thank the organizer to giving me the opportunity. First up, I'd like to ask, my slide is in the slide mode and my voice is okay to all. If we can anyone respond? My slide is visible and it is.
Yeah, your slide is very well visible. No problem. Okay, you may just can you just change 1 or 2 slides so we can be sure that yes, slides are
Sure. Just a minute.
Yeah.
Is it changing?
No. Yeah. Okay. Stop changing. No problem. Okay. Sure. Please continue.
Sure.
Just let's try to.
Yeah, I'll take maximum 10 to 15 minutes, not more than that. So my topic is a natural deep eutectic solvent, a tailoring tool for modification and extraction of biomolecules. Now, why we think about the natural deep eutectic solvent? So eutectic, we know that's a particular point where there is a 2 thing and a melting point is depression is there. 2 molecule behave like a 1 molecule. Why we think about this one? Deep natural thing one? Because now there is a lot of problem with the conventional solvent like methanol, ethanol, acetone. They have a lot of problem. Yes, they have the advantage, but if we think like that, okay, we are eating citric acid and we are using that type of solvent which contain only citric acid. Why not we are thinking like that solvent? Moreover, we are using fructose, we are using citric acid, malic acid. If we develop a solvent with these 2-3 edible sugar or acid, then obviously it will be more acceptable for us. So thereby the natural deep eutectic solvent come into the scenario. So if we see the graph, there is suppose you have a solvent A, a certain fraction is there, solvent B, certain fraction is there. In a high temperature, you mixed it and cooled it down. It will give a transparent liquid type of behavior, and it's behaved like a single solvent. But it has a donor site, it has an acceptor site. So thereby, if we use this solvent in modification or extraction or plasticizing agent in the fruit system, that may be acceptable, though there is a lot of research need to be done because these are new concepts. Now What is the application at present? The natural deep eutaxic solvent at present are in use of extraction of the phytochemicals, especially the pigment, then modification of biomolecules, synthesis of the nanoparticles, plasticizer, and it acts as a catalyst. Generally, initially, the ionic liquid considered as an eutactic solvent behavior. But now the scenario has been changed. People need more natural concepts. So thereby, deep eutactic solvent converted to a natural deep eutactic solvent, which consists with the organic acid, amino acid, sugar. These are all edible components. And it is suggested that there is a very weak interaction like van der Waals interaction or electrostatic interaction between the donor side or the acceptor side. Now, in this presentation, I'll give the two demonstrations we have conducted in our lab. Though there is a lot of demonstration we are going on in this field, but we are giving two examples. One is a modification of high amylose ester using the lactic glucose, lactic fructose, and glycerol citric acid. All are edible compound. And our target is to modify the thermal properties, flow properties, physical property, and textural properties. So just this the composition of this starch, water, starch, glycerol, starch, lactic acid, starch, lactic acid, glucose, starch, citric acid, and we find out that there is a change in the color. Obviously, there is a little bit of change in the color, but you can find out that AV value does not have any change. So generally, it is a transparent one and liquid in behavior. We have find out that native starch give two-state degradation behavior, where when you add the natural deep eutactic solvent, it gives single behavior. You can find out from the figure. It means the bonding structure or internal network in the starch and eutactic solvent has been changed with respect to the water starch solution. If we find out the structure or thermal property like onset temperature, you find out that there is a significant variation on the thermal property. So if we want a thermal stable product, so you can use the citric acid, glycerol, like as it has a has higher thermal stability. So depending on your product characteristic, what type of product you want, it's a thermal stable or you want a little less thermal stable product. Depending on that, you can select your eutactic solvent, natural eutactic solvent. Moreover, if we change the molecular ratio, then also you can change the characteristic of the deep natural eutactic solvent. Next, come to the some effect of the natural eutactic solvent on the starch dispersion. If you could find out that synergistic effect. So generally, in any food product, if we add some starch material or any type of subtle type of material, the main target is to take there should not be any synergistic type of effect. And you find out that if we add this eutactic and starch composition dispersed, you will find out the negligible synergesis, or we can say there is a high free thaw stability. If we talk about the peak force or textural property, you can find out that from the graph, from the table, you can find out that there is a significant variation. It means if we need a little bit of hard texture or hard gel texture, you can use the citric acid glycerol because it has a higher peak force. Whereas if we need a little less type of texture or soft texture in terms of peak force, you can find out that there is you can use lactic acid fructose composition. So it means if we change the composition or if we change the molar ratio, we can we can manipulate, or we can predict the texture, and we can prevent the increase the freeze thaw stability. Now this is some FTR spectra. Just on the first observation, you can find out that that is a simple. If we use the starch one, you will get this type of FTR structure. But if we talk about the B, means B structure, where we have the starch plus natural deep eutactic solvent, you can find out there is a significant variation in the graphical representation. So there is a lot of new bonds is appear in 3428 or 3819. There's a lot of new bonds is there, though they are present in the starch and water, but there is a shift of these new bond, or you can say depression of these peaks. Next, we have did some flow characteristics, and it is find out that Herschel-Berkeley is fitted good with all these components. And if we find out that the flow behavior or flow behavior index is towards the Newtonian, means towards 1. So it means the interaction between the NADs and the starch is such that the flow behavior or the nature of flow is towards the Newtonian behavior. And we have find out that we have yield stress we have determined, and we find out that there is a significant variation. If we want to increase the yield stress, or we want to go for a little harder material, so we can go for the citric acid glucose. You can check that table 130.35. It is the yield stress. And we have also studied the oscillatory rheology. And in the oscillatory rheology, you can, from the graph, you can find out that there is a straight. It means though there is a strong network between the starch and NADs, but this network it's not depend on the oscillation. So they have a viscosity, viscoelastic property. Now another example of the extraction of anthocyanin from the pigmented rice bran or black rice bran, where we have used the 5 type of natural eutactic solvent to extract the anthocyanin from the black rice bran. And in that case, initially we find out that all the 5 natural deep eutactic solvent significantly change the extraction capability or extraction efficiency. And we have find out that highest extraction efficiency have the lactic acid and fructose. So it may be they have the similar polarity, or may have that there is an interaction between anthocyanin and the lactic acid fructose natural eutactic solvent. So from these we have used optimization method, GAN optimization hybrid method, and we have find out optimized condition. And with this optimized condition, we have compared this extraction process with the conventional one. And you can find out from these graph that the ultrasound and eutactic solvent give higher amount of extraction efficiency than the conventional, and then from the natural deep eutactic only. So it means the natural deep eutactic solvent can be an efficient way to extract the phytochemicals from the natural sources. We have also studied the kinetics behavior and diffusivity of that extraction process, and find out that the diffusivity of anthocyanin in the extractant is higher in the ultrasound and natural eutactic extraction process. So it means that if we increase or accelerate the extraction process, we can use this natural eutactic solvent Moreover, the extraction process is efficiently explained by the pseudo second order model. And we have studied the thermodynamics also of that product. And the main impact is that the stability, which is main concern of any food technologies who is dealing with the nutraceutical. And we find out that if we add the natural deep eutactic solvent in the anthocyanin solution, will get more or higher stability. Why we think about the 6 or 90 degrees centigrade? Because 6 in the 6 pH, the anthocyanin converted to a colorless component. So it means we can assume that the degradation is much higher in the 6 pH rather than other pH. And we have considered that at 9 pH, the anthocyanin start breaking in the phenolic acid. So that's why we select these two conditions. So in the 6 pH, you can find out that the stability of the anthocyanin is much higher with respect to water. So it means it may have an hydrocolloidal effect, which have two approaches. It may be reduce the interaction with the water molecule, or it may be reduce the deprotonation of the flavonium content compound which is present in the anthocyanin. So it means that the natural deep eutactic solvent can also increase the stability of any, or specifically anthocyanin, in any solvent. So from these, we can conclude that there is a two approach. Either we can modify using the eutactic solvent, or we can extract any type of bioactive component from any type of biological sources. In this case, we have taken the trial with the high amylose rice starch, and we also taken trial with the anthocyanin. So many more approaches we can add in this process. Thank you from my side. If you have, I acknowledge my student, Vivek Gupta and Rahul Thakur, and other my group members. Thank you. If we have any questions.
So thank you, Dr. Das, for sharing your work. Actually, this was quite similar to my work. Not similar, that is addition to my work, because I have used this natural techniques, green techniques, and for this extraction of pigments. And you are using eutactic solvent, natural solvents, and that shows the effect of these solvent on extraction efficiency and pigment quality. So I was just wondering if we two of us could submit a collaborative project on this. Because so 1 minute. So this role of this eutactic solvents in extraction and natural solvents, so that could be combined with compiled with this green technique. So thank you so much for sharing your work. So I think before wrapping up the session, I invite our chair to summarize the session proceedings. And then if any questions, so audience can put in the question box, and then we will wrap up the session. So Dr. Saab, I invite you to summarize the proceeding of the session.
Thank you, madam. Certainly, as this the theme was just novel technology. So we have at least seen the two types of the novel technologies. One was about the mathematical, that we have seen the both aspects of this. You can say that our research work, mathematical as well as your experimentation, certainly. And in that two different technology, one was the green technology, and that was the computational fluid dynamics technology. And here, as this green technology for your retaining stability of the natural color and pigments, your topic. Amit has given on the natural deep extraction solvents. So certainly these are the two are supplementing to each other topics. So it's certainly we will find a very new innovative techniques in the as far as the quality is concerned, because nowadays we all are concerned about the quality of the food, its freshness and all those things, and because at the end the product, the ultimate fate is to the market. Okay, so yes. Once it is reaching to the market, the quality is the very important criteria, and once we talk about the quality, So obviously that, yes, appearance is the most important, because the person who is going to the market, they are hardly knowing about the physical, chemical and all those. They first see the quality of freshness. Okay. So this, if we combine all three together, when it talks together, certainly we can expect a much better quality of the product and good storage life of the product also. And certainly, actually, I can add one more thing. What I was observing there, this experimentation, all these techniques, actually these also can be modeled by using the computational fluid dynamics technology. Because for suppose you are making any changes, so getting the experimentation and getting the results will take a lot of time. Okay. But once you can formulate a model, and certainly you have to validate it once. At least once, all the mathematical models has to validate it once. So once you can validate that model, then you can investigate to affect the others, effect of other parameters on this color and your texture, and many other associated things can be done. Okay. So I'm just very much get enthused with that two talks, and will help me to just apply. I may also think about, I have got the one new idea where I can apply my techniques. Because I have enlisted many applications, and I can add one more application where these techniques can be applied. Thank you. But if you want, you can also add a little bit more thing about this.
Yeah, just for your presentation, just out of curiosity, I want to ask this. You just told that optimum storage conditions could be established using this computational fluid dynamics. So what could be these parameters that needs to be considered if we want to test this at lab level? So is it possible to apply this dynamics?
Certainly, actually, this main that means the way how we will proceed. We need a physical model. That means suppose you are having an enclosure for any product. Okay, so that product qualities we know, the thermophysical properties we know, shape we know, size we know, and all these parameters we know. Okay, so with this we can feed it as a boundary condition, because in the fluent solver we are solving the 4 or 5 basic equations are there. Those are universal equations. Those are applied or applicable to all branches of the science and engineering. Okay. Now, particular application depends upon the types of the boundary conditions. That means how we are supplying the boundary condition to these the original equations. Accordingly, depending upon the boundary conditions, we can get the desired result. For example, in my case, suppose if you want to study the moisture loss from a tomato. Okay, so skin is the main parameter, barrier.
Yes.
Okay. So skin will form a boundary condition. So if you can just take a mathematical model of the tomato, you can just make a geometry of this spherical or whatever with the geometry.
So firstly, we need to establish the boundary conditions, then accordingly we decide the parameters. Is it?
Yeah. Okay. So in the actually you have to supply your parameter in the form of the boundary conditions and some user-defined functions also. When you can write your own equation.
And if it is a packaged product, then the same thing applies. If it is packaged product. Packaging, for packaging we want to apply this dynamics. The food is packaged.
Okay, so in the food what you can do, you can predict the behavior. That means how much moisture will transfer within that food in 6 months of period of the time, that you can already calculate by supplying the characteristics of the package, because your package will become the boundary conditions now. Quality or the thermophysical properties of the packaging material, that will become the boundary conditions. And that will exchange your moisture, CO2 and air gas both. So you can predict the humidity as well as the gaseous environment both within the packet after the 4 months, 5 months, 3 months. That all they depend, and that too again the different temperature. Suppose you are storing at 5 degree, you will get some other values at the 10 degree again. So all these things, they are you have to just once develop the model. Whole package geometry has to be developed, and once it has to be tested experimentally. That means your model is working finely. That of the other parameters. That means one model has to be established, tested, and then once it is tested, then you can apply it to the other variable conditions.
Okay, fine. So I think this is much more clear to me and everybody. So let's wrap up this session. So before wrapping up this session, so I would like to thank on behalf of this organizers of this society, I would like to thank our chair, Dr. Manoj Kumar Chaurasia, our speakers, Dr. Amit Barandas, for sharing their experiences and making this technical session more fruitful. So thank you once again. And audience, if any questions, so still you can ask, and if no questions, so I think I should conclude here and this take your permission to leave this.
I don't think, madam, there is any further questions. We can just hand
Okay,
over
so
this session to the
yes,
next, because we are already
yes,
running short of the time. So
yes, sir, yes,
thank you
sir.
very much.
So thank you so much. Thank you.
Thank you, ma'am. Thank you.
Thank
you,
you.
sir.
Okay, thank you.
Thank you, Dr. Anand.
No. So it is easy, no? This is not the chemical. Oh.
A very warm welcome to afternoon session today of plenary talks. Hope I am audible. I welcome Dr. K.V. Kale sir, Vice Chancellor, Dr. Baba Saheb Ambedkar Technological University, Lonare, Raigad, Dr. Chindi Vasudevappa sir, Vice Chancellor, NIFTAM, Professor Rekha Singhal, ICT, Mumbai, and Dr. Shashank Joshi sir. Hope I am audible to all of you.
Yes, sir, you are audible.
Okay, shall we start now, sir? Session.
Because she is
There is one announcement. I am told that Dr. Rekha Singhal ma'am wants to present first. So hope it is acceptable to Dr. K.V. Kale sir, Vice Chancellor ji. Hope it is fine, sir. Can we interchange the timing? Professor Kale sir.
Yes, sir.
Okay.
Hello, sir. Dr. Kale sir are not present. They have sent the video lecture. So we can proceed as per your request.
Dr. Kale sir is coming later.
No, sir. They have sent a video lecture only.
Okay. Okay, sir. Thank you. Now it's my honor and pleasure to welcome Professor Rekha Singhal ma'am, Professor and Head Food Engineering and Technology, UDCT. Now it is called ICT Mumbai, and Chairperson of Research Council CSIR CFTTRI, and prestigious fellow of INSA, Indian National Science Academy. Welcome you, ma'am, for this plenary session. Dr. Rekha Singhal, ma'am, her area of expertise includes vast field, including food quality, food chemistry, biopolymers, lipid chemistry and technology, food product development, food processing, fermentation, downstream processing, and biomolecules, to cover some of the topics. She has guided 16 PhD students and over 75 masters, and currently guiding 22 PhD students and 11 masters. She has over 270 international publications, and she has presented in over 100 conference proceedings. She is author of 32 book chapters, and she has been granted 1 patent, and also 3 patents are applied. She is leading several projects, including currently 1 ongoing and 3 completed, and also with the industrial collaboration, she has completed 2 sponsored projects. Her academic qualifications: PhD Technology, then MSc Tech, and she is editor of Journal of Food Science and Technology, Springer, member of editorial board, International Journal of Food Science and Nutrition, member of editorial board, Plant Foods for Human Nutrition, member of selection committee for BARC, and member of expert group in the area of secondary agriculture, Department of Biotechnology, Government of India, member of Board of Study in Microbiology, University of Mumbai, member selection committee appointed by Rashtra Sant Tukoji Maharaj, Nagpur University, University of Mysore, Shivaji University, and Allahabad U University. She is expert to UGC DSA program of University of Mysore, life member of AFSTI, life member of Association of Carbohydrate Chemists and Technologists, to just indicate few of her awards and recognition. With this brief introduction, may I request ma'am to enlighten us on the topic, challenges in the food analysis for ensuring food quality and authenticity. Ma'am, please, I hope you can share it from your side.
I am unable to share it from my end. I'm trying.
May I request Bodhankar team to kindly enable ma'am for sharing.
From our side, we have enabled. They are co-host now.
Can I share it now?
Yes, ma'am, you can share.
I'm not able to share. What do you want to share? Shall I send you the presentation? Can you share it for me, please?
Yes, ma'am, please.
I can do that immediately, no?
Yes, ma'am.
Yeah, because somehow it's not working here.
Shall I tell you our email, ma'am?
Yes, sir. Yeah, 1 minute. I need the email. Yes, sir. Please let me have the email. Hello.
First@gmail.com.
28
No, I'm not getting it.
28.
28, huh? Okay, I got it. 28 ICFOST@gmail.com.
Ma'am, 28 th.
Yes, I got it, sir. I got it. Huh?
ICFOST@gmail.com.
Yes, sir. I received it. I'm just sending it. I'm not writing anything. Please don't mind it. Yeah. Sir, I've sent it.
Bodhankar team, just confirm it, and once you get it, you kindly present it from your side.
Yes, sir, we are checking only.
Apologies for this, but somehow this sharing is not happening from my end. Okay.
Kindly assist me on next slide, ma'am.
Yeah, I'll tell you. Yeah, we'll have to be a little fast.
Yes,
but we will manage it. I have 20 minutes. Am I right?
Yes, ma'am.
Okay, fine. So it's 14:17 and I hope to end it in 20 minutes. So thank you for this opportunity, and the topic of the presentation can be seen on the slide: challenges in food analysis for ensuring food quality and authenticity. Next slide, please. Yeah, we all are aware that food analysis is absolutely mandatory for quality assurance and safety. We are already aware, because as consumers, we need foods which are wholesome, nutritious, microbiologically safe, allergen-free, free from toxicants, and we have a whole range of toxicants ranging from heavy metals to pesticides, hormones, contaminants, and whatnot, migration from packaging materials. We also need them to be free from adulteration, and we do not want any misbranding. So all of these can be met only when there is appropriate food analysis. Please let us go to the next slide. So we have sometimes, if you see, we have many analytical methods for analyzing the same analyte. How do we actually select an analytical method? So we need to be aware of why are we doing the analysis. So what is the purpose? What is the characteristic of the method? And what is the compound or characteristic of interest? So when we talk about all these three things together, we really need to have a specific method to analyze a specific component which is characteristic in a specific food. So we have too many specifics, and that is what makes food analysis in some cases pretty challenging. The next slide, please. So I had actually compiled this for mainly student delegates, if they are there. And these are the type of samples which are typically analyzed in a food quality assurance program. We have raw materials, then we have process control samples, finished products, competitor samples, complaint samples. We know the reason why we do that. For raw materials, for instance, we need to be fully assured of the quality of the ingredients, and they need to meet the right specifications. We need to select suppliers, and if we want to go for any modification in processing, we need to analyze the raw materials. Then we have process control samples. For example, when there is a change in the processing, then we need to really monitor we have to monitor it analytically. Finished products already for meeting the legal requirements, label requirements. Competitor samples mainly for new food product development, so that the new product could be in some ways better than the ones which are existing. And complaint samples to actually address consumer complaints. So these are a whole range of samples which can be analyzed. For paucity of time, I'm not giving examples, but let us go to this criteria. So we have for the choice of analytical method, the inherent properties of the method. For example, is it specific? Is it selective? Is it precise or accurate? What are the what is the applicability of that method to an existing laboratory? We have here sample size, reagent, equipment, cost. For example, if the sample happens to be saffron, even 1 gram is absolutely difficult. Or if you are having a reagent which uses toxic reagents, it may not be applicable. So there are examples could be given for each one, but these are the basic concepts. The usefulness of the method, is it reliable? What is the time required? And above all, is it safe to the analyst? So personnel safety is very important. Next slide, please. Okay. What are the trends and demands that dictate analysis? Obviously, it is the consumers and the industry. So we have three stakeholders: consumers because they expect quality food, industry because they have to select suppliers and they have to deliver the specifications in the form of certificate of analysis, and government regulations for various purposes, and most importantly, nutritional labeling. And of course, GMPs and other voluntary standards which are there, including codex. Next slide, please. Now, this is a very general slide for all the analytes. When we have a sample, the most important criteria is sampling. If the sampling is not done properly, the whole purpose of analysis could be defeated. Then the samples are subjected, particularly food samples, they are susceptible to a whole range of degradation products degradation processes, and they need to be stabilized. After stabilization, we then need to prepare the sample. And in this case, when we talk about preparation, we have to separate the analytes and sometimes even chemically derivatize it so that it can be analyzed either qualitatively or quantitatively. Now, this separation, either directly or after a chemical reaction, is then actually the data is acquired, and then the information is obtained by interpreting it on a receiving system, which is most often a computer system. Yeah, the next slide, please. Now, what are the challenges? Some of the challenges in food analysis, they are of routine nature. For instance, in some cases, like 99% of the analyte could be concentrated in just 1% of the food. And an example here is aflatoxin. The food matrix, sometimes you may not be able to completely extract the analyte, and therefore, there could be under-reporting or under-reporting. In many cases, the analytes undergo a whole range of chemical changes. It could be oxidation, hydrolysis, breakdown, transformation, and many times we again, are not able to get the proper values. Then may not be quantified by an accepted technique. And particularly when it comes to pesticides, it's well known that the degradation products of pesticides are more harmful than the parent compound in a few cases. And when we try to analyze them by a method which is reported for pesticides, our analytical techniques will tell us that the pesticide is gone, but what has happened to them, that many a times we do not really worry about. And then, of course, there are alterations in the sample, as we have seen, microbial spoilage and oxidation, lipid oxidation, enzymes. So these are some of the challenges which we face, and they are all matrix specific. So they need to be prepared as per the food matrix. The next slide, please. There are some more challenges. And, for example, interpersonal and interlaboratory variation. Like if I and you do the analysis, same analysis using the same reagents, everything is same, we may get slightly different values. Or if two laboratories do it, they can report slightly different values. So there are these variations. There is a role of purity of the reagents, the skill of the analyst, the sensitivity of the equipments and instruments. Then sometimes the calculations are done erroneously, and these are blunders. Then another challenge is sometimes, the instruments are not calibrated. There is inadequate and infrequent calibration. And one of the experiences which we have had is when the equipments are shifted from one place to another without proper care, it is really a problem. So it gives inconsistent results and cannot be trusted. The next slide, please. There are other issues in food analysis. So these were what were the conventional ones. The issues which are really our challenges are geographical origin. Then, for example, we get in the trade, international trade, we are getting products from many places. So if we need to understand where is our coffee coming from, is it coming from Brazil? Is it coming from Ivory Coast? Is it coming from Kerala? Where is it coming? So geographical origin, botanical origin. I need to know, as a consumer and even in the trade, what is the botanical origin? And as an example, honey. If I'm eating a product, is it the genuine one or is it genetically modified? Similarly, it is detection of irradiated foods. Yes, we have a label that can show the logo. Yes, this food is irradiated. But if after irradiation that logo is removed, as a consumer, how do I know? Synthetic versus natural. There is a vast difference in price of natural vanillin and synthetic vanillin. And we need to understand how to evaluate this. The compound is the same. Fruit content in jams and squashes as well as in juices. Yes, we have regulatory standards, but do we know whether the fruit has been included at 25% or at 45%? You have to only trust the manufacturer. There are no analytical methods as yet indicated in the regulatory. We have nut contents in mixed minced and chopped nuts. How do I know how much is cashew in it? How much is almond in it? How much is pistachio in it? We don't have this, but these are very practical issues in food analysis. Then we have interspecies adulteration, like basmati rice in non-basmati variety, one variety of meat or wheat in another variety, especially when they are ground. So these are some challenges. Let's see the next slide. And we will try to discuss a few of them. Next one. Yeah, how to find the botanical origin? There are various techniques and there is a lot of research which is possible in this area. I've just listed them. So we have PCR-based methods for herbal teas. You have NIRM, then you have combination of IRMS, which is isotope ratio mass spectrometry. Then we have, melisophenological data, pollen spectra for Raman spectroscopy to find out what is the botanical origin. And then, of course, we have SPME plus GCMS to study the volatiles. Now, which can differentiate the honey from different sources. Like, for example, is it from apple? Is it from cherry? Is it from saffron? And why is this required? This is required because it permits marketing as a monofloral honey rather than a generic honey. So botanical origin identifying is really one of the challenges and a lot of inputs are required. The next slide, please. Similarly, we have botanical origin. Again, the same reasoning as I mentioned. The cocoa butter, from which part of the world have I got it? So this can be done on the basis of fatty acid and triglyceride profile. Similarly, we also have other analysis which are reported in the literature based on pyrolysis and MS, and they can differentiate cocoa butters from different geographical origins. And in particular, we can also go for isotope ratios analysis of 18 oxygen by 16 oxygen. Then we have mineral composition and stable isotope analysis for multi-elements, and there are other markers. So it is possible to detect the geographical origin. Next slide, please. This is important because we can see this country of origin labeling. Many countries are now making it mandatory. And along with these labels, we need to really know whether this is made in Chile or whether it is in US or whether it is in Germany, made in India, made in Spain. So how to really identify that? Therefore, this becomes important. The next slide, please. Genetically modified foods. It's a topic in itself, but since we are talking about challenges, we go ahead. Now, these can be detected either on the basis of proteins or on the basis of DNA. And then, of course, we have biosensors and microarrays. When it comes to protein, the techniques which are well known and which are being used are the Western blot, ELISA, and lateral flow strip. And DNA-based methods are based on PCR, quantitative real-time PCR, and Southern blot. Next slide, please. Detecting irradiated foods. Now, this has been a challenge, and we have had organizations working for years and years together. Yet there are some successes, and some failures too. So people have evaluated histological and physical properties, some changes in the protein constituents based on the use of hydroxyl radical biomarkers or cross-linked proteins that could be formed on irradiation. And amongst the most important technique for detecting irradiated food are the volatile compounds from lipids. And these are basically of three categories. We have long chain hydrocarbons, 2-alkyl cyclobutanones, and cholesterol oxides. Now, these long chain hydrocarbons, the carbons which are actually, they are derived from fatty acids, and they have either one carbon atom or two carbon atom plus one double bond less. Similarly, alkyl cyclobutanones, they have the same number of carbon atoms as the parent fatty acids. So these have been quite useful. And then there are changes in the DNA which have been monitored as thymine glycol, which is a damaged base pair product of DNA, and microelectrophoresis. The next slide, please. We have formation of free radicals. which can be quantified by thermoluminescence, chemiluminescence, and electron spin resonance. And each of these techniques have their own pluses and minuses. For example, in thermoluminescence, low levels can be magnified. Even if the level is low, one can magnify it. It can vary with the food, so matrix effect is there. It is useful for qualitative detection, not much for quantitative. And we have electron spin resonance, which varies depending on from the food, whether it contains bones and shells, and the free radicals which are formed during irradiation are trapped in either stones, pips, or achenes. So these are normally detected. Now, the next one, which I thought is important, is natural versus biosynthetic versus synthetic, biosimilar versus synthetic. Now, we have to remember that the natural products are always much, much more expensive than biosimilars and synthetics, and therefore claims of natural are being made, but the actual molecule used is a synthetic or a biosimilar. Now, these again, as I had mentioned, GCMS with IRMS based on intrinsic ratio of 13 carbon to 12 carbon. Now, once this was established, the adulterators, they keep pace and they overcome this method. They find ways to evade it. And then there were analyses further which were based on 14 carbon. Then we also have differences in isotopes, as an example in benzaldehyde. So the carbon in bitter almond and synthetic or petroleum origin can be differentiated. And in particular, you have site-specific distribution of deuterium, which can actually differentiate these natural, biosimilar, and synthetic. The next slide, please. I was mentioning about fruit content. Now, we know FSSAI standards, we know the standards the world over. And nowhere we can actually check. It is assumed that the industry has added. But there are reports where we can use a profile of organic acids, the anthocyanin patterns, inorganic indicators, in particular potassium and phosphate. We have amino acids, which are naturally present, and to add them externally would be difficult for the industry because they are more expensive. They would rather give the fruit than the amino acid. So in particular, we have proline, and then we have formal titration, ratios. Then there is a parameter of total nitrogen to amino nitrogen. Again, we have stable isotope ratio analysis based on either 18 oxygen or 13 isotope. I'm sorry, it should have been 13 carbon. And then we have carbohydrate analysis, which are very specific for the fruit. For example, sorbitol is found in apples and sorbitol to sugar ratio. Now, also phenolic constituents and pigments. But the most important thing is that we can use this in the raw fruit, but what happens to them on processing, whether these would still be valid. And this is an area where a lot of work would actually be done. The next slide, please. Interspecies food adulteration. Here we have milk, meat, and cereals where this happens. And one can have product-specific techniques. For instance, in the case of meat, we have a whole range of techniques ranging from electrophoretic, immunological, enzyme assays, DNA-based test, and we also have specific peptides and fat analysis. And then we have pentosans and pentoses for detecting soya proteins. So I could go into each one of them in detail, but paucity of time doesn't permit it. So the next slide, please. Yeah, we already know that reports are there, though this is an older one. The recent report had also indicated that about 24 to 25% of foods which are marketed are adulterated or misbranded. Next slide, please. Yeah, and consumers are also afraid because they do not trust. They know that the products could either have bacteria, pesticides, and they are willing to accept less healthy ingredients in food or beverage products to save money. These are 1/3 consumers are there. And almost consumers generally prefer to shop at a farmer's market than a mass merchandiser to avoid this questionable ingredients. This is something which we all know. The next slide, please. Let us come to, food and packaging cannot be separated. If there is food, there has to be packaging. And when we have packaging, there are analysis for packaging materials also. And we have this, I have summarized it in the range of tests that are all done: general testing, mechanical properties, barrier properties, optical, and special properties. So we can see mechanical properties in terms of strength, tensile strength, elongation, heat sealability, barrier properties for mainly water vapor and oxygen, optical properties for transparency, haze, and other special properties, for example, environmental stress, and there are many more. So this is also very important and need to be incorporated in the industry. And they are incorporated, obviously. Next slide, please. But when we are developing new packaging materials, in particular, the biodegradable ones, we have to monitor these parameters. The recent trends are now, for analysis is a combination of genomics, proteomics, metabolomics, and transcriptomics, essentially for evaluating bioactivity and safety, as well as for traceability and quality. So these are big words, big names, big terms, and each of them is a 1 hour lecture. But essentially, all of them can lead us to some information on these aspects. The next slide. Yeah. Now, traceability is a very important concept in modern times. I have given 2 examples, but I will prefer to explain one. Now we can see over here the challenge. You are having a pizza over here and it has multiple ingredients. Now you will see that this pizza which has come has olives coming, which has traveled 5,000 miles, tomatoes which have traveled about 2,900 miles, onions have traveled 3,000 miles, peppers have traveled 750 miles, and you will see mushrooms have traveled 5,000 miles. So you will see that when we receive the product, there are ingredients which have come from different places, and we really need to know what is from where they have come. How do we really understand this? So product price volatility, you will see consumer side, demand side, consumers prefer for whole grain. So whenever we have talk about traceability, we have, can I see the full, I can see the names. How do I come out of it? Yeah. You can see over, no, next, earlier slide, please. You can see that the products flow from producer to processor through distributor, retailer, and to the end user. But when we talk about traceability, the end user, which is the consumer, wants to know from where it has come. So there is a tracing, which is backward traceability, and also there is tracking, which is forward traceability. And for this, we need to have proper analytical methods. Yeah. Next slide. Another important one is analytic electronic nose. And of course, there are electronic tongue now, which are available. Electronic mouth is also available. But talking only about electronic nose, this is a volatile compounds, and the electronic nose mimics what is happening physiologically. So just as we have receptors in our biological nose, in electronic nose, there are sensor arrays. We have olfactory bulbs, and there are pre-processing. And the brain registers it, but in this electronic nose, there is a database, and which is recognized on a computer. And this is how actually one can evaluate it. So there is a lot of similarity, or people have tried to develop electronic noses on the basis of what happens physiologically. And these are improving continuously day by day to give expressions which are as close as possible to the human sense. The next slide, please. This is again an example of lab on the chip. Now, this is very important for a whole range of biochemical assays and chemical applications for separating molecules from mixtures, chemical detection, and biological applications for sensors, drug sensing, and many others. Now here we see this integrates one or several laboratory functions on a single chip of only few millimeters to a few square centimeters in size. And we can see the analysis being done on a microfluidic chip, which is number 3. The sample is introduced, the reagent is introduced, the reaction is taking place on that chip, and there are actuators which are sensing the reaction, which is detected, and finally you are able to the results are displayed. Now, actuators and detectors, obviously, they are powered by electric board and which require a source of power, and which in this case is the battery. So there are a lot of analysis which has come up, and this could be very useful. The next slide, please. I have given this microfluidic devices for food safety, but for paucity of time, just an example. Zearalenone, you can see the device type single linear channel glass. It can detect less than 1 ppb in a baby food, and it is embedded glassy carbon electrode. Another example you can see, ochratoxin. There are 2 channels which are made up of PDMS, and the detection limits are 0.1 and 2 nanogram per ml for beer and red wine. And the other instrument used has integrated silicon photodiodes. So like this, for every target and every device, you can have different LODs and different specifications. And this is again a whole area where there are a lot of challenges and a lot of solutions, both presenting itself. Next slide, please. This is another example which molecularly imprinted polymers in food analysis, very, very specific. And we can see the template. In this case, what is done? MIPs are synthetic materials, and you can see that they have recognition sites which can bind the target molecules even when they are present along with a mixture of other compounds. They are very selective and they are very sensitive. So how it is done? So whatever template we have, whatever we wish to analyze, we along with the monomer, we polymerize it in the presence of a cross-linker. And then that template or that analyte is removed. And we are now having the template without the analyte. And when we bring this in contact with the analyte, it will capture it and you can actually analyze it. So this is very useful for a whole range of analytes. I can't see it, the bottom. Yeah, it is for pesticides, food additives, contaminants, very important, minerals, pesticides, and many more. So this is again an area which is very useful, and we can apply it to our traditional foods. So you can imagine the scope that presents itself. Next slide, please. The other analysis of relevance to food systems, bioavailability assays, toxicological evaluation of new entities, use of aptamers, analysis of stereoisomers and racemic counterparts. And also we have to be very careful because we have to eliminate or at least minimize matrix interferences. Now, these are specific to the food type, and we find that many times they are chemically bound. So composition, texture, and if the analyte is chemically bound, we may get wrong ideas. So these are the challenges which one has to overcome. The next slide, please. There have been a lot of recalls of poor quality products in various parts of the world. Everybody can see the slide as an example. Red plastic pieces in raspberry jam, mayonnaise which was mislabeled in Denmark. And in India, even if it is happening, there is no record because there is hardly any surveillance. But this is just to say that if there is a surveillance, we will detect all these and it can actually protect the consumers. Next slide. This is again an example where eggs were actually 2,50,000, I think 2,50,000, 25,000 eggs, 2,50,000. No, it is 2.5 lakhs. Eggs were recalled and chickens were quarantined. And the reason was the presence of dioxin. Now we don't even, many of us are not even aware of what is dioxin and what is its significance. So slowly it will come. I'm sure it will come. Next slide, please. Local products. Since we are in India, we have to worry about the products which you consume every day. I consume Kaju Katlis, but do I know whether it has cashew? And if it really has cashew, how much? There could be peanuts and it can be marketed as Kaju Katlis. Similarly, we have masala mix of thandai. How do I know how much is the nut content? How do I know whether, the black gram content in idli dosa batters? Or do we have frozen products sold as frozen products like peas and meats? Can we identify the legumes? We have papads from black gram, moong bean, and we have so many other cowpeas. Can we identify whether it is really from those legumes? Can we identify if kesari dal has been put? Similarly, synthetic milk in plant-based milk or in dairy milk, can we identify? There are so many. I mean, if you see around, you will find so many more examples where challenges are there and which require attention from all of us. Next slide, please. That there are many challenges of non-scientific nature. Most importantly, we have a chalta hai attitude, because who is bothered, you know? And we wake up only when there is a tragedy. When somebody is sick, somebody is on a hospital, or somebody has died, only then people try to wake up. That is a harsh reality. There is also lack of critical thinking to use science for local issues and further to seek regulations. And I still believe that we need to have hardcore standards of identity for Indian traditional products. They are non-existent. We see where so many products in so many countries, they do have these standards of identity. Next slide, please. Food quality, safety, and biosecurity. Now we are having computer visions and optical sensors for non-destructive fruit and vegetable quality to detect, so that we can detect it. So if there are any problems. Now it is a good thing if it can happen, because the final product can only be as good as the raw material which is used. I think the next slide and should be the last one. So conclusion, food analysis is not as simple as it appears. Newer techniques keep emerging, and we need to really use artificial intelligence and machine learning to be able to use it for this purpose. There are newer challenges also which keep emerging, and we need to pay attention to our local foods. Monitoring and recalls, which can happen only if there are surveillance, need to be more stringent and organized. We have to develop standards of identity and trained personnel. One of the biggest challenges, and consumer awareness. It should be through responsible media. The word responsible is within parentheses because we do not know whether the media is irresponsible or responsible. So if this can happen, I think there is a possibility. The next slide, please. Thank you very much for your time and attention. I think I have exceeded my time. I'm so sorry. Hello, I'm not able to hear any. It is mute. I cannot hear anyone.
Can you hear me, ma'am?
Yes, now I can hear you, sir.
Yeah.
Now I can.
Yeah, thank you for enlightening the delegates with the most important chapter, which is challenging in the food analysis. I'm sure that the chairperson, which Dr. Bhaskar was originally was supposed to chair this session, but he had some urgent work, office work, and he expressed his inability to join, and he sought the apology from all of you for not being present here. And in absence of him, myself, Dr. Alok Srivastava, is chairing the session. So very rightly, you have included most of those challenges. I'm sure that we will pass on these kind of information to FSSAI, as well as also it will form the part of the recommendation. Many challenges you mentioned about the fruit content in a juice, and then also sampling techniques. Now we are facing another issue. Government is trying to food security or nutrition security. We are trying to promote the FRK, fortified kernels. Yes, but again, the fortified kernels are 1% of the rice. Then when we are analyzing this vitamin B12 or folic acid, obviously challenges, as you mentioned, that 1% of the analyte, 99% of the analyte might be focused or centered in a 1%. So these are the huge challenges, and apart from that, we have to certainly capacity build our network of the lab so that the emerging challenges could be addressed effectively. Thank you, ma'am, for highlighting all those issues.
Thank you very much. Thank you.
Now it's my honor and pleasure to welcome our dear Vice Chancellor, Dr. Chindi Vasudevappa sir. I'm sure that all the audience would be aware, but maybe for the young audience, it is my pleasure to briefly introduce Dr. Vasudevappa sir graduated and postgraduated in fisheries science. And then he did his doctoral degree from Central Marine Fisheries Research Institute, Cochin. And subsequently, he joined as an extension specialist at US, Bangalore, for almost 26 years in various capacity as a senior fisheries scientist and chief scientific officer. And then sir has developed so many technologies under mono and polyculture systems, and also technologies for fish seed rearing and feed, also ornamental fish farming, and established the fish farm at Hebbal in collaboration with L&T in PPP mode. And then operated more than almost, he was instrumental in several of the project, 10 national and 2 international. Sir was a senior executive director and chief executive at NFDDDM, National Fisheries Development Board, Hyderabad, Government of India for 5 years. And then he has introduced very valuable cage culture in India and released several fish species for culture, including Pangasius suchi in India. And then transfer of technologies for several such species. As Dean of Postgraduate Studies in US, Bangalore, Sir was responsible for reforming the PG education. And also he is member of Research Advisory Council for 3 ICAR institutions. And along with that, sir is helping NABI, DBT, BIS, EIA in several capacity. Professor Vasudevappa sir had fellowship, and he got Young Scientist Award and also Best Extension Worker Award, Certificate of Excellence from Global Food Chain Alliance, Danfoss, and Dr. J.S. Pruthi Memorial Award from AIFPA. And then recently, sir was awarded by prestigious Karnataka Rajyotsava Award as Vice Chancellor, first Vice Chancellor of University of Agriculture and Horticulture Sciences, Shimoga, 2014 to 2017. He was responsible for establishing the new university campus as a first Vice Chancellor. And then in Shimoga, under his leadership, 2 rice varieties, 2 groundnut varieties, and 2 castor varieties, 2 onion varieties, and 1 fish varieties. They were all implemented. And then subsequently in July 2017, Sir is leading National Institute of Food Technology, Entrepreneurship and Management, NIFTEM, as a Vice Chancellor. And then he was responsible for also starting and establishing the NIFTEM Technology Incubation and Business Incubation Foundation. And under his leadership, the institution was granted as Institute of National Importance. And sir has about 100 publications, 32 books, and he is member of several professional bodies.
Yeah, I think Alokji enough. Thank you.
Elegant with benefit of the experience. Kindly. Welcome you, sir.
Alokji, thank you very much. And I wish I'm
May I
audible.
request all other members to kindly mute the mic, please.
No,
Everyone else, mute the mic.
Somebody has to sign. Then बाद में हम sign करें. For example,
I hope I am audible.
CCL है.
May I request Udhankar to mute the mic? Udhankar team, yeah, please, sir. Sorry, sir.
Okay. So I hope I am audible, right? Am I
Sir,
audible,
fine, sir.
please?
Yeah, fine, sir. Please.
Okay. Thank you, Alokji, and good afternoon, everybody. I know it's a great pleasure to participate in this very important program of the country. And today, in fact, we are really facing the problems of sustainable and adaptable, innovative food processing technologies. I know we have been blessed, or I would say obsessed with the thermal processing of foods, which has become a major, I would say, a technology for us. But we need to look at how exactly we can really get into other technologies which are of importance, especially from the point of view of course, maintaining the quality and safety. Now, if you look at the whole, I would say the agro-processing industry, probably it is only to add value to the agriculture produce, maybe all through the what you call the value chain, right from maybe the farm to the market. But at the same time, I know we were focusing more on high-tech agriculture or horticulture and things like that, maybe on fish processing, honey processing, cold chain infrastructure, steel silos and warehouses for food grains, with a hope that we will be able to achieve the food security. With service, of course, we are also looking towards the nutritional security. And of course, if you look at the international trade, the share from crops is still high. I would say the processed food is still only trying to gallop, but I think the growth is quite good. I would say that here because we have seen what is the percentage of all these the products which are contributing to the total, and I would say for the processed foods, meats, and of course other meat products, fish and fish products, they're quite contributing, and also milk to a certain extent. But fruits and vegetables, which are mostly the perishables, we are at a very, very low level. And because that is one thing which is very, very important for the country like India, where the horticultural production is galloping, and it is around 320 million tons today. That means we need to address issues related to all the perishables, which I would say is very, very important. And coming to the demographic stand of India in comparison to other countries, probably I know still we eat more than 50% of our food is raw food. So the semi-processed is only about 19%, but I would say that the processed food is, of course, is showing its greater, I would say, participation in terms of it is coming to about 31%, as compared to some of the countries like Germany or maybe China and all that. We are still at a very, very low level of processing. And category-wise, if you look at, probably I know the fruits and vegetables I told you, though the productions are very high, probably we are only at 2 or 2.5%. And cereals and other food grains and oilseeds, they contribute to something like about 40%. But I would say here, it is only the minimal processing or a primary processing. And to a certain extent, we have moved forward with regard to the silo concept and all that. Of course, the packaged foods, of course, especially the products, dairy products, and the breads and bakery confectionaries, I think this is also picking up very well. And in fact, it's around 32%. Dairy is about 15%. And as I said, the beverages, this is another big area. Of course, I know contribute small, but I think now it is picking up. It's around 6%. And the meat and meat products, or the marine or the fish and all that, it's about 5%. But state-wise, if you look at, probably, I think we are in a place, Maharashtra is contributing to something like about 17%, Tamil Nadu followed by Tamil Nadu and Karnataka. I think Uttar Pradesh and of course Gujarat. So other states still they are to further pick up and all that. Probably that is one thing which is very much required. And the market size, if you look at, probably, I think it's about we were at say about 263 billion US dollars in 2000, and by 2025 we are supposed to be at 470 billion US dollars. Statewide share of the food processing industry, if you look at probably, which is an organized sector. And the way I say this, unorganized sector still constitutes more than 75% of the food industry. Out of which, of course, there could be small scale people who are about 30-32%. That is where I think we have to look at, and this is, as I said, see the number of factories and the number of people employed, and GVA, if you look at probably, Andhra Pradesh has a large number of factories, but the employment, if you look at probably Maharashtra and then Uttar Pradesh, and to a certain extent Tamil Nadu, and even Andhra Pradesh, I think they are contributing significantly. Of course, other states are also doing well, but at the same time, it has to be further picking up. And potentials, if you look at probably, I think this is one thing where the processing sector demands and commands huge amount of capital investment. I know the Ministry of Food Processing has come into being, and it has become an independent ministry today, and it is giving a lot of support for establishing mega food parks, which of course did not found to be very successful. But the other projects I think are found to be very successful. Maybe the cold chain projects, and maybe the institutions like both IFPT and NIFTEM, and both of them have become NIFTEM today with an INI status, and the creation of forward and backward linkages, and Pradhan Mantri Krishi Sampada Yojana. There are many schemes under it, including establishment of labs and all that. And probably very recently, we have come up with one PMFME, that is the Prime Minister's Formalization of Micro Entrepreneurs. So that is another big program. And also PLI. PLI is the production-linked incentives, which can be given to maybe encourage the industries to perform better. And in Indian processing industry, if you look at probably, we were more focusing on doubling the farmers' income. Of course, the Dalwai committee has come up with a huge report on how to really attain this through mechanization. And the mechanization was the key word there. In fact, agriculture mechanization has taken up in a very big way. But even then, the percentage is only about 2.8%. Whereas in the livestock, especially, this has really attracted a lot of attention. More than 16.44 million people are engaged in this sector, and 7.9% it is about. And that's where the growth rate is quite good. And so also even in food processing, which was only at a very small level, now it has touched about something like about 5.06%. So coming to the food per se, in fact, I would say we are number one in terms of livestock population in the country, and also maybe in terms of the global share of milk, which again is very, very important. But we are second in many areas. And in fact, of course, I know in fisheries or in fruits, vegetables, cereals, and also with here, in fact, I would say the production levels of fruits and vegetables has gone up from a mere 150 million tons to now it is already about 320 million tons in about 1.5 decades time. So this is where I think, but anyway, we have the big challenge because now there is a huge production, and how do we manage the supply and demand side? That is very, very important. And what is the desired infrastructure, especially to address some of these issues of food processing and value addition, and also reaching the people with quality and safe food. And maybe the formalization of in food processing industry is again becoming very, very important. So proper regulatory environment. I know we do have FSSAI now, and of course the Indian Standard Institute is already there. And in fact, this has been doing a lot of work, of course, with many communities to comply with the international requirements of FDA or European requirements and things like that. But anyway, a lot of further improvements are required. Another very important area is low value exports. I think this is something which is always bothering us because we need, after all, we are part of the agricultural production system. Food processing is part of the agriculture production system. How do we convert that probably into, now we are around 10%. So how do we increase it to say 25 or 30%? That is something which is very, very important. Of course, all this has to happen through a sustainable approach. So we know technologies, if you look at probably, I think we have conventionally, especially the thermal processing has been a mainstay for all of us right from the beginning. Maybe where we spend high energy and probably protein denaturation takes place, which we are still, I would say, we are to recognize that properly, and loss of volatile compounds and decreasing food quality. These are the conventional issues which are through a conventional approach of food processing. Of course, emerging green sustainable technologies we look at, probably we need to really address reducing energy consumption on one side and lowering waste generation. This is very, very important. And minimizing footprints, especially the carbon footprints on the environment, and scale up the recycling and byproducts. This is again another very important area. So probably I think when we are addressing sustainability, life cycle assessment has become very, very important. I know a life cycle assessment always starts with the resources. It has all the links and overlapping links with the whole value chain, or the the links which are there in the food supply chain system. Would be resources right from the point of even seeding to the harvest, and then the processing, and probably manufacturing, and then distribution, and its use by the people, and also of course the end of its life, so the shelf life things and all that. These are all overlapping, but at the same time they need to be addressed both in isolation as well as interdependent thing, and then only probably we will be able to address the quality of the food and the quality of the sustainability of the technology part of it. Of course, I know this is a multidimensional tool to assess the environmental impacts of food products applied to every stage of food chain, right from farm to the fork. I think this is where I think this has become a tool for us to assess the sustainability of the technology. That apart, of course, food supply chain is a set of interdependent entities, as I said earlier. And probably I think we need to look at, at what is the lowest possible cost with which all these, maybe right from maintaining quality, safety, value addition, and all that could be done. So of course, compared to the products and services, by identifying the improvement requiring stages, probably I think the life cycle has to address the various kinds of food products. And this is, of course, again, the life cycle assessment, where we always look at how exactly we can really bring in some sort of a reduction in terms of probably the I would say the pollutants which are really bothering the food industry. So if you look at the North Italy and Sweden, where during tomato ketchup processing system, the emission of sulfur dioxide was observed to be 70 to 90%. So these things have to be brought on as per, of course, ISO 14040. LCA is a scientific method that includes mapping. One is, of course, mapping the food and setting scope and boundaries, collecting data, calculating, evaluating, and interpreting the results for the improvement of the environment. Of course, these are all very important things. Probably here, the goal and scope are becoming very, very important. Maybe the inventory analysis and the impact assessment, and how these things to be interpreted, probably maybe in a complementary assessment or interactive approach, with an interactive approach. So the mitigation measures used to reduce the greenhouse gases, GHG, in the food systems, if you look at, probably there are 4 or 5 6 areas. Non-mobile energy. I think this includes the use of the renewable sources of energy. So how do we do it? Probably a reduction of the global warming potential has to come from fuels by using renewable sources of energy. So of course, mobile energy, again, here we are using for especially tractors, ships, and other things. A lot of these fuels, which are from the mineral sources, but may need to be replaced with maybe hydrogen or electrical engines. And maybe direct greenhouse gases. I think CHGs have become very, very important today, especially nitrous oxide, methane, and refrigerants. How do we reduce the use, and how do we reduce the emission? I think that is becoming very important. Production efficiency, again, reduction of absolutely the global warming potential by proper waste management. This is something which is very, very important. I know we know that more than 30% of the food is wasted. Can we reduce it to even 20%? Even in Europe and USA also, the waste levels are much higher compared to India. So that's where I think we need to look at, because the amount of food that is wasted in India amounts to more than 100,000 crore rupees. So that means it's very important that we need to save our economy as well. And of course, consumption again, avoid using, of course, or less consumption of maybe the eggs or milk, rice and meat, which demand now, or which I would say, which are responsible for, especially the production of these responsible for, I would say, the emissions, direct emissions of GHGs. So, and of course, conservation, of course, 3 R's become very, very important for us. That is, one is the reduce the power usage, or reuse, and also recycle the waste. I think this is something which is very, very important. Coming to the action mechanism of selected non-thermal technologies, which we have been really using it, and probably now we are opening up our eyes for the non-thermal technologies. Could be high pressure processing, or pulsed electric field and cold plasma, ozone, or electrolyzed water. I think these are the new technologies. Still, I would say we are yet to scale it to a commercial level. They are at a pilot scale, and probably or a lab model has been established. And but anyway, a lot of the beneficial effects have been really, probably addressed, or I would say perceived. In fact, the protein unfolding, it's very important in the food when we process it. And I think even the cell lysis and the DNA denaturation should be reduced to the minimum, and shell shrinkage has to be reduced, and cell wall damage has to be removed. So that means these are all the technologies which address issues related to the food safety. Of course, advantages and disadvantages of such of these technologies, if you look at, I know advantages are always that we always claim as scientists that these technologies, they use less energy, and they don't damage the tissue or the cell or the cell wall, or even at the surface and all that. And maybe I think that denaturation of the nutrients doesn't take place, and the volatile, I would say, the flavor compounds are retained and things like that. But even then, I would say that these technologies have their own disadvantages. Coming to the pulse electric field, probably it involves high cost. That is one thing, and of course challenging to use with the conducive materials, and probably ineffective against especially some enzymes and spores. So that means again we are prone to a lot of health risks. So that has to be properly taken care. And the high pressure processing, I know this is one thing which we have been trying to advocate, but still it has also its own limitations. So HPP treatment on meat and fish especially has the possibility of causing release of metal into the tissue. This is something which is very, very bad, may result in a lot of the health or the negative impacts on the health. And also the protein denaturation in certain foods takes place, especially when we use high pressures. So this is something which is also again a very important thing, and can possibly cause structural changes. So this again because of the high pressure. So especially for delicate fruits or vegetables and things like that, the structural changes takes place, means you will not be able to really identify it is this or this product or that product. And that's how I think, even of course the cold plasma, this is something which is always the low equipment and operational cost. That's what we claim, and it's highly reliable. Of course, increases microbiological safety of treated foods. But again, if you look at the disadvantage here, it is not uniform. So surfaces of the food surfaces are not uniform. That's why the effect is not commonly, or I would say uniformly felt across the whole surface of the food. That is the major issue which we are really focusing. And ozone again, of course, is a disinfectant which we all of us know. So low cost and less time, especially for as compared to other technologies, that is always there. Ozone treatment can eliminate organic odors, especially the ones with carbon as their base element. Of course, but if you look at the disadvantage, probably ozone treatment is less effective on fruits as compared to the vegetables. So maybe I think because of the corrugated surface or uneven surface and things like that, and the thick pericarp of fruit makes it difficult for ozone to penetrate. That is the biggest the problem. And that apart, of course, the prolonged ozone treatment can cause changes in, I would say, sensory properties. I know ozone continuous exposure is also not good for health. It may lead to even the cancerous tissue generation. And ozone treatment may produce corresponding ozonization byproducts. This is again another big thing where absolutely we will not be safe as far as the food is concerned. So we need to overcome such of these things probably. And the electrolyzed water, DW, this is something which we are trying to use especially for in CIPs. And where absolutely it is more found to be more effective, especially the usage of a saline solution of electrolyzed water production makes it readily available for procurement. This is one easy thing, of course, but look at the problems and issues which are there with that. Probably EW loses its effectiveness and activity with the evaporation of chlorine in an acidic pH. So that means maybe the inactivation, or I would say sterilization, doesn't really take place well. So the interactions of chlorine with the micronutrients present in the food also causes loss of activity of the electrolyzed water. I think there are a few more things. Probably you have to look at all these things very clearly. Of course, coming to the pulsed electric field, which is done by utilizing less power and are found to be more effective as compared to the conventional treatments. And with regard to the high pressure processing, of course, the cost is always high compared to the thermal processing, and which may be direct or thermal processing treatments. So it's about 1.78 folds. In terms of, I would say, thermal processing indirect. In terms of thermal processing retard treatments, it is about 1.40%, 40 folds. So that means the cost is high anyway, but all the same, it is found to be more eco-friendly, because it is observed that some more efficient, this method is more efficient as compared to thermal processing, and exhibits greater numerical values for all the considered environmental indicators, which have been listed, a large number of environmental indicators. Probably, I think that is one thing which we really look at very seriously. And cold plasma, I know it has been really, especially very efficient to treat dairy and meat effluents. And of course, the untreated effluent was observed to show toxicity affecting the aquatic ecosystem, including, I would say, the Daphnia magna, which is there in the waters, it was killed with 24-hour exposure. And toxicity levels of effluent post-plasma treatment was found to be at maybe, I think, 80 kV if we had used. In 5 to 10 minutes, it was found to reduce the microbial count by 100% and 73% respectively. So these are all things which have the direct, I would say, implications and the advantages. And ozone, as I told already, ozonated water, tap water, and control, when it was compared, in fact, this was done by Chekka et al. In 2021, the global warming potential and acidification potential and the aquatic eutrophic potential were highest during transportation, followed by packaging film. But with the use of ozone water spray treatment, it was observed that carbon dioxide, sulfur dioxide, and PO4 emissions decreased by 45.2%. That means this can really reduce the biological activity of the system and reduce the gases. And of course, electrolyzed water, as I said rightly earlier, so it's more used in CIP cleaning, with where it is found to be 25% cost-wise, 25% lesser than the conventional methods, where we use a lot of, I would say, the sodium hypochlorite and things like that. So that creates some problem which need to be looked at. And to conclude, probably I think these are all emerging technologies reported for sustainability using life cycle assessment. So involving every process from farm to fork. That is where I think the success of these technologies need to be really assessed. These techniques are not only approaches for green concept, but also producing safe foods with the retention of sensory and nutritional properties of the treated food product or a material. And nevertheless, most of the emerging non-thermal technologies are applied either on a lab scale or on a pilot scale. I think the upscaling need to be done. Maybe at least to start with, we can use it at the small scale level where this could be a possibility. And of course, higher cost of non-thermal equipment and electricity consumption induces a higher production cost. This has been the case, and I don't know, but sometimes we need to compromise on these things because quality and safety become paramount important for us compared to the cost of it. Thus, and of course, I know besides for adoption of these technologies by large and small scale food processors, studies on the environmental, socioeconomic effects are needed and which has to be taken up immediately. So probably with this, thank you very much. I think I try to just bring in the novel or the innovative technologies which need to be readdressed by the scientific community, especially the food technologies across the whole country.
Thank you so much, sir. Thank you so much, sir, for highlighting the important emerging technologies and its advantages. I'm sure that all the delegates which are online now through Zoom as well as the YouTube live, they must have got immense benefit because it is important, as you rightly mentioned, sir, any emerging food processing technology, they must ensure the interaction with the environment because then only it can be sustainable and it will have, and they need to consider the life cycle assessment of the process. Thank you again, sir, for highlighting also the government schemes about the food processing through Ministry of Food Processing, sir. Thank you from the ICFOST side, sir. Thank you very much, sir.
Thank you
for your time.
Thank you.
Now, it's our honor and privilege to welcome Dr. Shashank Joshi, sir. I am sure that all the delegates, they are very well aware because Dr. Joshi is household name nowadays. I watch him every day on NDT TV for his very valued and informative insight on the pandemic. And the food fraternity is also aware about Dr. Joshi because last 2018, sir has addressed us in CFTRI in the IFCON, International Food Conference, and his knowledge in the area of food, nutrition, and the health, it was really mesmerizing to all of us. Dr. Joshi, sir, MBBS from Grant Medical College and Sir JJ Hospital, Mumbai, MD from Internal Medicine, King Edward Memorial Hospital and St. Gordhan Das Sundar Das Medical College, DM from Grant Memorial College and Sir JJ Hospital, Mumbai in endocrinology. He is a consulting endocrinologist at Lilavati Hospital, Mumbai. Sir is president of Indian Academy of Diabetes and past president of Research Society for the Study of Diabetes in India and All India Association of Advancing Research in Obesity. Dr. Joshi is also Vice President for Association of Physicians of India. And Dr. Joshi endocrinology research studies has addressed a broad range of topics including diabetes, obesity, thyroids, osteoporosis, and growth. Sir has about 400 publications and visiting faculty to many of the Indian and international universities, emeritus editor for the Journal of Association of Physicians of India, and consultant editor of India Journal of Endocrinology and Metabolism. His special areas of work covers Indian Asian phenotype, thin fat in Indians and comorbidities in hypothyroidism, and also impact of vitamin D deficiencies on bone health and Asian Indians. Sir has authored more than 18 books and several monographs. I'm sure that I would not do justice with Dr. Joshi's contributions in this brief introduction, and I request Dr. Joshi to kindly enlighten us about the topic diabetes remissions, AI-based, generating the evidence-based. Thank you so much, sir. Thank you for sparing your time. Welcome you, sir.
Thank you so much. Thank you, AFSTI, Takon, and all office bearers of AFSTI and CFTRI. And I must thank Dr. Prabodh Hande also. He always ensures that I speak at this meeting. So, today I'm switching gears and going to talk on area. Though we are in pandemic times of COVID, we are in a syndemic of diabetes, because unfortunately, before the pandemic started, every year we were losing around 4 million people living with diabetes. And in the last 2 years, we have lost every year around 6.5 million people with diabetes. So every 6 or 7 seconds, we are losing one human being with diabetes. And diabetes is reversible through lifestyle, but adherence to lifestyle and precision nutrition is tough. And therefore, I'm going to, give you some glimpses on some work which we are doing in artificial intelligence. So, we are going to talk about this new term, this remission, because people were not talking of remission or reversal of diabetes maybe 5 years back or 10 years back. And last year, all the global societies got together and they defined remission. Then, our person introduced me, said that I work on this Asian Indian phenotype. We are the thin fat Indians. So how is it relevant to India? Then there is a twin cycle hypothesis. There is fatty liver, fatty pancreas. Can we reverse it by just eating less, eating correctly, eating the right thing? Then can we have a way to reverse diabetes? Can we do that? And can we use artificial intelligence in diabetes? And can we handhold technology and reverse chronic disease? And maybe a simple take-home message. So if you do a scoping review of all the literature published on the word remission and reversal, what came out is that you need no anti-diabetic or glucose lowering therapy. We need normal blood sugars, that is normoglycemia, and we need that this to be sustained for at least 1 year. So when all this pooled analysis was done, and they wanted to do this definition, which was published in PLOS in 20th of October 2020, they removed every study published on planet Earth related to remission. And they did a complete scoping review, which is available full text on the Medline. And they defined, partial remission, complete remission, prolonged remission, and so on and so forth. And they use these, Sankey diagrams for defining remission. And fundamentally, there are two types of remission. One is partial remission, one is total remission. And partial remissions means you need to take them off the anti-diabetic drugs, but some of them might continue metformin for some other indication. The 3 months average sugar should be below 6.5. The fasting should be below 126. PP should be below 200. So that was the consensus. And the duration was not specified. Some people said 6 months, some people said 12 months. And for total remission, it was remission of pre-diabetes, which means the A1C has to be below 5.7. And the fasting PP has to be below 100 or 110. AD and WHO differ on it. And 2 hours glucose should be below 140. So basically, all it means is that either you have fully normal A1C, fasting and PP without any drugs. That is the meaning of complete remission, or partial remission means up to 6.5, 126 and 200 and no drugs again. And they used all this. So last year, in the month of September and October, the US Endocrine Society, the European Society for Study of Diabetes, Diabetes UK and American Diabetic Association came out with a policy document. This is fully published now and worldwide available on a definition of diagnostic criteria for remission. What do you say? Who in type 2 diabetes is remitted? So it means that you should get an A1C below 6.5, which occurs either spontaneously or through an intervention, which lasts for 3 months in absence of any drug. Number 2 is, A1C, if it is unreliable as a marker,
then you can use fasting glucose below 126, or nowadays we use the AGP, which are these glucose, continuous glucose monitors, and you can say that A1C less than 6.5. That can also be used. Now, always the A1C should be done before the intervention and 3 months after the intervention. And for long-term maintenance, we need at least 1 year, and every year you should look at it. So we are in a food conference. We are into food technology. So food is medicine and medicine is food, is what Hippocrates, the father of medicine, said, almost more than centuries back. And we clearly know that lifestyle changes, and now we are all, I wish that I could have traveled to FSTI to give this lecture, like I had traveled to, traveled to Mysore last time with my friend Dr. Maskar and Dr. Halde. And but that now we are all addicted to our devices here, and we are all in this device zone. So obviously our lifestyle changes and our nutrition gets skewed, and that is the whole challenge which has occurred in the modern space of medicine, and that's the big challenge. Now, as Asian Indians, because of rapid economic development, urbanization, change of diet and lifestyle, clearly we are seeing an explosion of diabetes at a younger age and at lower degrees of obesity. So what is typical for Indians, we are living in India or living abroad, is that we have central obesity around our stomach, and we have obesity at a lower BMI. If our abdominal circumference is more than 90 centimeters for men and more than 80 centimeters for women, then clearly there is a challenge, and that's Asian Indian phenotype. And this is a survey we did with 18,000 people, which we published in 2012, where we picked up 8 states of India, and we took the first 10 patients which entered any general practitioner's clinic or a family doctor's clinic. And we screened them for diabetes, blood pressure, and we looked at their waist circumference. And 86% of them had truncal obesity. So what is driving the epidemic of diabetes and hypertension in our country is the abdominal obesity. So we are thin fat Indians. We have more fat, less muscle. We have sarcopenia with abdominal obesity. Is it genetic? Probably yes. Is it environmental? Absolutely yes. We are sedentary and we are affluent. And that's the key which is happening. And muscle has become the focus point, because it is not just important for structure, but it's a primary metabolic organ, which is not only a reservoir of proteins, but actually regulates the glucose levels. And therefore, if you see the same BMI, if we are in Asian Indians, you can see on the left-hand side, patient A, you will have more fat mass and less lean mass. While you can see in patient C, there will be more lean mass and less fat mass. So that's really the difference. So we are sarcopenic. We have more fat, less muscle mass, mitochondrial defects, and we have challenges related to the Indian mitochondria. We did the STAR study, which we published in BMJ Open almost 6-7 years back. Clearly, we suggested that India is a carbohydrate fat country across India, including Northeast. You can see whether you are a diabetic or non-diabetic, we eat too much of carbs and fats, and we eat too little of proteins. So that's really the Indian phenotype. So, when we look at reversing any disease, why we are getting the disease? Because we are eating too much. And when we have a positive caloric balance, we generate de novo lipogenesis, and that accumulates fat in the liver and the pancreas, and we trigger a twin cycle. So basically, when we eat too much, we are triggering a liver cycle of liver fat, especially if there is a muscle insulin resistance. And then, of course, we will also have fatty pancreas, and we trigger this twin cycle. And this was published by Professor Roy Taylor's group, which is world famous now for their remission studies from United Kingdom. They did a direct study, which I'll allude to a little later. So it was way back, 20 years back, in 2004, the Diabetic Nutrition Study Group of the European Association of Study of Diabetes recognized that if you eat less and reduce caloric intake with people to maintain body weight, you can actually correct energy balance and reverse diabetes. Canadians recognized in 2013 and ADA recognized in 2014, and now remission and reversal of diabetes is possible and feasible. So that's something which is well recognized. So why are we getting it? What is the root cause? The root cause is metabolic inflexibility. So obviously it is called as dysglycemia based chronic disease, and it's all in the mitochondria, because the switching of the glucose and fat occurs inside the mitochondria of our body. And clearly we know that some of us are flexible in the mitochondria, some of us are not flexible in the mitochondria. So mitochondria of our body have a capacity to switch freely between oxidative fuels depending on the nutritional context. And this is clearly lost in people who are obese or people who have type 2 diabetes. And that is why the disease progresses. For example, somebody is fit but eats everything, which is wrong food, but does not get diabetes, it's basically because they have a metabolic flexibility. But when that ability of the mitochondria to switch fuels is lost, you will get progression of type 2 diabetes and its complications. So that's really the key, and it's all linked inside the bioenergetics and the reactive oxygen species related to the mitochondrial electron transport chain. And fundamentally, it is the electron transport chain RTC complex 2, which is a cellular target now for DBCD, where new therapies are being discovered. So basically what is happening in type 2 diabetes today is that there is mitochondrial dysfunction, which interferes with oxidation of acyl CoA, which allows you to accumulate a lot of intracellular lipids, dialkyl glycerol, reactive oxygen species, which activate serine kinase, leading to interference in insulin signaling, leading to insulin resistance, and it interferes in the muscle GLUT4 translocation. So that's really the key. So what's happening is when there is a mitochondrial overload or a gridlock, there is a decrease in the mitochondrial pyruvate uptake and lipid oxidation. There is decreased substrate utilization and ATP generation. There is excess of glucose and lipids, which leads to insufficient lipid utilization and ectopic fat, which leads to microvascular complications and impaired insulin signaling, insulin resistance, and macrovascular complications. So obviously, this is a study done by Professor Nair from the Mayo Clinic, where he looked at healthy people, obese people, and type 2 diabetic people with muscle. And it is the muscle mitochondria which are defective in obesity and type 2 diabetes. And clearly that has been documented in the Indian population. So obviously the metabolic inflexibility leads to fundamentally the mitochondrial dysfunction, which fundamentally leads to insulin resistance, dyslipidemia, diabetes, and hypertension. So that is something which we know very well. And it is very, very clear that if you do caloric restriction or use caloric restriction mimetics or lifestyle, we decrease the oversupply of glucose and lipids. And clearly, when there is caloric restriction or lifestyle modification, the nutrient load comes down, the lipid loading on the adipose tissue comes down, and the energy expenditure and the ATP production is unaffected. So clearly, that is a way to tomorrow ensure that we are able to get into that. So medical industry or pharma industry is trying to do pharmaceuticals, which will improve mitochondrial function, mitochondrial biogenesis. But it is exercise and caloric restriction which can do the same thing. So if you are able to appropriately do proper lifestyle modification, you can exactly get everything which you can do by drugs and improve insulin sensitivity, have normal metabolism and normal cardiovascular function. So today this is a reality. It is no more a myth. You know, when somebody says that I can reverse diabetes by appropriate lifestyle, it is a very tough lifestyle for which sometimes you have to use technology, which is what I want to talk to you all today, and that is possible. So, you know, this very low calorie diets, they have been there for a long time. In 1929, the first research was published of very low calorie diet in obesity. In 1962, the canned drinks were introduced. In 1976, there were sudden deaths associated with these very, very low calorie diets. And of course, Codex standards got introduced in 1995. So that is really the history. So basically now what are the very low calorie eating plans? That is what direct trial was done by Bob Taylor, that either you have VLCD or VLED, which is very low calorie eating diet, as 450 to 800 kilocalories per day, and low calorie diets are 800 to 1200 kilocalories per day. And you need to ensure that they are micronutrient replete, more than 50 grams per day protein and more than 7 grams per day fat. So that is what has been recognized. So the first people to reverse diabetes in the world were bariatric surgeons. Pori et al. More than 25 years back showed that if you do a bilirubin-pancreatic diversion, 90% of the people, the diabetes completely is reversed after 10 years also. And Professor Taylor elegantly with general practitioners in UK showed in the direct trial that by similar caloric restriction, but severe caloric restriction, you can get the identical effect of bariatric surgery without doing any surgery. And you can get normalization of insulin sensitivity, liver fat, and all interventions are feasible. And he did it. And he was able to resurrect the lost first phase insulin secretion just by severe very caloric restriction. Body weight came down, glucose came down, insulin action improved on the liver. And this study, which he did, was published in the Lancet in December 2017, which became a standard of care now. And it is called as a direct trial. And basically it had people with type 2 diabetes less than 6 years, BMI between 27 and 45, not receiving insulin between 20 and 65. Obviously, they are an intervention group, and you can see that in 50% of these people, remission of type 2 diabetes was possible after 1 year. And now they have 2-year data, 5-year data published. All they did is replace meal with a low calorie diet, a negative caloric balance was established, and the liver and pancreatic fat was depleted, and diabetes was reversed. So this was a simple mechanism, which is not, it's very easy to say, very difficult to adhere. That's the big problem. And they were able to show in very elegant physiological experiments that gastric emptying improved, glucose improved, insulin improved, the various gut peptides improved. And who responded better? Shorter the duration of diabetes, better the response. So if your diabetes was 4 years, 3 years, you can respond better. Younger the population, better the response. So type 2 diabetes, naturalistic, can be reversed. Today in modern era, we can reverse it either by surgery or by lifestyle modification. But lifestyle modification, you have to use very low calorie diet like direct trial, and that is tough to follow. We can also do chronobiology to reverse diabetes. For example, Professor Hallberg, who's no more, and his wife Germaine Conselian from University of Minnesota, they showed that if you have a large breakfast but no dinner, you can actually not get obesity and diabetes. But if you skip breakfast and have a large dinner, you can actually get obesity and diabetes, and you can die earlier. And they published this data way back in 1973 and 1976 in the Lancet. Now, can we use technology? Can we create a digital twin and use technology for adhering to lifestyle, which is diet, exercise, sleep, happiness, and all that? Can it be linked? Because it's impossible if I tell anybody in the audience to eat 700, 800 calories a day. So, there are innovators now. We know we have electric car. This is Tesla. So Elon Musk, had these twins which he created, that artificial intelligence can drive the car and drive the electric car. So can we use Internet of Things, machine learning, and use that technology in medicine today? Can we really create digital twins of our body for glucose, for blood pressure, for food, for activity? Can we create that? Can we use technology for doing that? Yes, it's possible, because metabolism is a very complex subject, and we can use that. So every individual is different, and the reactions of every individual will be different. So it is not easy to create the digital twins. So this whole body digital twin, which there are founders, one of them is at IIT Research Park in Chennai, Maluk Mohammed, and one of them is in USA, Jahangir Mohammed and Terry Spoon from MIT. They basically, designed these, and they were the part of the Jasper technology which Cisco bought over, and they are the ones who created a digital twin for Elon Musk for electric cars. Now they're using the similar technology for whole body and trying to reverse chronic disease and diabetes. And you can see here what they do is fundamentally they attach CGM device, they attach a blood pressure device, a weighing scale, a ketone meter, and map everything. So they get signals of health. They have a coach. So coach talks to the patient every day and ask whether the patient is happy or stressed out, because the important thing in life, in lifestyle modification, is that person should feel and happy about it, because people want to reverse diabetes. And of course, there are medicines which are going on. So a doctor is also involved. So it's actually a team of technology, which is an app and various sensors where the app crystallizes and synthesizes that. Then there is a coach which supervises and talks with the patient all the time. And then there is a doctor supervising treatment so that the treatment can be reduced. So it self-learns each human being's metabolism and tries to predict an outcome, and then tries to give precision information to basically tell you how much to eat. Suppose you are having 2 idlis and less sambar, they'll tell you have half a idli or 1 idli and more sambar. Okay, something like that they do. Then if you're sleeping less and you're sleeping only 4 hours, they'll say sleep for 7 hours. If you're not doing any physical activity and only doing 5,000 steps a day, they'll say do 10,000 steps with muscle building. If you're taking metformin with a sulfonylurea, they'll say stop the sulfonylurea because low sugar attacks will take off all the medicines. And the coach will keep you happy, because there's no point doing all this clutter in your mind when you're confused, but you need to also be happy when you're doing this whole exercise. So that's the whole way you are using it. Many people have tried this, like Livongo, Volta, they are all these reversal technologies, they have done it. And Twin is also doing it. Twin is based out of India and US, and they basically reverse diabetes, blood pressure, dyslipidemia, obesity, kidney, liver, pancreatic beta cell, insulin resistance, and inflammation. So what do? They use a continuous glucose monitoring device. It's called as AGP. It's an Libre Pro sensor, which is available in India now. And we can easily map. You don't have to keep on checking the sugar all the time. It's just attached, and it will go to your mobile phone by just a simple sensor. And you can actually plot the glucose values when you eat breakfast, when you eat lunch, when you eat dinner, and you can actually map it. So, and then you can create it. Then the machine learning takes over. So after 30 days to 45 days, the machine learns your body's skills, that if you eat a dosa, if you have coffee, if you have paratha, what would be your glucose spike for that particular human being over 30 days. And then it will synthesize all that information and give you a solution, what should be there through an app. So basically through that CGM patch, we are able to plot a virtual CGM graph and predict what would be the value. Similarly, the blood pressure is also mapped, and it is creating a virtual blood pressure monitor. And then, we are looking at food response. So for the same human being, suppose I eat food, Dr. Prabodh Halde or Dr. Maskar eats food, what would be the food response? Suppose I have idli, my glucose might go up from 90 to 110, and Prabodh's glucose might go up to 120 or 140. So somebody will have a poor response, somebody will have a yellow response or a fair response, somebody will have a good response. So we have to ensure that the response ultimately becomes green. And that is the key in precision nutrition today. Precision nutrition is all about what food, what meal, what combination, how often. So actually we have to learn our taste preferences and adapt a food habit which will change. It's very, very difficult to adapt and change food habits because a lot of eating is emotional and mindful, and we need to make it more mindful and make it very, very accurate. So fundamentally, that's what these artificial intelligence of AI technology and the coach and the doctors do with the person. And therefore, if there is continuous machine learning, what happens? There is a CGM, which is a glucose monitoring device. There's a blood pressure device. There's a ketone monitoring device, because if you starve too much, then your ketones will get positive. There is a body scale. There's a Fitbit, which tells you and measures your activity. Then your sleep is measured, symptoms are measured, mood is measured, and all the blood work is done. And all that is inputted into a machine learning system. All the food elements are analyzed, which are all the 10,000 food elements, the micronutrients, including the gut microbiome. All that is put in a database. And ultimately, using machine learning, you can devise a advice of precision nutrition, sleep, activity, and under medical support and a coach support, and try to keep the person happy and healthy. And maybe over a month or two, the device dependence on the human being, which is all the time constantly being monitored, will come down, because then you will do the pattern recognition and give a solution and be able to do it. So obviously, if we do such a thing, we need a randomized control trial. And now 1 year randomized control trial in Bangalore city is over. Dr. Parmesh Shamanna, Dr. Ashok, Dr. Bala Dharmalingam, they are the lead authors of the study in Bangalore. And you can see that on an average, the mean average is clearly, you can see around 42. The starting A1C is around 8.9. The diabetes duration is around 4 years. The average BMI is around 27. That is what is being done. And you can see that we have outcomes of diabetes reversal in almost 88%, blood pressure, lipids, obesity, the heart risk score, kidney albumin, liver, fatty liver, all that can be reversed in a very, very appropriate way. And most of the patients are able to reverse or take off their medications, except metformin. Metformin sometimes continues, and you can see that the data is consistent on various metrics, whether it's A1C, HOMA-IR, weight, waist circumference, and so on and so forth. And you can see that members are in remission, A1C improves consistently, and you can see the weight loss is consistent. So we had published a lot of that data. In fact, in the International Congress of Endocrinology, I presented this paper last year, and we published the early results of this paper. And we clearly showed that the insulin resistance improves as well as the A1C improves. And you can see here from the scatter plot that there's a direct correlation that insulin resistance improves with the A1C. We also use this at the technology meeting. We have a diabetes technology meeting called ATTD, where we again presented data to show that the glycemic variability comes down. And when we use some of these technological helps. And in the American Diabetic Association meeting last year, we presented the interim results of the randomized control trial. And again, we showed that using this technique, in a small cohort, we are able to show reversal in both glycemic and extra glycemic parameters. And what is unique is many people think that we can reverse it because there is weight loss. But actually, this was a paper which I presented as a late breaker abstract at the American College of Clinical Endocrinology last year, where we showed that you can actually use this technology independent of weight loss. So you can get diabetes remission independent of improvement of obesity. So it is not just weight loss dependent, it is weight loss independent. That is something very unique. So obviously, using various health experiences and signals of CGM, blood pressure monitor, ketone monitor, smart scale, Fitbit, and Apple Watch, and an app, we can take all this and integrate it with what you eat, what is your energy, what is your mood, what medicines you are taking, what are your symptoms, and we can actually give them advice. And we have published all this in various peer-reviewed journals. And this is all precision treatment using sensors, blood reports, member logs, using machine learning, artificial intelligence, and trying to curate a plan with the help of doctors, coaches, and mobile apps. So this is possible. It's not impossible. So obviously, diabetes can be reversed today. Okay, it's a tough job, but it is doable. In a small subset of type 2 diabetic population, if we get motivated people who either can follow a very low calorie diet, like 800 calories, or they can go into an artificial intelligence system, which has to be handheld, which means they have to measure it all the time. Then they have to have a coach. They have to have a doctor supervision. Under a controlled environment, we can remit diabetes. Diabetes remission is a possibility. A lot of research needs to be done. But even though I'm talking of artificial intelligence, to have a world free without diabetes, you need to digitally detox. We are all intoxicated to our computer screens. I would have loved to meet people physically. I would have loved to travel to Mysore or any other area. I think Aurangabad was the place which was supposed to be the meeting. I don't know where the meeting was this time. But you need to understand that key is diabetes prevention. So though my talk is on remission, we need to eat less. And in COVID pandemic times, we are in during Corona era. We should have an after Corona era. We don't know when that will happen. But eat less, eat on time, eat slowly, and eat in the morning. Walk more, try to do your 10,000 steps per day, and sleep for a good 7 hours and sleep on time. And try to be happy. And try to do 1 or 2 hour digital detox every day. Because at the end of the day, that's the only way we'll be able to reverse diabetes. So I'll be happy to answer any questions. I know it was a different. I think they're muted. So thank you very much for the kind opportunity given to me. If there are any 1 or 2 compelling questions, I'll be happy to answer. I think you are muted, I think. This technology is not an easy thing to handle.
Is it fine, sir? Can you hear me? Yeah. As usual, very insightful, mesmerizing talk, sir. Very nicely you have put the perspective, medical perspective of the food. Eat less, eat right. And also very rightly mentioned that most of the Indians, their diet is full of the carbs, and it is challenged to restrict it to around 700 calories. So obviously, probably we need to work more on the exercises. We need to be on time, smile, happy. So all these factors, but very wonderful concept which you gave, which will provide many of the youngsters the tool to work on that, whether all this AI, ML, whether they all can be integrated with the body metabolism and also the food, so that the concept of personalized nutrition can really come into the picture there, sir. Thank you so much for all your knowledge and sharing with us, sir. Wonderful, wonderful to have you, sir. Thank you for your time, sir. Now, the delegates, we will have the presentation from Vice Chancellor, Professor K.V. Kale, sir, Professor Karbhai Kaleji, who was Senior Professor of Computer Science and Information Technology, and presently Vice Chancellor of Dr. Baba Saheb Ambedkar Technological University, Raigad. And he also worked as Director of Board of College and University Development, BCUD, of Dr. Baba Saheb Ambedkar Marathwada University, Aurangabad. He was head of the Department for Computer Science and IT at the same university for about 10 years. He also served as Director of University Network and Information Center at Aurangabad. He has he acted as the President of ICT section of Indian Science Congress Association, Kolkata, during 2015 and 18. And Professor Kale sir had part of various committees like Perspective Development Plan, Rashtriya Uchchatar Shiksha Abhiyan, Higher Education Policy, New University Act, Higher and Technical Education, Government of Maharashtra. Sir was coordinator of Monitoring and Evaluation Committee of Avishkar Research Program organized by Government of Maharashtra, and pioneering the multimodal biometric and remote sensing data analysis, and established the state-of-art lab for multimodal biometric research lab, MBRL. His area of interest has always been in the geospatial technology, big data analysis, artificial intelligence, machine learning, and pattern recognition technology. During his 32 years of experience of teaching, research, innovation, guiding PG, UG, and PhD students, has published 360 papers, 6 books, and also 23 chapters. He has several patents, including 2 Australians, and he is also having several crore worth of fund from various agencies, including DST, UGC, RUSA, Media Lab, etc. With this brief introduction, may I request Professor Kale, sir, to present his talk on the theme hyperspectral technology for food analysis.
Good morning, dear participants.
Yes, sir.
I am Professor Karvari Vishwanath Kale, Vice Chancellor, Dr. Babasaheb Ambedkar Technology University, Lonere. I am happy to be in present of you in this August gathering to deliver a special talk on hyperspectral technology for food analytics. Though we are in the technology hyperspectral and we are linked with the various technologies, particularly agriculture sectors and food analytics. So we had been have some experiment in our laboratory with the chemical technology with Professor Sakre teams and my teams. So at the outset, I would like to congratulate the organizer, Professor Sakre and Professor Anna Pure, that they had given me this opportunity to present in front of you the renowned and advanced technology specifically for food analytics and food detection and food quality assessment, which is immensely important for health and for health industries and food industry. So before going to start ahead, what I would like to impose to you, food safety and the quality are becoming progressively important, and failure to important monitoring process and identity anomalies in composition, productions, and health and other services because of the content of the foods at the deeper sites and in the micro level side cannot able to detect with the help of the extracting and extracting laboratory. So what we had suggested, the hyperspectral technology found to be suitable for detecting the minor level of informations which are depicted inside the food, not only the food, for other sector of area. And it is very easy to detect and analyze the content about the food which is supposed to be good for health conscious and for the food processing industry. So hyperspectral technology includes hyperspectral imaging and non-emitting reflectance technology. With help of various reflectance and reflectometry, imaging and non-imaging, we made the big data analytics. And on the basis of this big data analytics, we had developed some particular technique to interpret and analysis of the various type of foods. So we had done some experiment in our laboratory that is on the sweet potato. At the end, I would like to highlight it. So before going to ahead, this is a new technique. This technique is innovative technique, and this innovative technique gives you the idea to how to reduce the defect of the existing system, which are not supposed to be found suitable for correct analysis and mapping. So what is this technique and how do we have performed the experiment? In short, I would like to put in front of you in a brief. Food remote sensing is one important global umbrella area under which we had various number of applications for surface and for soil and for forest and for analysis. And within that, food is an important criteria because the food is an immense for the quality foods and for safety and for healthy and for human health overall. So what is this technology? This technology specifically preserves and applied with help of big data analytics in our laboratory, and we do develop some destructive detection food mechanism, which is a non-invasive mechanism for the industry and for the authentication of and benchmarking of the quality of the food. So these are the overview, but I don't want to take you in the overview. These are the technology constraints and some of the basic remote sensing specifically used in the multiple applications. Here also we had used the remote sensing, but that remote sensing is the hyperspectral remote sensing. As because of the multispectral imaging having some limitation through which we cannot able to catch the detail about the food, about the content of the food, and we cannot able to create the spectral signatures about the food. So we use the hyperspectra. And what is hyperspectra? Which requires some another dimension to speak, but the hyperspectral technique just in a narrative way gives you the detailed information about the content of the object. That object may anything that we can put in the laboratory or you take in the field. If you take the global coverage, we need the sensor to put in the highway. So how to perform this? This is the natural source of energy falling on the surfaces. And on the ground surface, there are so many things: mountains, area, soil, water, food, and all. So we take the sensor either on the board or the crata, take the reflectance of the material catch by the sensor. The sensor sends information to the ground signal, and ground signal prepares the data in terms of image and non-imaging form, and we'll send at the back to the high-end application. Here we are using the food are in the field or food are taken into the laboratory, extract the content, and develop the technique, big data analytic technique for quality assurance and quality measures on the basis of analytic. What analytic? That means what are the things available in the food in natural way. So the food scientists and agriculture scientists must know what are the good content which is supposed to be available for a good health and digestion system. If there is a miss or additional get content added because of the deteriorations and bacterial content, that is hazardous to the human being. And that's why even the food industry or the health department always making you assure that is there in the mixing in the food, is there hazardous content in the food, and if it is, then that is dangerous for the health. So this technology provides you the accurate mechanism and measures to detect that particular type of content which is supposed to be available in the fresh foods or the preserved foods. So we use the platforms that are the various sensors available in the market. The data get collected with the help of various mechanisms, and those mechanisms, some sensors are put in the aircraft, some sensors are on board, some sensors are in the satellite. If your coverage area of the surface is more, you need to high altitude information which is mounted on the satellite. So all type of data collection mechanism, ground truth data, airborne data, or UE data, or drone data, or hyperspectral data which is supposed to be the sensor are mounted on the surface, above the surface at the too high altitude, that is in the satellite form. And once the data get collected, the data get analyzed and processed, and automatic application and full detection mechanism has been already developed in the developed countries, and we are also marching on the similar type of way. So how do data collect? As I said earlier, data get collected in the field, particularly with the drone. This is the sensor here. The sensor scanning on the surface of the field. There is, let us say, some particular crop, and that collect information, crop includes the leaf, crop includes the flower, crop includes the fruits. So in field and in laboratory, both mechanisms that we can consider for collecting the data. So please remember, data get collected through the sensor, and the data in the form of signals, in the form of images, and the sensors are hyperspectral, multispectral data. And these data also some sample taken to the laboratory, and we make the modeling of these two data and undertake it. What are the content available within that particular food? So these are the various composition made by the people. And these data sensor having two type, passive sensor and active sensor, both are now required nowadays for performing the different type of things. So passive sensor, that is the natural sunlight, active sensor is the artificial light. If in night situation, somehow if we require to information about the object, and then we need to allow the artificial light and get the information back to it. So what we are talking about, that is the hyperspectra. So let us give a brief information about the hyperspectral and multispectral. We as a human being working in the visible spectrum, that means beyond the wall, I cannot able to see what has happened in the wall, I cannot able to see because of the limitation of my sensor. So visible sensor range having the violet color to the red color, and then short width infrared and low width infrared. These are the some of the honor band available in electromagnetic spectrum. So I can see the leaf, I can see the tree, I can see the fruit, but I cannot able to detect what is inside in the tree and what is inside in the fruit. And that was we required the extraction of the fruits and leaf to identify the content. Later on, we can have the multiple imaging sensors. Through multiple imaging sensor, we can elaborate the classification of the fruit. This is banana tree, this is bubble tree, and this is about that. But within the mango, if you say that what is Alfonso and what is the Gauran and what is the Devgad, I cannot able to detect on the basis of food. Some expert visually interpret on the basis of color, shape, size, and taste. But artificial intelligence system cannot able to do this because of how to detect, because leaf size is same, fruit size is same, and then even though we want to suppose to detect the minor change within the food, this is what the general observation. And because of the gap between the BAP in multispectral happens, and due to this we cannot able to capture the signature. But in this type of limitation in all the field recorded in the hyperspectra, hyperspectral is a continuous band, and we can scan the informations of the object continuously in multiple forms. So this is narrow slit with the multiple band, 100, 200, 300 bands are there, and each band gives you the different information, and on the basis of that different information, we can able to detect the object accurately and precisely. So hyperspectral, beyond the hyperspectral, there is a more particular hyperspectra that the sensor is not available in India, that is in the USA only. So we use the hyperspectral imaging and non-imaging technique in our laboratory to extract the contents about the fruits, and I will show you at the end what that we had did in the laboratory, etc. So visual interpretation is possible with the help of visual, but the detailed interpretation we required some processing and analysis. So that is what one band imaging, one panchromatic single band, that is 4-band imaging, this is multispectra, and this is what the hyperspectra. So 200 band, 300 band. So same observation, we can have the number of object detections possible, and because of this hyperspectral technique available, the sensor available, and there will be the wonder to detect the minor information about the content about the object. So what we need to consider in general, we need to consider the 3 types of resolution basically for image and object detection. One is the spatial, another is the spectral, third is the temporal. Temporal means time data. If you require to map the informations about the development of the fruit, when fruit is in the flower mode, when fruit is in the curry mode, when fruit is in mature mode, and when fruit is in the cultivation mode. So on the same information, we require to collect the data timely, monthly, or some season wise. And what is the content that we can map with the help of spectral and spectral signature and spectral signature. So spectral and spectral, these are the technological terminology through which we can able to detect the object very precisely and correctly. No doubt we require some certain technique also altogether for interpretation of the data. So what we say, the data, hyperspectral data that we can map in terms of digital and in terms of array. That means imaging form and non-imaging form. That is in the vector form, information only. So digital data is imaginary data, multidimensional or hyperspectral data, and spectral data in the vector form only. In spite of picture, we'll have the information in terms of digit only. And this is what the hypercube. Let us say this is the spice of a particular part of the animal or particular part of the crop, and there are multiple layers. There are 200 layers approximately. So each layer gives the information differently. So wavelength versus reflectance, that is the spectral signature. And our core objective is that to create the spectral signature of each and every object which we have detected through the sensor. And these sensors provide you the information very precisely and accurately, and you can model it, you can process it, you can analytic it. So analysis means at what wavelength, what reflectance, that will be the picture signature, and through the signature you can able to detect the content about the object. So this is 3D. This is from ultraviolet ray to near infrared. So there are n number of bands. As we see that in the multispectral data, there are n number of bands available. This is composition about the hyperspectral band, and this band gives you the information specifically for identifying the content about the food specifically. So spectral signature is important. It is a variation of the reflectance or emittance material reflected from its wavelength, basically from its surface. And those surfaces are supposed to be required some emanance of the light, whether it is artificial or natural. And on the basis of this reflectance, the reflectance gets get by the sensor, and the sensor gives you the information. Now those information of the data, this is the data, and this is the spectral signature. So there are n number of signatures. This is the average signature of the various vegetation. So under the vegetation, all word, fruits and trees and crops comes together. So we need to analyze this particular signature. If it is a green, that means it is a signature of the vegetation. Under this vegetation, there are so many crops, there are so many trees, there are so many fruits, and each fruits having the content particular to particular wavelength and particular reflectors. So there is some segment in visible spectrum. We can study the chlorophyll content and observations about the crop. And in near infrared, we can see the cell structure. Within cell structure, there are so many minerals and so many related to water bodies and all. And in shortwave infrared, from this range to this range, we can able to specify the atmospheric water absorption and band. That is the leaf biochemical, protein, ligand, cellulose content. And these specification gives me the detection of the object. So in short, through hyperspectral signature, if you scan it, if you perform the spectral signature, that signature gives me at what particular wavelength, what reflectance means it is a protein. At what particular wavelength, what reflectance if it is a cellulose. So likewise, we can create the non-invasive mechanism to identify the system to identify the content about the crop, the content about the food, and which helps me a lot, which is beyond the capability of your general laboratory extraction methods. So we did some experiment earlier using the multiplications of the format of the data. We need to convert the data from raster form into the vector form. These are the technological constraints. Once the data get collected, for processing the information and building the GIS application, we have to consider the data format mapping. Because of the sensory mechanism, data is not supposed to be fit into some particular form, and we have to need to rasterization and vectorization of the data specifically. So coming to the actual point, application of hyperspectral remote sensing in food technology. So when you see the food technology, you have a lot of technology in your laboratories and your curriculum through which you can able to detect the content of the fruits and observe whether there is a fraud made by some industry to get mixed unwanted content in the fruit pack and fruit pack. You require a lot of energy and a lot of certain mechanism and step to follow. But with the help of hyperspectral imaging, our observation is just to scan this information either in the local mode of the sensors or in the generalized mode of the sensor, and put the system all together to process the data and find out the detection of the fault. So some example that we have taken in agri-food, identification of the parasites and the food contaminants, food ripening, and disease in the food plant. We can easily detect on the basis of color, circular, and shape, and all this. And cultural heritage, pigment degradation, hidden layers, and so many things that we can, beyond the scope of this particular slide, that we can perform with the help of this technology. So detection of the fruit and detection of the content within the fruit, and detection on the basis of this, we can develop a model whether the quality of the food is good as per the health standards, as per the general standards or not. Similarly for fruit, this is also a leaf. You can take a cucumber leaf or any particular leaf, whether that leaf is having some chemical composition or some different type of materials available deposited unnaturally or artificially made by some. So vegetable and fruit detection authentications and application available readily nowadays in the market up to some extent. So on the basis of shape, size, color, the content is degraded. When we are going to cut it, then only we can observe. But with the help of this technology, it is very possible to detect the unwanted or unethical or mixing content within the food by naturally or by human being interventions. So these are the applications where we need to have some concentration. Hyperspectral data imaging techniques are some important technique, and we need to develop some lot of algorithms for its automation of the detection of the food and its authentication for benchmarking analysis. So apart from this, there are so many applications, and what we did, the application range are, there is no upper limit. The basic is the satellite remote sensing. Under which satellite remote sensing, we need to perform the hyperspectral data, and that hyperspectral data is having some different type of application altogether, even though today. So what we did actually as in a technical composition, we take the sensor information, either active, passive, and pre-processes. So in pre-process, we need to call geometric correction, radiometric correction, atmospheric correction, enhance the image, modify the image, and rectify that, and keep that particular image for ready for further processing. So then further processing is what? That is the classification, and that classification perform on the basis of machine learning and artificial intelligence. So supervised classification, unsupervised classification, reinforcement classification, there are the technical constants. If you know that the quality of the apple is like this, either by taste or by seeing, and then if the imaging system gives you the different one, so we know how to procure it and how to process it. So these are the our end technologies. Using the appropriate algorithms, we need to develop that particular tool to analyze and map the content and the quality of the fruits. So there are so many techniques available in supervised, unsupervised, and reinforcement for processing the data. And the data is a big data. Why? Because of collection of the hyperspectral data. By nature, itself having the lot of information, mixing information, and we need to supposed to clarify it and clear it altogether. And these informations having the different sensory mechanism. Again, it is a deep part, and we require the various classifications to process and to identify. If you collect the information from the ground for a particular bagicha, that is a fruit plantation, and let us say, as I said, there is a mango having a different variety, we cannot able to detect the different variety even though with the help of naked eye. So then there is a key means, so cluster together the similar type of plant and differentiate on the basis of content of the leaf and content of the fruit, whether it is a Ratnagiri or Devgad or Hapus or some Gauran mango. Likewise, it is quite possible to similar detections and identification through the field and with this particular technology. And whether this is supposed to perform or not, our tool is accuracy assessment, and we do accuracy assessment. We find out the kappa component and check whether the system developed by us, that is non-living system, is how much accurate with the laboratory equipment. So for that, the last competition I came to, we had did the study with the help of our chemical department and computer science department of BAMU earlier, and we used the AHD field effector 4 and PKL sensor of a hyperspectral data collection, develop some spectral libraries and indices, and perform some studies. So what study that we had performed? We had the common publications along with this department, that is the sweet potato. We extract the content of the potato that they had already extracted in chemical technology laboratory, and same content of the examination extraction that we perform with the help of hyperspectral technology. And then we benchmark that both technology are supposed providing the similar result. So this is the field spectra 4 that is having the nano range of material from 350 to 250 long range, and all the information that we can perform and create the graph reflectance wavelength versus represent the spectral signature. So this signature gives me the variation of the variant about the content of this particular fruits, and those fruits are supposed to be extracted. This is Dr. Rupali. She has performed the study with the help of Department of Technology during her research work, and one lady from the chemical technology. And we publish combinedly 2-3 articles on the basis of this result. So sweet potato. What I'm going to say that the chemical technology people identify the extraction of the fruit by their routine method or clinically method that we can say, and the same information that we observe with the help of hyperspectral data imaging. And that result that we can match, as an example, we can take simple component from the food that are the protein, calcium, iron, potassium, sodium, and zinc, and a similar extraction that they had in the laboratory. And with the help of optical band, this happened. But with the help of hyperspectral non-imaging and hyperspectral imaging, we got the result approximately the similar type of composition. And then we benchmark, yes, with the help of non-imaging spectroscopy, with the help of hyperspectral technology, what are the content that the chemical analysis method gives us, which is exactly similar content that we can map and identify within the food with the help of our technology. And then we benchmark, and that work has been already published. So these methods that we had overcome the difficulties that they had raising day to day, because the similar type of organic within this particular component may not able to get detect. But with the help of this and with the help of big data analytics, we perform it and we benchmark. Similar type of study we can perform on the various crop in our laboratory by creating the spectral signature. And this is one of the important data set of the hyperspectral data, remote sensing data of sensory, having the more than 200 band of information. So spectral features, and on the basis of that spectral features, we can easily calculate with the help of technique, that is NPN, pH, iron, manganese, zinc, soil, and so many content within the plant and outside the plant also. So these are somehow the work that we have performed, and on the basis of that, we do perform some basic type of research in our own the city for garbage collections and all that. So technique for geospectral technologies and hyperspectral technology is more immense important nowadays, and that's why the collaborative and multidisciplinary research is required, and that is the start has been done in the BAMU, and I must congratulate to the again both the organizers and the team member that they had catch up the very important area, and they had mixed up the multiple technology altogether, and that is what they suggested in the new national education policy. The people should come together under one platform in the different discipline to resolve the conflict of the social challenging problem. I think this is one of the good examples that they have said. So I once again congratulate and say thank you to you for giving me this opportunity to represent in front of the learned audience for performing. This is my entire team earlier, and these people have performed this work. So I must congratulate to them and thank to them also for providing the support and develop the technology altogether. So thank you very much.
Thank you, Dr. Kale. So hope I am audible.
Yes, sir, you're audible.
Yeah. So myself and my co-chair, Dr. Suresh G. Shakre ji, on behalf of organizers of ICFOST, we would like to thank all the speakers, Professor Rekha Singhal ma'am, Dr. Chindi Vasudevappa sir, Dr. Shashank Joshi sir, and Dr. K.V. Kaleji for sharing your knowledge and also sparing your time with the delegates of 28th ICFOST. Thank you all. And with this, we end this session, and Bodhankar team may connect the next session, please. Thank you. Thank you all. Thank you.
Priyanka, you are starting?
Yes, sir.
All the speakers are there?
Yes, sir.
Great. Please speak.
Good afternoon, Prabodh.
Good afternoon, sir. Good afternoon. So, Priyanka, to start.
Yes, sir. Good afternoon, everyone. We from ICFOST and AFSTI welcome you all at our technical session 19, that is on functional food, designer and Ayur foods for health and wellness. As we all understand that in today's era, people are aware about the important role of good health and factors which are associated with it. Moreover, consumers are also willing to shift towards a sustainable, functional, and healthy foods as they play a pivotal role. So hence, in this regard, the objective of this technical session is to apprise the participants about the critical role of these products and share the insights from the experts. We are confident that participants would be highly benefit with the expertise of our esteemed speakers. And in the end of the session also, you can also post your questions, which can be addressed appropriately if the time permits by our chair. Now, in order to present this, it's my honor to introduce to all of you to our esteemed speakers of the day. Is my next slide visible?
No.
Just a second. Yeah, Budhankar team, can you just upload the slide? Is there some, it's
I can upload it. I can upload it.
Yeah, please come to the second slide.
Upload. Open. It is different. Our screen open. Oh. Yeah. And number 2. Yes.
Yes, sir. Please can you go to the on the full screen mode?
Full screen.
Yeah.
Okay.
Thank you so much. The second slide.
Before that.
Yeah,
Okay.
thank you. So the chair of our session is Dr. Sudhakar Maskar. He's the Chief Technical Officer at Marico Limited and handles both the food and the personal care. He has earned his doctorate degree from Indian Institute of Chemical Technology for studies on surfactant and synthesis bioactive lipids. He has worked in HUL R&D Center for a decade on foods and personal care category and has created patented technologies. He has 20 patents and 25 international patent publications. Now, we would like to move to the next speaker. Now we have Dr.
Priyanka, just a minute. If
Yes.
Dr. Maskar can actually just say hello to everyone, so at least people will recall after introduction of individual guest, then if the chair can. So Dr. Maskar, just request you to say hello to everyone and then to...
I think you can see me now. I've just started my video. So hi
Yes,
to everyone, and thank you for calling me here and giving that opportunity. Prabodh.
Most welcome, Doc. It is our honor. And Priyanka, one more introduction I just want to add as an introduction to Dr. Maskar. Not only though he is from the academy, though he is from the industry, but he is well-known friend of academician. And to AFST, he has been attending ICFOST since 2004. And he is also alumni of IICT Hyderabad, wherein it is a very strong chapter of AFST, and he was also vice president of OTAI for 4 years. So thank you, Dr. Maskar, for accepting. And he's the chair. He will be chairing the session and also will be giving opening remark and closing remark apart from his own talk. Thank you, Priyanka, to you.
Can I move to the next one?
Yeah, please.
Thank you, sir. So our next speaker for the day, who is also our co-chair for the session, is Dr. Prabha Sankar. Dr. Prabha Sankar holds a PhD degree with 26 years of research experience in the area in the food science, biotechnology, biochemistry, and immunochemistry. He has earned many awards such as Best Scientific Award and Technical Contribution, Distinguished Faculty and Scientist Award, Bharat Gaurav Award, Lifetime Achievement Award, etc. And he is also a member of various committees, such as served member in EPIDA Task Force, life member of AFSTI and Society of Biological Chemists, and member in very technical and souvenir committees. He has 106 publications in the referred journals, 9 patents, developed 29 processes, published 2 books and 3 book chapters, and also guided 20 PhD students and 82 master students. We welcome you, sir, in this session. And now we would move to our next speaker for the session, Professor S.T. Maske. Professor has earned his PhD degree in polymer technology and has 19 years of R&D experience. His area of expertise includes, but not limited to, polymer processing, rheological characterizations of the polymers, nanoparticle synthesis, and applications in polymers. He is a member of various committees such as Plastic Waste Committee of Maharashtra Pollution Control Board, etc. Professor Maske has 166 international peer-reviewed research journals, 4 books and chapter which are authored, and 6 patents. He has guided 16 PhD students and 87 MTech students. So with this, the brief introduction of our speakers. Now, I would request the chair for session, Dr. Maske, to deliver the opening remarks and take over the session. Over to you, sir. Thank you.
Thank you, Priyanka, and thank you, ICFOST and AFST organizers to give this opportunity to speak here, also chair the session, and I'm very happy to be associated with this food association for a long time. I've been from ICT and I've been in oil technologies, and therefore food is very close to me. It is also nice to see that my co-participants and co-speakers with such a high acclaim research. So I think today's area is very relevant. I think there was discussion happened with Dr. Shashank initially, and which actually alluded to this topic of health and these new lifestyle changes which are happening in the current scenario, and this pandemic is throwing up a lot of health issues for the human beings. I think the lifestyle changes like refined food, no activity, this stress around and affluent living is creating huge amount of issues with the health. And this nutritional overload, body cannot digest because body has always been in starvation. And when you put a lot of nutrition into the body, it doesn't know what to do. And therefore, there's a lot of issues which are coming up, like metabolic syndromes, lifestyle diseases, diabetes, obesity, cardiovascular diseases. And nutrition can be one. There are medical doctors who can always take care of this issue as a curative one, but there are preventive theories which can happen through nutrition. And nutrition can be a complementary therapy to doctors. And therefore, the new words which have started coming is designer food, functional foods, fortified foods, and they're all synonymous, which refer to the food fortified or enriched with nutrient content already present in them or other complementary nutrient, also known as nutraceuticals. Functional foods are highly nutritious and associated with a number of powerful health effects. For example, they protect against disease, prevent nutrient deficiencies, promote proper growth and development. The health effects rendered by the functional food are typically due to bioactive compounds they contain, and different compounds can exert specific effects in the body, but most often they work together with the macronutrients to alter one or two physiological processes which might show a deviation in the current lifestyle, new life changes. For example, whole grains contain bran, germ, and endosperm, and these particular nutrients are found in the outer layer of grains and the brans that function as a protective shell for the germ and the endosperm inside. Several epidemiological studies have shown that this high intake of whole grains or these unrefined foods is associated with reduced risk of type 2 diabetes, coronary heart disease. And the consumption of 90 grams of whole grain foods per day has been shown to reduce the risk of colorectal cancer by 17%. So there's a huge amount of health improvements or the health supplements can happen through the proper nutrition. But it's important to note that although the presence of bioactive compounds in the foods are important and they're there, the digestion, absorption, and metabolism are also critical factors that influence their health effects. And that happens through when they get processed and then they get packaged. And also the factors within the food production chain, such as processing and distribution of foods, that can also influence the content and type of bioactive components found in the food. So it's not about what nature has given us, but it's about what we do with those grains, what do we do with those food, and minimally process them and minimally damage them so that they are available in the body is more important. The new area which is also coming as the Ayur foods, and that's the same thing, which are Indian evolved medicinal system called Ayurveda. It has also biochemicals which are coming from the plant, which are used for either physiological defects or it's also used for a complementary nutrition, this one. So I think this particular session is going to talk about three important things. Possibly it's very difficult to take this area and cover this area into these three small sessions, but Professor Pichan is going to talk about the processing of foods to see that how do you create the design foods and the functional foods. I will going to talk about the grain and its importance and its health benefits, which are not known to India yet. It is consumed in India, but it's not a very famous one. And the last talk by Professor S.T. Muske is going to talk about the packaging, because packaging these foods is also important because you have to preserve the integrity of these nutrients, and it should have a shelf life of 1 year, and that creates the packaging. And the packaging should be sustainable. That is more important. That's a new calling. And therefore, this is going to provide you a glimpse of what is going to happen in the functional foods and the fortified foods. So thank you very much on that. So I thought I will now invite Dr. Pichan Prabhashankar to deliver his talk on
Thank you, Chairman.
And the future prospects in baking and extrusion-based designer foods.
Thank you, Mr. Thank you for a nice introduction. And I will start with my presentation. See the next.
We can see the slide, sir.
First of all, thanks to the based design, of course. Basically, I'm going to divide the topic into background, market scenario of the baking and the pasta right now, and fortified products, gluten-free products, low GI products, and shelf-stable natural preservatives, and prebiotics and monojuice conclusions. This is my topic, subtopics. Basically, food processing is initially previously. Now slowly the good food has become as a health-oriented things, especially to treat the diseases and or prevent the diseases. Nowadays, bread has so many variations come. So coming to the why we have chosen this wheat-based processing, wheat is a staple food all over the world, and previously in because today any part of day, they always use any of the wheat-based food product, either chapati, either biscuit, or bakery pasta, etc. So this is one of the major you can introduce the health-based things. To understand that one, we must know the market scenario. What is slowly increasing to the
post 61.2 million. If you go to Indian, so it's going to increase like tremendously. Coming to the bakery production Indian scenario, biscuits are more produced and bread is the second one, cakes and pastries and other things. And coming to the, nowadays people are concentrating on enzymes or other ingredients required. Is increasing. And second thing is that products are improving, getting momentum, and then many of these are fortified, and people are going for the mineral fortification, and people are going to the level of the biofortification also. There's fortified bakery products also. There's a tremendous growth in this coming scenarios. And another thing is previously pizza was also the pizza market that is rapidly increasing, and then two. Say what I'm putting these figures are because to Indian culture also. Coming to the extruded product, and 15 years before 20 pasta may not be that much common in India. Nowadays pasta and vermicelli are picking up. Your things of the improve the health prospect of the products, especially in pasta product. Globally, you see market is increasing. And then different countries also. And the sales are higher, and Western India, South India in between. This is the pasta market side of India. Coming to the Maggi is the buzzword, and that is also coming from the exported product, instant noodles. Thereby, it's globally that market trend is increasing tremendously. So coming to so far, I discussed about the need and how CFTR has done many newer innovation to improve, especially in the case of the, actually we have the front runner as what you can say, fortification, flour fortification done by our institute, and especially in Maida fortification, Nata fortification, it has been most, you can see the more than. Now, even though we do, there are some issues are in the mineral fortification because of the bioavailability. So recently we did the small research work by giving a better stress, and then thereby improve bioavailable iron. Thereby the availability of the iron will go. Also done some animal experiment to see that shows much more bioavailable than the normal iron salts. So these also within the different fractions of the particular grain. We also made the bread, and bread also fed into animals. We found that anemic animals are much more so that this is one of the new area we have taken up in the improvement. The African yam bean is one the collaboration of the Nigerian people. It has got a lot of polyphenol dietary fiber content. So normally if you see the normal sandwich fibers and the polyphenols, and the African, this also showed that 15 power level shows that much good product, and then it is also contains more amount of antioxidant and tryptophenol content. And one of my students worked with other important seed is available in India is only 2 hemp seed. And flatbreads, I think chapati is a major stable component in our country. And it also divides some amount of the fibers or less, and then it also less in the fat content. In this context, rich amount of the unsaturated fatty acid content. We are incorporating hemp seed at different level. We found that the 10% level is going to be good. Thereby, you can improve the nutrition of the chapati also. Other important work we done with the edible seaweeds. Bhaskar also long time back. And we did the work with seaweeds incorporated pasta. We went up to 30%. We can propose highly bioactive compound that's required for the different health issues, and we found that has been implemented with respect to the edible Japanese seaweed. And we also done with some small work with the Indian also, and incorporated that by improve the bioactive principles in the pasta products. Other important thing is fenugreek. Fenugreek silage, effective lactase, and it also reduces sugar level and cholesterol. It contains isoleucine also, and it increases the production of insulin. And it also reduces the calcium oxalate kidneys in the kidney stones, and reduction of the cholera. And we have to place this particular fenugreek as one of the, you need to use then it implies into the different bakery and tertiary product to improve the health benefits. Especially, we are used in the bread, and we go, it has that can be developed with respect of the use of the fenugreek gum, and he also used in the tradition for chapati. Saturation decreases, that indicates that also acts as an low GI commodity. Apart from it, also have the other benefits. And we also use chicken, minced chicken, and also egg yolks. And also we use shrimp meat as a source of the ingredient in the pasta product, improve the nutrition profile of the pasta. That has also been done. And very important will be pasta. That is nothing but it's especially vegetables. Suppose if you pasta, that's the thought. In this thought, we develop the spinach and pumpkin, and this extract has been used as ingredient. Also, nature of the pasta, then it has been given us even all the can go to the pasta product. And apart from that, we also done with one of the Nigerian yam also in the meat-based products. So fortification adds a lot of in this one. Coming to the issue, and one of the issue is either it be the soybean or could be shrimp. But what we concentrate on the wheat itself are allergic to many people, especially some people are allergic to wheat. For that, we need to be definitely what we call celiac disease. That is more common in the case of the Western countries. In the central population, and almost 1% population gluten intolerance. For that purpose, CFI have done many. We done the many because if is almost be stopped, or that particular person cannot be given 100% wheat-free product to be given. In this collection, we developed many products. One is gluten-free biscuit, and then gluten-free rice biscuit, just based biscuit, and then we also pizza base. And then one is foxtail millet base and toast. And we also done little millet, and then we also do some of the patient serum also. I'm going to talk about some of things in my next coming slides. Apart from this, we have also other concept called sourdough. sourdough is a concept that will be use the different bacteria and make the dough. That sourdough will decrease the allergenicity. It also improves the bioactive molecule present in the flour by production of enzymes from the particular. So this is one of the work done with Nigerian sorghum. We done with a different culture. We found sorghum, sourdough-based gluten-free bread. This is one of the things. And apart from this, we also use enzymatic flavor proteins. We use the green mussel. That we digest the green mussel with different flavors. That flavors has been flavor analysis being done. At that time, apart from the used in the pasta product also, we developed the gluten-free pasta products in these different millet-based being used. I think my voice is audible now.
Sir, it's
Oh, it's okay.
in between.
Okay. Now it's okay now?
Now it's fine, sir.
Okay, fine, because the mic is okay, fine. Now it's okay, my voice is okay now? Okay. Coming to the, we also use chestnut as a source. I think in the Indian, the Delhi and other states, people use chestnut flour as during the festival season. That has been used for functional ingredients and it also bioactive principles. That has been used in the development of the chestnut-based gluten-free cookies. That is one of the new things. And already this particular technology has been transferred to the industry also. This is the example I showed in the backside minute. And we did different kind of enzymes, other things. We developed the foxed millet-based gluten-free bread. In this, we optimized the bread using the different enzyme. That has been a newer technology. In this, mostly people tell millet-based bread means always be mixed with the wheat flour. This particular thing is 100% millet-based flour. And we also developed the finger millet-based muffins. It is 100% gluten-free muffins. This is one more other product. Coming to the, we are trying to do some small work by treating the wheat flour itself with different treatment, especially chemical treatment, and then that particular chemical treated flour can be used for the development of the gluten-free bread. We could not able to achieve the 100% gluten-free bread because even though gluten-free wheat is present, that is cannot become as 100%. That's one of the small work. And we also did with pasta by altering pH. Then coming to the, there's a collaboration between CFTRA and Indra, France. Using the legume-based, different legumes has been used as a gluten-free source. In this, we also done the has been because that we are very good gluten-free legume-based pasta. Okay, done with the multi-fab base. It means multi-legumes has been used as a pizza base. As I told you, pizza is one more common, and many industries are looking for the wheat flour alternative for the pizza bases. And one of the things is we did with the particular work, we could able to done the work with the gluten-free pizza base using the different legumes. These are the different pictorials of the pasta products produced by the CFTRA. This glycemic index reduction. Basically, the other complication you face with the by eating the bakery product or this is one of the things is glycemic increase. In this connection, we are working the different low GI glycemic index agent. Especially, we developed the pizza base using the Triticum dicoccum. That's a different species as a tetraploid. Triticum is the hexaploid. That particular wheat has been used to develop the low GI glycemic index pizza base. And we also done many of the work with the low glycemic index noodles. And noodles are known as moderate high GI glycemic index. We have developed the product with low GI using the different legumes or incorporation, by which we also done with what we call voluntary trials. We found that glycemic index less than 55 that has been developed by CFTRA. And small work was done with probiotic enriched. We use a microencapsulated probiotic enriched vermicelli. That was not that much successful because but probiotics are not that much stable. That's one of the drawbacks of particular work. And other important thing is people are looking for the natural preservatives. That is one thing people are, especially people use calcium propionate or sorbate has been used in a bakery product as the preservatives, but prolonged consumption of that one, it may cause lead to the cancer. And sometimes without knowing that, many of the bakers will put more amount of that also. So that's the reason CFTRA came out with the preservative-free or natural preservative-based bread as well as muffin has been developed. And this is also another work which is basically using the multi millets and with the help of natural preservative, a particular product called cookie cake. This critical cookies, it looks like a cake, but shape is like a cookie, but softness is a kind of the muffin. That's what cookie cake. And this with the help of all the microbial data, published in data also. Other new concept I want to project here is oleogel, because people always tell this, people use the fat that causes the also trans fat content in the thing. Especially we are in the process of developing the oleogel. Oleogel is nothing but alternative to the solid fat. So just because we can't use we can't use oil as such, that won't form the structures. For the purpose, we are using the newer technique called oleogel. We need to have the oil. This oil has been tailored with the what we call gelators that can go for direct dispersion and indirect dispersion. That particular phenomenon is called oleogel that has been successfully tried and used with the groundnut oil and monopresside and beta cytosterol. This has been one of the compound, and we developed hybrid oleogels that has been applied in the cookies, and we replace the saturated fat with the oleogels. We produce the product with the better quality, and it also lead to the less amount of the what we call saturated fat in the end. That's one of the achievement that this is going to be. That is the one thing, because we can able to slowly replace the saturated fat content in the bakery products. So that's some more example from other country also. People use alternate fat in the bakery product. They used in the bakery goods as a oleogel. This compound has been used as already in the other countries. So coming to this, my last slide. And these are list of the technologies developed by CFTRA with respect to baking into pasta product. And these are the recently developed gluten-free cookie cake, gluten-free cookies, multigrain cookies. These are the things we developed. With this, to summarize my talk, nowadays, as chairman told, the beginning of the session, looking for the healthy ingredients, healthy products. Especially people will think bakery products are very not healthy. And as far as our CFTR research is going on, we are trying to make this bakery product as healthy as possible, and also with pasta product. That is because we can't avoid the bakery product or traditional product. That is because most of wheat-based product is our staple food. So that's what in future we will come out many of the functional foods. Thanks for going on. Thanks for IFSA. Thanks for everything. Thank you very much. Thank you. Thank you.
Thank you, sir. Thank you for sharing your innovative and insightful findings with respect to designer foods and the latest and the current trends. Thank you. Now, I request Dr. Maskar to please apprise the participants about the topic on the nutraceutical properties of oats. Over to you, sir.
Can you see my chart?
Yes, sir.
Okay. Thank you very much. I think Dr. Prabhashankaran, it was very nice. Is my video on?
Yes, Doc.
Yeah, okay, fine. So I think fantastic start to the session. I think with Prabhashankaran giving us the entire effect of processing and how do you include lot of these functional foods into the bases which are currently consumed. I'm just going to change the track and going to talk about the nutraceutical properties of oats and why it is more important, because I think many of us don't know oats because oats we see coming from a Western food and a Western world, and therefore there's a huge amount of awareness, which is lack of awareness, I can say, about the oats. And I just want to take you through very quickly in a 20 minutes what oats mean to us from a nutraceutical point. And this is what a simple definition, nutraceutical is a broad term to refer to a food or a part of the food that provides incremental health benefits and can be segregated under two broad heads. And there's a standpoint of a category, which from a marketeer point, and nutraceutical markets are divided into two. One is functional food and beverages, which are functional foods, which Dr. Prabhashankaran talked about. Then there are beverages, and then there are dietary supplements, which are consumed at a very, very small quantity. Vitamins, mineral supplements, protein supplements, and herbal supplements and other dietary supplements. Now, when you look at whole grains, and which I alluded to before when I did my introduction, that whole grains are something which we stopped eating for a long time. And that's more because the whole grains have a huge amount of sensory problem when you consume. And therefore, we started refining these foods. And therefore, we are removing hulls and we are removing brans and getting the inner macronutrient, which lacks of all these biochemicals. And therefore, the huge amount of these benefits of these whole grains has been lost. And if you look at all the whole grains, and if you look at as a cluster of them, they have a different protective physiological mechanisms. One is a very mechanical, and that's called dietary and insoluble fiber, which gives you a satiety. It gives you a good amount of viscosity generation of the food liquor. It has a hormonal effect because there are good amount of trace metals, zinc and seleniums and nicotinic acid, which are many times a cofactor in the enzymatic processes. Good amount of polyphenols, which can give you antioxidative and anti-inflammatory responses like oryzanol, carotenes, polyphenols. Polyphenols also lead into a lot of self-signaling and changes the redox status of the body, which is called as the internal redox system. And they also have a beta complex vitamins which regulate the energy metabolism. So there are a huge amount of value addition this whole grains do when they are part of your food. Coming to, I'm just calling it the nutraceutical, and I don't know how much of justice I can do in this talk to call it a nutraceutical, but let me go through the presentation and then you will understand what oats does. The oat grain constitutes of three, like any other whole grain. It has an endosperm, which largely of 50 to 65% of carbohydrates, good amount of protein and vitamins and mineral. It has a germ from where the new grain comes, a new plant grows, and it has an endosperm, depleted layer, and scutellum. It has the vitamins and minerals, but more important part is bran, which has a pericarp and seed coat. And there's so many new biochemicals which are sitting into that and which have a huge amount of health benefits. So if you look at a nutritional composition, it's a energy of 389. But the more important part is it has a protein and it has a carbohydrate which contains a dietary fiber and which gives a nutraceutical status to oats. If you compare the nutritional components of oats with other grains, if you look at the more important striking part is the protein, which is 9 to 17%. And another striking part is about the total dietary fiber. It is very high and it is as compared to barley. And this dietary fiber is different. It is called beta-glucan content. And this beta-glucan has a very different carbohydrate structure. It has 1,3 and 1,4 beta linkages. And that makes it good amount of highly soluble, and also it creates it generates a viscosity when it is dissolved or whenever there's a water inside any food. It also has a higher protein and a higher lipids. So on the whole, if you look at oats, has a good amount of composition of macronutrients and the micronutrients. Coming to what makes oat very different than other grains is, and why this composition makes it different than other grains, is about beta-glucan. It's a naturally occurring soluble dietary fiber with 1,3 and 1,4 beta linkage. This ratio of this linkages in the oats give rise to water-soluble property, and the higher molecular weight of this beta-glucan also in turn gives you increased viscosity. And what it does is this actually gives you a good amount of viscous of a food chyme, and therefore it shows the gastric emptying which get delayed, and therefore the satiety increases. And therefore, when you have a dietary fiber in your food and a very soluble dietary fiber beta-glucan, your satiety increases, and that allows you to consume less food. It has a protein and highest protein among all the cereals, 11 to 15%, high globulin and prolamine ratio. The protein quality is very different because of higher lysine, 4.2%, which is limiting in wheat and other cereal grains. And it has a very balanced amino acid profile. So the protein which it has, 11 to 15%, are very superior quality. And apparent protein digestibility, 85%, very high. Bioequivalence is about 80%. And net protein utilization 68%. So it is as high as soya, more than soya. And the new molecule which you are currently finding out is avanthanamide. Avanthanamide is a ester of cinnamic acid and anthocyanin acid. It's a very different antioxidant, and it is basically it's not a polyphenol, but it's a very clearly a anthocyanin acid polyphenol, and it has a potential mechanism such as anti-proliferation in the intestinal luminae, anti-inflammation, anti-itch, and cytoprotection and vasodilation. And I'm going to allude to this as we go through this. So how does oats give you nutraceutical status? So impact on a blood sugar and the glycemic index is the first part. Then what happens is oat starch. If you look at, there are three parts. One is about an entire oats. Oats has a beta glucans, which increases the reduces the action of P13K AKT, and this regulates expression of GLUT4, which Dr. Shashank talked about, which gets impaired in the diabetic people, which transfer the glucose to cell. It also doesn't get digested and goes to the colonic rectum, and there get fermented and generates the short chain fatty acids. And this beta glucan also increases the viscosity and therefore decreases the gastric emptying and gives you satiety. It also has a phenolics which inhibit the enzyme activity, alpha amylase, alpha glucosidase. Therefore, food doesn't get digested and glucose doesn't get generated. And it has a oat proteins, which gives you some amount of satiety, which has a insulinotropic effect, glucose dependent GIP and glucagon peptide 1, and the insulin gets reduced. And this impacts the glycemic index. Now, that's all theory, but I'll just talk to you about how the things work. Now, I talked about the increased viscosity of food liquor. Now, viscosity gets increased, and this is compared with any ready-to-eat cereal, which is carbohydrate based. And if you look at the insert oats and the steel cut oats, give you higher molecular weight. Therefore, they give you initial higher viscosity, and later also it gives you after digestion a good viscosity, and that is because of a radius of gyration. And therefore, all the varieties of oatmeal have a higher molecular weight and radius of gyration that RTC, which is ready-to-eat cereals, do not have, and therefore they perform better on a glycemic index. And the study which we have done in our company, these are test group where lifestyle changes were given to people also, and the oats were given, which we have produced. And then the control group where the traditional breakfast, which is a carbohydrate base, was given. Now, if you do these studies for 14 days, and therefore this is what Dr. Shashank talked about, AGP, which is a glucose monitor for 14 days, and it does every 15 minutes the glucose monitor. Now, if you look at fasting blood glucose in a test where people were eating oats after 14 days, there's a good amount of drop in a fasting blood glucose. And if you look at postprandial, that after you eat food, that blood glucose also drop, showing the effect of that thickening of the blood chyme and therefore not releasing a lot of glucose inside the food. So fasting blood glucose as well as postprandial blood glucose drops after you consume the breakfast of oats in the morning. If you look at this is what this is what the AGP and the glucose profile of a person. And if you see within this circle, there's a glucose excretion happens when you take a breakfast of a normal carbohydrate-based breakfast. But if you look at a oat base, you don't get excretion. These excretions are very, very difficult for a diabetic people to digest. If you look at in glycemic variability, the control group shows a good amount of glycemic variability between 6 to 10 a.m. because you have taken a carbohydrate-based breakfast. But if you look at this particular glucose release has actually tempered in a taste good. And this is something very unique about this whole grains we talked about, the second meal effect. Once you eat a breakfast in the morning, then what happens is when you take a second meal, since there is a huge amount of satiety, the second meal goes down. And therefore, we have done this part that people are eating 442 calories on the day 0. But when they have oats for 14 days, the calorie intake goes down by 335. And we are given only 30 grams of oats. So nearly 1 gram of oat reduces the calorie by 3 in the afternoon meal. And that's called a second meal effect, and which happens with most of the whole grains, but for the beta glucan containing oats, it happens very, very supremely. Impact on lipid profile and dyslipidemia, that also I will talk about. And what is that great about oats that reduces the cholesterol? Now, it's very interesting to know that the mechanisms of this cholesterol, one is about it reduces the cholesterol absorption. Also, it reduces the cholesterol generation. That is called LDLC, the lipid protein, low density lipoproteins. Now, what happens with the oats is it actually starts, these beta glucans start binding to the bile acids, and the bile acids then sit inside this viscous fecal matter and then get extruded or get outside the body. Now, once the bile acid goes down, the reduction in cholesterol and the bile acid levels activate the cholesterol 7-alpha hydrolase and also upregulates the LDL receptor. Now, these LDL receptors transport the LDL, which is the low density lipoprotein, which is a dangerous one, which people talk about, to the hepatocytes, and it gets converted into the bile salt. So you actually are reducing the cholesterol absorption and reducing the cholesterol content inside the blood by just degrading those LDL into bile salts. Other one is about reduce LDLC production. The short chain fatty acids produced by fermentation, which I talked about by beta glucan, inhibits the LDLC synthesis. So on overall, it decreases the cholesterol level in LDL, which is low density lipoproteins. Now, this is where we have done another study. As you know that the arterial health of any human being or any person depends upon a nitric acid, and that's called the nitric acid, which gets synthesized by nitric acid synthase enzyme. Now, if you take oats, the nitric oxide which gets generated, and it is a 45% enhanced release, and nitric oxide is required for endothelial maintenance of endothelial. Also look at the proliferation of smooth muscle cells, which actually lead to the atherosclerosis, because smooth muscle cells give you foam cells, gives you macrophages, then give you foam cells, and then create the ultimately the plaque, which is called atherosclerosis. There's 11% reduction in the proliferation of the smooth muscle cells. And this was done inside the in vitro analysis, the cell flow distribution data. Now, this is exactly what was done, not by us, by David Peterson and Monson Midani. They have looked at the DNA damage which happens, and that was looked at from a thymidine uptake. And if you take aventhanamide, the damage to the DNA goes completely down, and there's a viability of the muscle cells. So aventhanamide at a higher concentration is not toxic to the cells. It also looked at the vascular cell proliferation, and if you look at increase the aventhanamide, the vascular cell proliferation goes down. That means the chances of creating a plaque also goes down. And if you look at here the aventhanamide, the synthesis of nitric oxide, and this is again a study done by those people on the vascular smooth muscle cells and human aortic epithelial cells, that as you increase the aventhanamide, the nitric oxide keeps going up, and that shows that your arterial health will be maintained. And this is what another study which was done by Gulati, Mishra, and Pandey about 3 grams soluble fiber consumption, that is 35-gram oats in the morning. And this showed that good amount of effect of a total cholesterol, LDL, the VLDL, which is a very low density lipoprotein, triglycerides, and HDL. So overall, if you see, consumption of oats gives you good amount of glycemic index or a glycemia control. Also, it gives you good amount of a dyslipidemia control. Impact of weight and BMI is about, I think, oats, because of its beta-glucan and dimethylamide and its pre-biotic status, gives you 3 types of effects. One is hormonal effects. The interluminal viscosity of the food goes up, and therefore rate of gastric emptying goes down. Macronutrient absorption also goes down. That means glucose don't get absorbed. Postprandial glycemia goes down, and therefore insulin secretion goes down. Now, there are other effects called intrinsic effects. Is the energy density and the palatability goes down. The chewing and mastication goes up because of fiber, and that gives you satiety, and therefore energy intake goes down. Once the energy intake goes down, the fat oxidation increases and the fat storage goes down. And the colon effect, which I talked about, that this beta-glucan doesn't get digested and goes to the colonic rectum, and the fermentation happens to the short chain fatty acid because they act as a prebiotic. The hepatic glucose production happens, free fatty acids go down, and insulin sensitivity goes up, and insulin secretion comes down. All this reduces the body weight, and this is what is seen in our experiments. What we did was, actually when you burn fatty acids, you get acetone, and that acetone can be analyzed through the breath. So fatty acids, when go to liver, they give acetoacetate, and ultimately that breaks into acetone. And the acetone coming out in the breath can be analyzed, and that shows the fatty oxidation. And if you look at the studies here, the oats, which is in the blue, this one, and these are 4 subjects. We've done enough, but I'm just showing you 4 subjects. Poha, which is a highly carbohydrate data, and the noodles, which is highly refined flour. I think the fat burn index, which is calculated, has been very highest for oats, because oats doesn't give you a glucose, whereas these 2 foods give you glucose, and therefore oats start taking the energy from fats, and therefore the fat burning index goes up, and therefore you actually are consuming you are digesting your you're consuming your fatty acids and fats. This is what is about another data on a consumer, which is 44 consumers, and we have taken 40 grams of oats per day, and there was improvement in the glucose, insulin resistance, and a weight reduction. You can see the intervention, the cell with the intervention showed good amount of benefit across weight, BMI, glycemia, insulin, and a HOMO-R, which is also one of the markers of a diabetes. The another one we studied about impact of glucose consumption on blood pressure. Oat fibers, when they go, they create the short chain fatty acids, acetate, butyrate, propionate. They activate the G protein coupled receptors, and which acts on a 2 olfactory receptor, 78, and reducing renin and signaling to the brain, and decreases the blood pressure. And this is the study which has been done in China. And another study which has been done shows that a prospective randomized control trial for 3 months, 18 to 65 year was the age, and this is what they get it. So if you look at the reduction or the benefit or the difference in the blood pressure, you can see it here. The systolic blood pressure, the intervention group showed a good amount of difference, dropped it. Diastolic blood pressure, maximum and the minimum blood pressures also showed a good amount of positive influence. So, and that is more happens because of a nitric oxide synthesis. The nitric oxide synthesis happened because of avanthalamide in this one actually makes the blood pressure come down. And this is some of the study which has been done in China. So overall, if you look at in a very short, this particular oat in a whole grain consumption will lower your glycemic variability because it has a good amount of beta glucan and gives a good amount of viscosity, and it has a polyphenols which reduce the activity of anti-amylase and glucosidase. It reduces the total cholesterol and low density lipoprotein. And that's more because it is increased excretion. The fecal matter just carries all the bile salts. Also, because of SCFA, there is no synthesis of or reduced synthesis of LDL. Increased anti-atherogenic potential because of aventhramide increases the nitrogen synthesis, and lowering of body weight and body fat because low energy because of large amount of satiety, and the gastric emptying gives you lower energy and dietary fiber. The second meal effect I talked about, and it also improves the blood pressure. So these are trials which have been done by consumption of oats at a certain point of a day. But if you take oats as a part of your meal, there's a huge amount of benefits you can get. And therefore, I thought this small amount of data which we have, which we created in our lab, I can present to you so that you actually start getting and therefore I call oats as a more of nutraceutical, not as a particular component, but oat as a grain. So this is from my side. Possibly it was a very rapid fire, but I thought within 20 minutes I should do a justice to oat grains, and I can say it's a really a nutraceutical for the health issues which you see because of a modern lifestyle. Thank you very much.
Thank you, sir. It's an excellent presentation by Chairman, and you are given the impacts of all the insight, how the oats has health benefits, and you went to develop the blood pressure. You also described the new novel compound from the oats. Now we can, I think we can request next speaker to.
Yeah, good evening to you all, and hope you could able to see a slide which I have shared too, and my voice is clear to you all.
Yes.
Yeah. So, yeah. So I'll be talking on a material which is a biopolymer, which is nothing but
echo in your voice. There is some echo in your voice, please.
Is echoing to my voice?
Yes.
Now how it is? Can I move or?
Go ahead. Please go ahead, please. Sorry. Go ahead, please.
Thank you. So the topic which I'll be discussing with you, which is nothing but one of the bioplastic which we have extracted here in ICT and demonstrated for food packaging application. So it is nothing but a caffeine as a biopackaging application. Considering the time of 20 minutes, all the studies related to food packaging, I may not cover in detail because I need to give a certain challenges why we have undergone such study. And I am from the background of polymer engineering. So my perspective towards the topic will always related to the materials as in a plastics too, and its versatility towards the different industries. And one of the leading one is nothing but the food industry. So which we all know why the plastic is, because it is a lightweight, durable, and so many other fascinated properties which any plastics is associated to. However, due to its lightweight and non-corrosive and the cheaper in the cost, the plastics becomes a culprit that to be plastic in terms of the polymer which goes into the flexible packaging to any industry, starts from food to pharma to textiles to any other industry too, including electronics and electrical and locomotive industry. The lightweight of the plastic, which is a benefit, and the cost which is quite lesser as compared to the other materials which can be used for the packaging, but then it turns out to be a pathetic picture, which is like because of the lower dense material, lightweight material, it is not fetching a good amount of price as far as the recyclates or reprocessing of the plastics. Now even we all know the single-use plastics is also been taking the lead of it. So we need to target a issue which is nothing but a waste generation by this packaging, because packaging, there the plastics goes into and the primary and the secondary packaging as well as into and the tertiary package. So the packaging in packaging industry, considering to an any stuff which you are going to pack into, it becomes the integral part of it. So it will be always go along with that product, and that is the function of the product needs to be protected, preserved, and promote by all 3 P's. If someone needs to do it, it is nothing but the material which is a polymer or a plastic. But at the same time, the crux is like it is non-biodegradable, and it is quite a complex in recycling in terms of the complexity which I am talking about when we talked about laminates, which are the larger concept used into the food industries or the pharma industries packaging too, which becomes the complexity to convert into the recyclates or recycled material, so leads to an environmental pollution. So this problem is already arised, and this which you can easily locate to any geographical location of the country as well as throughout the globe. So we need to fix the problem. As we need to fix the problem, with the genesis behind fixing the problem is like there are certain numbers which might be an eye-openers to every one of us here. The plastic waste generation, the numbers which are pasted here, which are very recent numbers, which has digged out from the literature, recent literature, and the numbers are related to pertains to a plastic waste generation. It is not the polymer generation, considering the tonnage capacity. So plastic waste generation from 1819 to 1920, the recent data, if you see it, which is into the 34 lakhs tons a year as the waste. And that waste, which is been annually growing with the speed of 21.8%. So approximately, if it is like a 22% increment into the waste generation, which is supposed to be eye-opener to everyone in the field of polymers as well as those who are the users of the material. And this waste generation includes all synthetic plastics, which is non-biodegradable. Many are the plastic, because of the lamination and all, you cannot reach to a recycling or circular economy model into the plastic recycling. So the problem which needs to be fixed with certain alternatives to that synthetic plastic. Whereas on all the packaging applications or all sorts of application, we could not lead to a conversion into the biopolymers, but there are certain applications or certain packaging areas where the synthetic plastic can be easily replaced by a polymer, which is again a plastic or a polymer, which is a good molecular weight constituted material with a good strength into. Definitely, it may not be superimposed properties like in synthetic plastic generally hydrocarbon resins has, but we need to increase the usage of a material from materials engineering or materials technology for the area is nothing but the biopolymers. So there are many biopolymers which are being known to be used into the packaging industry as well as into an allied industry where all these synthetic plastics go around. And this biopolymer is not only the need of a food or food packaging industry now, even the pharma also needs it that way. The biomedical applications, automotive applications, few of the OEMs are being also come up with certain mandates to be used into certain polymers which may be a single use or a environmental friendly material, and a cosmetic industry. So it is increasing in demand in different application and the different sector in all verticals in the area of application. So one of its into and packaging goes with the food packaging. Next will be a pharma packaging, because in pharma packaging, many of the applications where high permeability resistance you need it. There you need to have it and the material like borosilicate. Even into some perfumery industry where the borosilicate material is the only material where the perfumery industry is wished to have, and they even till time didn't replace the glass as a material by plastics. But in food industry, yes, people are been using it, and that rate of increment into and the utilization into an food industry, not all sorts of packaging here, but people are giving it an approach towards an utilization of biopolymers into and the food packaging. When we talked about an biopackaging, when we talked about any polymer or a plastic per se as a biopolymer, that biopolymer may come up from the biorenewable. The resources which are being used to generate these plastics must be a bio-based. So biorenewable based material can also talked about as a biopolymer. A biodegradable plastics also people take it into the umbrella of biopolymers, and any other bio-related material. Bio-related materials is like the renewable resources generated, or a certain byproducts which can be converted into the derivatives of certain long chain material, which can be having a good strength, which also been considered into the biopolymers. So when we talked about any concept of biopolymer into the picture, then it is nothing but the known identities into a biopolymer area are starches, cellulose, then phytosans, then polysaccharides, basically, then carbohydrates, carrageenan, alginates, zen. And the area where this particular talk is focused on is nothing but the caffeine. Caffeine is one of the elastic protein which can be extracted from a sorghum. And even a West sorghum can also be applicable to get a good quality caffeine. So generation of extracting a caffeine, it's not the mandatory requirement to have it and sorghum into a good quality, even into the West sorghum, agro West, which goes for a dumping and all. From there also you can take out this material as one of the elastic protein, and this elastic protein has a tendency to form good elasticity and all, which we talked about over the this discussion part. So let me give you some glance onto the caffeine as a biopolymer. So sorghum grains are the major source of the caffeine as caffeine protein. Caffeine constituted of 70 to 80% of the total endosperm proteins, and it is a hydrophobic characteristic. The alpha protein, beta and gamma, the caffeine different percentage are being available, out of which the hydrophobic characteristics are available with alpha type of caffeine, and it is relatively more hydrophobic, and which is advantageous towards utilization into the packing industry, because the hydrophilic resins, it always get it dissolved or get it merged with the material where the moisture is been present. So a particular grade of the caffeine can be extracted. So certain study which is onto the laboratory scale are being done it into the ICT, and then eventually a certain large scale trial also been taken it, and we are even patented extraction process and its application into the packaging. So not into the much detail which has been revealed here, but I want to tell you into how the chronology goes. Here the sorghum as one of the grain which we have taken it, and then ethanol, one of the alcohol which we have used, and then the process which has followed by using a metabisulfate and sodium hydroxide, and the digestion into this, and then take out the material which is a white precipitate, and this white precipitate, once you dried it into, you will get it as a free flow suspension powder, which is nothing but this elastic protein, which is nothing but caffeine as a powder. The caffeine itself is an elastic protein, but you need to have it and more elasticity as far as the packaging applications are concerned, which we all know. Because if you want to pack any material, you should have a certain mechanical strength to the material. that strength in terms of its tension mode or a load tolerance, you need to have a good elasticity. Because elasticity deals with a shock absorption capacity of any material. So to increment into the caffeine what the native caffeine has would not be a right choice for going it for the application in terms of primary or secondary. So certain modification of the caffeine needs to do. So we have performed a caffeine modification by two ways. The first, which has been mentioned here, is the esterification. So we have done it and we have made it an ester derived caffeine. So due to this way, we could able to enlarge its elasticity and could get it a good film as a cascade material. Here is been shown the blown film. Certain experimentation we need to even optimized for the formulation, but a casting and the elasticity is could able to allow us to even melt blow this material. But certain trials we need to reach to and the final stage to convert into and the pouches and all that part is still in progress. But rest of the study which we have done it's related to the film formation and its film property. And then we tested that film property for its permeability resistance by using it and this water WVTR method as well as OTR and MVTR. That data is also been tested for this material, and a different esters derivative from methyl ester, ethyl ester, butyl and propyl are being taken it, and water vapor permeability and water vapor transmission rate. Here it can be shown a clear picture is like ethyl ester based systems has shown a better resistance towards the permeability, and which is advantageous towards utilization of any material as a packaging material to any biopolymer. When we talked about any material to be used for the biopolymers, you need to have it at certain strength, and that strength is nothing but its mechanical property or mechanical strength. And this mechanical strength, which we have tested by converting this caffeine into the film by addition of certain lubricants, which is nothing but the plasticizers. But plasticizers which are being used into the systems are not a phthalate-based plasticizers, are non-phthalate-based plasticizers are being used and converted into the longer specimens to go for characterization of tensile, elongation, rheological studies and all others concepts are being studied. And even in this case also the ethyl esters are marginally good as compared to this, the modulus value. Then amidation of the caffeine molecule was also been carried out, and there also different acid chlorides and anhydrides are being used, and their characterization was been done. So esterified and the amidation based of caffeine was been done, and the permeability data was been shown. So butyric based systems are being shown. Permeability into and the higher quantity acetic acid was being lower into this case. And here even not as a pharma application, but we have converted into a shell, and which can be a replaceable. I mean, we are been anticipating to replace it the gelatin as a material by this particular biopolymer. So there the dissolution study and bursting strength which we are been doing it there in collaboration with one of our pharma faculty here in ICT. However, the acetic anhydride based system has shown it a significant improvement into its mechanical property, which is more than a double as compared to caffeine as a molecule. So even into once the melt strength which been we could able to achieve, which is more than a requirement as at current stage, which we are having a non-Newtonian type of viscosity behavior, which is showing a great amount of shear thinning. but we want to build it and more Newtonian part to it. By that way, we will get it and sustainable viscosity over the higher shear rate. Then we could able to even electrospun it. And then electrospun materials will always have it and the better perspective into a many different application, and even into the coatings and the fiber spinning and all that. So that way, the plasticizers, when I've talked about, so not a phthalate based, the glycol or a TEC and the TA, these are the non-phthalate based plasticizers with different concentrations were being used. Threshold concentration of such a material was being characterized, and the better property we could able to achieve with one of the biopolymer which not been extensively studied as well as used into the food or pharma and any other application which can be unreplaceable to and the synthetic plastics to a larger extent. When we talked about all these, then we need to have it and one property to have a good surface or topological property. So in topological property, by addition of the plasticizers, which gives you an slightly an oily surface to it or lubrication surface to it. So we have tested for its contact angle measurement and studied for the comparative between PEG, TEC and TA, what will be a better contact angle gives towards and more hydrophobicity. So the TA part was been shown it humps into another better heights with better higher contact angle with a lower concentration of plasticizers added into. So that way the different concentrations of optimized concentration of all three plasticizers was being used and converted into and the film. The laboratory, the prototype based films and then packed with respiratory foods into it and certain studies which are still under progress, which we have been doing it now to see we could able to increase even to and the shelf life of any food ingredients and all, which we want to be, but definitely a biological concept we need to have it from their perspective, because my angle goes with the materials engineering more and towards the strength, viscosity and its application and productivity towards the material. So elongation properties of PEG based systems have shown excellent improvement after the certain loadings. So we could able to get it a higher elongation property. By that way, it is a more sustainable material towards an extrusion blown flame application or cast formed films as far as the biopolymer is concerned, and which will be a better elasticity compared to an US starches and some carbohydrates basically largely. So with this, I have given you a brief onto the study, which is what we have done it in the laboratory, and the certain investigations are still in progress. So I didn't reveal it completely, but yes, I mean, prima facie, we can always say it like it is a good material to be used as a biopolymer, which can replace the synthetic plastic.
Professor?
I hope I have completed on time. Yeah.
And then I'd like to request Chairman sir to conclude the session with the remarks.
Thank you. I think both the speakers, I'm very happy that I've been here with you and got to hear a lot of different things about nutraceuticals and the foods. And I think starting with Dr. Prabhashankar and nutraceuticals, as you know, are the food which give a lot of benefit. Many times this need to be incorporated into the food vehicles, because if people are going to eat it, it has to be in the part of the food which we normally eat. And this needs good amount of studies about, and that's what Prabhashankar has showed, that if you look at bakery and the fermentation, where all these ingredients like fenugreek, algae, everything you can take and add into the food. But more important part is it's not just adding, it's about getting the digestibility, getting the biochemical structure intact, it also needs to show health benefit. And therefore, it's not about adding something into the food materials, but understanding what interactions they can have in a processing conditions and whether the final food will have the same amount of taste and the texture which people eat. And it's fantastically showed these parts of taking different ingredients and showing that fenugreek and sea algae and very interestingly, I think there's a huge amount of scientificness about this study because there's a good amount of evaluation which has happened, good amount of structural elucidation happened, and the processing conditions which needed to keep all this intact and deliver value and a bioequivalence was nicely studied. So thank you, sir. Thank you very much. Coming to the Dr. Muske, I think I know plastic is a growing nuisance, though it gives a good amount of convenience and I think convenience to us because of plastic is a very indestructible material, and that also creates a problem because it keeps growing and it keeps accumulating in the environment. And where we seek a solution, the one solution is to make those synthetic polymers biodegradable, but why not go to nature and look at the polymers which nature has made? And he has shown fantastic work from a sorghum where caffeine has been isolated. Then it has an alpha hydrophobicity, but how do we increase further hydrophobicity by derivatizing it through alcohols and esters and anhydrides and chlorides? Good point is, you can talk about all these natural materials, but ultimately they need to deliver value and compete with the synthetic polymers. And that is what he has shown. He has shown that the properties can be studied and improved, rheological properties, surface properties, the mechanical strength. So it then competes with the synthetic polymer. That's what I see. Fantastic work, and this needs a amount of further work, but I think he will continue to work and get it done. But it's a nice approach, and it's an approach which the world needs today. And getting from a sorghum is fantastic thing, sir. I think I've just shown you oats as an ingredient. How can it add the health benefits to a lot of our lifestyle diseases or the metabolic syndromes which you see, the dyslipidemia, the blood pressure, the body weight, the glycemic index, I think, and the glucose release into the blood. And then it talks about the approach that we should go to the ancient science. What we were eating as a whole grains is more important than the palatable and sensorially very good refined foods, and we should actually possibly try to avoid that. Having as Shashank was saying, little consumption of those foods is okay, but be on a guard. So I think overall, I think this session actually has touched upon a lot of this one processing, packaging, and the grain. And I'm thankful to of course to arrange this session, and I thank also to both the speakers who added a huge amount of value. At the same time, I would like to, I think there's a duty I need to do about the silver sponsor Hexagon who has sponsored this one, and the MariQuest sponsored this session. So thank you for both these sponsors to make it happen and bring this knowledge to a lot of audiences which will ultimately derive value from this. And all these speakers, whenever you want, you can contact them and seek further explanation or further insights into the research. Thank you, sir, and nice meeting both of you. I have heard your name. Muske and my Musker names comes together.
It's quite similar to an institute, and both of us current institute is the same.
Yeah, so I heard your name many times, but never got an opportunity to see you.
Next time.
Prabhashankar, I will always, when I come to CFT, I'll see you. Thank you very much.
Thank you, Mr. Thank you, Mr. Thank you all, and thanks for chairman. Thanks for the visit. We'll conclude the session. Thank you, chairman, and other speakers, and thank you the organizers also. Thank you the sponsors also. Thank you very much.
जबाबदारी सगळी आता देशाची support करणारे माणसं.
Thank you, sir. Thank you, Priyanka.
नमस्कार डॉक्टर प्रबोध सर.
थैंक यू सर. थैंक यू.
नीलेश अमृतकर साहब नमस्कार, कैसे हो?
बस मस्त बढ़िया.
We have just finished our smart protein where I was chairing, and
You are multi-present in two halls, Hall A, Hall B.
So I was talking to somebody like our condition is like you go to one of the marriage hall where 2-3 marriages are taking place. You don't know where to enter, but you end up entering into one session where you have a lunch, but you realize that is not the hall which you are looking for. Then you go to the other hall.
Sir, I think our Dr. Asna and Dr. Preeti both have joined this program.
Very good, very good. I welcome both of you and please take it over, Dr. Nilesh Amrutkar.
No, I will not be taking over. It is Dr. Asna who is the chairman of now this session. So I think Dr. Asna, very good evening to you.
Good evening.
All well, madam?
All well.
Chalo, great.
So far so good.
So far so good.
Yes.
Yes.
इसी को औरंगाबाद समझ के बैठे हैं घर में.
Yes, वही औरंगाबाद में इधर हॉल में घूम रहे हैं, कौन दिख रहा है, कौन मिल रहा है तो.
वही तो.
So now you and Dr. Preeti, Dr. Preeti has also joined. So welcome Dr. Preeti on behalf of ICFOST AFSTI, and I think Dr. Asna and Dr. Preeti can take this forward. I will be switching off my video as well as mic. Yeah, thank you all of you.
I think there is a short break or something now as per the program. There was
we
a
are
tea
at
break.
Okay, we are at 5 o'clock, no, but 5:30.
And that's a virtual tea break.
Okay.
Have you had your tea?
Yeah. I was waiting in the lobby having the tea for this session to start. So I think since
I went to AFST, I wanted to be there only and complete this session. Then they told me, Chan said like 6 बज जाएंगे शुरू होने में, आप बेहतर घर ही चले जाएं. इसलिए मैं घर आ गई.
So, in fact, since we are yet to start, then maybe we can thank Perkin Elmer for being the session sponsor for this event.
Silver sponsor, I think.
Silver sponsor as well as for this session. I think they are sponsoring, and the other sponsors also for in this particular event. So I can see Mr. Nair over here, and also Sharad Tripathi ji. Namaste.
Sir, how are you,
change look?
हाँ सर थोड़ा
Mahajan has joined.
थोड़ा कोविड में थोड़ा लुक चेंज कर दिया. Working on this.
But I hope all health wise everyone is
all good, sir. All good.
Great.
All
Family
good.
wise सब लोग अच्छा है.
All well, sir, with your blessings.
Very nice. And I think from your side even Mr. Nair is there.
Yes, Sunil Nair is there.
Hi, sir.
Hello.
I'm there.
How are you?
Yeah, fine, sir. Going on.
Thank you very much for supporting our ICFOST AFSTI.
Absolutely, sir. It's a pleasure. Absolutely.
Sir, it's an honor for us to be associated with this program.
Thank you so much. And I hope that you make all full use of the connects that you would be having because of the wide fraternity in food industry who are there in this particular conference. So please, our Dr. Asna is also a very senior scientist. So a lot of people you would be interacting. And I think we are having Girish Mahajan also from High Media. Dr. Girish?
Yes.
Namaskar,
yes, Dr. Nilesh.
काय सगळं ठीक?
नमस्कार. काय म्हणता?
मस्त
बस ठीक.
मजेत.
Yes.
Also, Nilesh sir, also Sharad has a presentation also to make.
Yes. Of course.
Yes, sir. Thank you.
So it is happy to listen to Sharad after a long time.
Thank you, sir. Honor is all mine.
Yes.
Thank you, sir.
Whenever you are in Mumbai, do visit us.
Absolutely, sir. Absolutely. Just keeping fingers crossed to get this third wave over and we can start again traveling to places. Would like to see you, sir.
Yes. Definitely. So over to you, Dr. Asna and Dr. Preeti, both of you can take over.
All four speakers are there. Meenakshi ji, Dr. Meenakshi.
Yeah.
I think the other speaker is Dr. Meenakshi Singh and Dr. Khedkar.
Yeah.
So I can't see Dr. Khedkar is here. Yeah, I think he's here. Dr. Khedkar, are you here?
Oh, I'm not finding.
I can't see Dr. Meenakshi also.
Meenakshi also, I don't.
Okay. So can I request Bodhankar Events to please call up the speakers and check if they have received the Zoom link? Or should I put on our group, Bodhankar Events? Who is there? Karan is there. Who is there right now? Veena? I think I will write to them.
Who is there representing Bodhankar Events?
There is somebody Bodhankar Events, so I don't know whether it is Veena or Abhijit. This is Hall A, right?
Yeah, Hall A.
Yes.
I am just messaging on our internal ICFOST virtual group. 1 minute.
We are calling them.
Okay, who was this?
This is Ajay.
Okay,
from
Ajay.
admin side. Yes, sir.
Yeah, Ajay, please call up both the other speakers.
Yes, sir. Yes, sir.
Quickly.
Yes.
Yeah, thank you. And also send them on their WhatsApp the links.
Yes, sir.
Dr. Asna, maybe you can start with the program because otherwise it will get late. And in the meantime, I will see whether I can coordinate from the office to get in the other two speakers.
Okay. If it is so, I think without wasting much time, we can commence.
Yeah, because it's 6 o'clock, so
Yes,
we can
yes,
start,
I know
I think.
it is quite
Yes.
late.
Yes.
Thank you. A very good evening and welcome to the second day and the last session of the second day. It is a very important session. And at the outset, I thank the ICFOST organizing committee to have given me this responsibility to chair a very pertinent session in the current context of the pandemic. How can we make our food safe from all aspects? So here we are to discuss food safety solutions, a comprehensive outlook. I welcome Dr. Preeti Amritkar, who will be, with me as a co-chair for this session. She is a director at the labs or EnviroCare Labs Private Limited. She has a PhD from chemical technology from the renowned ICT. She has good experience in research area in analytical method development in chemical and biological testing in food, environmental, and consumer products. She has a rich experience of about 20 years. She is also on the committee of FSSAI, harmonization of product standards with the Codex, then pesticide residue analysis in milk and milk products. She is currently a member of Food Additive Sectional Committee, and she has also been participating in as a resource person for several conferences. We have with us about 4 speakers. Dr. G.D. Kedkar, who would be speaking on food forensics, Mr. Sharad Tripathi, who will be addressing on food safety solutions, a comprehensive outlook, and Dr. Girish Mahajan will address current trends in food microbiology testing, and Dr. Meenakshi Singh will speak on recent advances in food safety in reference to global and Indian perspective. So without delaying much, Dr. Preeti, you would like to say a few words, please, as co-chair.
Yes, thank you, Dr. Asna. Thank you for setting that context. Before we move on to the actual presentations, I would like to introduce Dr. Asna here. Dr. Asna Uruj, she is a professor at the Department of Food Science and Nutrition, University of Mysore. She has done her PhD and has more than 32 years of experience in the field of food science, clinical nutrition being her area of specialization. Dr. Asna is a member of FSSAI Scientific Committee and member of UGC, ICMR, and DBT expert committees. She is the Vice President, Association of Food Scientists and Technologists, and has been the President of Indian Dietetic Association, Mysore chapter from 2014 to 18. She is a distinguished orator and has been invited for more than 130 national and international scientific events related to food science. She is an eminent scientist with more than 200 papers and 8 book chapters and 2 technology patents in her kitty. She has guided close to 20 students for their doctoral work, and she's also the recipient of various awards. Professor G.S. Ben's Lifetime Achievement Award, Dr. Kalpana Chawla Award for Young Women Scientists, and Young Scientist Award, and she also has 52 Best Research Paper Awards. So these are only a few that I have mentioned here. So with this introduction, I thank Dr. Asna and look forward to this interesting session on food authenticity, food safety. Thank you. Dr. Asna, would you like the post presenter would be
Dr. Gulab Kedkar is here with us. Okay. Dr. Kedkar?
Madam, they are not joining because of some issue.
You are not joining?
Dr. Kedkar, sir.
Anybody representing him?
No.
No, is it? Okay. So then, Mr. Tripathi, Sharad Tripathi?
Yes, ma'am, I'm here.
Yes.
Dr. Asna, I think.
Yeah, you please introduce him.
Yes,
Dr.
yes, I will. So welcome, Mr. Sharad Tripathi. It's a pleasure to see you after such a long time, and have the privilege of introducing you. Mr. Sharad Tripathi is an accomplished professional with consistent success over 21 years of experience in sales, marketing, and product development. He has worked closely with food industry professionals and commercial testing lab. So he's currently working at PerkinElmer as a global market manager, dairy and foods. And I think he was associated with other organizations as well, like Agilent Waters and Shimadzu, etc. So with a very different background, but I think that background also gives you an insight towards food safety authenticity. So I welcome Mr. Sharad Tripathi for his presentation. Welcome, sir.
Thank you, ma'am. I would like to thank Dr. Asna, Dr. Preeti, for giving us this opportunity. I also like to thank all the organizers of ICFOST and all the members of AFSTI who are joining us today virtually in this event. Without wasting much of our time, I'll share my screen and I'll request people to confirm if you can see my screen.
Yes. Yeah.
Okay.
Yes, it is visible.
Yeah. Thank you. So the topic of the day is on food safety, and what I'm going to talk about the food safety solutions that are being offered by PerkinElmer. It's a bit different. I mean, there has been a talk around food safety, but what we are going to talk are the solutions that can prevent the food fraud and the adulteration, and we'll go through a bit in detail in the later slides. So I'll start with what is the importance of food safety? Why are we all here, and why there's a need for the discussion? I would say more than ever, we all have a responsibility to make this world a better place. And I thank all of you for organizing this event. And we are going to discuss what are the current challenges and how can we overcome of these challenges. So just to give some of the brief background, I was, while preparing for this presentation, I was going through Food and Agricultural Organization's website, and I found some of the data. This year, there were around 2,791 million tons of cereals that is going to be produced globally this year itself. And if you see the utilization, it is slightly over, it is around 2,809 million tons of cereals that are going to be produced. Okay, so why should we worry about? Why we should be worried? Because if you see, this is also from FAO's report on how to feed the world. By 2050, almost 60% of more food will be needed to feed the global population. Looking at the rise in the population growth, this is what is one of the major challenge for us. But this is not only the challenge. Even the current production, what we are having, almost 25% of our agricultural crops are contaminated with the mycotoxins and some other different problems. So it is not only the food produced, it is also the food waste that is creating a major challenge. So even if we are not able to, I mean, while we are working on producing more and more grains, even if we can sustain what we are producing, if we can preserve and if we can, avoid the food waste, then also it can help a larger community and the people to serve more and more people for food. Not only this, even food fraud is costing about $30 to $40 billion a year. At one side, we have a challenge of crop contamination. The other side is the adulteration. And adulteration is one of the major issues these days. According to WHO, the foodborne illness itself is costing roughly 2 million deaths per year, which is quite huge. And how this is happening? This has been happening by various reasons, either by heavy metal available in food or by pathogens, pesticides, mycotoxins, naturally occurring toxins, chemicals. Because of that, almost 600 million people are falling ill every year, and approximately 420,000 people die every year from eating contaminated food, either by bacteria, viruses, parasites, toxins, or chemicals. And that's where all of us has a responsibility to make this, to prevent this and to make this a safer food for all for consumption. And this is, I would consider all of you who are here, especially the organizers, you are all a food warrior who are fighting against food fraud and against preventing these challenges on food safety. While from PerkinElmer side, we are helping you, providing all the necessary tools and what can be used and how can we prevent, doing the right analysis, right tool, we can prevent the food fraud or issues related to food safety. A bit about PerkinElmer. Our mission is innovating for a healthier world. And as I said, food safety, we all have a responsibility to make this world a better place to live in for all. And this is something which was inherent in our DNA. PerkinElmer has been one of the oldest organizations from almost 80 years, almost 8 decades. And it all started with in a very small room with Mr. Richard Perkin, who started this vision. And now we are proactively connecting the dots between the challenges faced by various scientists, clinicians, researchers, and the solution that we are developing to solve them, to make even a greater impact for generations to come. We started focusing more on what sustainability truly means and what it means that we are improving science and healthcare and food industry for the better. A bit of glimpse of what PerkinElmer is at a glance. We are headquartered at Waltham, Massachusetts. As I said, almost 80 years of innovation. We are a member of Standards and Poor's, having currently operations in more than 180 countries. 45% of our revenue comes from Americas, 30% comes from Africa, and approximately 25% comes from Asia Pacific. Globally, we are more than 16,000 employees with $5 billion plus revenue and more than $18 billion enterprise value. So this is what PerkinElmer is at a glance. Let's look at the leading capabilities, what we have in different end markets. We have solutions to cater various end markets that we serve, including diagnostics, life sciences, food, and applied market. And we are not only providing instruments, we are providing the complete solution, which includes instruments, consumables and reagents, software, and after-sales services. Let's look at a bit more in detail on food. Our story that begins with the creation of a high-quality, unique portfolio for assessing safety and quality in food. And if you see in food, we are creating a solution that is helping manufacturers, growers, producers, etc., for safety and our global food supply chain. The solutions that we are proposing are help maintaining safety and quality of food, beverages by detecting fraudulent ingredients or toxins, or by either analyzing milk and milk products for unsafe antibiotic levels, harmful residues, and product impurities, or by enhancing plant grain quality to maximize productivity. Happy to share that almost 220 million tons of food that has been tested each year by our instruments, or approximately 270 billion gallon tons of water that has been analyzed, ensuring that people are getting safe water to drink for. Our solutions are typically categorized for upstream, midstream, and downstream segment. What it means that across the food value chain, which starts either from farmers, growers, agricultural research, to midstream segment, where mainly processors, dairy farming, or meat processing, animal husbandry that comes into picture, or to a downstream segment where distributors or the retailers are there. we have a solution to provide to each segment of upstream, midstream, and downstream, which also includes the commercial testing laboratories or contract testing laboratories. If we look at food segment as a glance, we are not only offering the solutions which are being used for safety testing, but also for compositional and functional analysis in food quality. And we are serving various end markets that includes dairy, grain, meat, seafood, processed food, cannabis and hemp, as well as agricultural and bioresearch. So complete portfolio solutions to offer for various end markets. That can also be categorized on the kind of technology that we are having. We are having fit-for-purpose instruments, for example, near-infrared flow cytometry, rheology instrument for food quality testing. Similarly, we have NIR solutions. Apart from that, we also have immunoassay-based or lateral flow-based kits. Or for broad-based, we have solutions like Oroflow, MaxSignal, Solus, which are pathogen detection solutions that we have. In analytical instrumentation, we have GC, GCMS, HPLC, ICPMS, atomic absorption spectrophotometer, and FTIR. And I know there are many people who are already using these kind of technologies and very well aware of the solutions, what we have. Very much specific to dividing between food safety and quality, although the topic of day here is food safety, but I would also like to draw your attention on the food quality solutions that we are having, which is NIR solutions for proximate analysis, or either for mineral analysis, we use atomic absorption instruments, chromatography solutions for various volatiles and non-volatiles, functional instruments, for authenticity, and we have variety of solutions. And for food safety, whether it is mycotoxins, pesticides, antibiotic residues, heavy metals, we have the line of solution, and some of that we'll see in the later slides. As I said, when it comes to food safety, we have an arena of portfolio to choose and to go for. For example, if it is fatty acid, sugars, additives, we have the solutions GC, GCMS, LCMS, MS. For pathogens, we have a complete range of pathogen solutions for Listeria, E. coli, adulteration and contamination, whether customers are requiring a spectrum 2 FTIR or heavy metal analysis to be done by atomic ICP or ICP-MS, or LCMS-MS for antibiotics, mycotoxins, pesticides residue. We have a complete solution, a complete set of offering, which includes from UV IR to GC, GCMS, LCMS. Apart from that, we are also having microbiology solutions, which we offer from, for example, pathogen detection and the rapid diagnostic kits for various antibiotics and naturally occurring toxins. Similarly, as I said, food quality, we have an instrument which is being used for compositional, functional, and authentication testing, like moisture, protein, fat. We have a solution to offer same ways for process optimization and adulteration. We have instruments, especially for dairy segment. We have instrument like lactoscopes, online NIR, inline NIR solution. For grain analysis, we have DA7250, FT9700, FTNIR. So variety of solutions, whether it is for quality testing of food or safety testing. PerKilmer is the company which is having a solutions for all the needs. Again, for functional instrument, whether it is glutamatic, texture analyzer, viscosity analyzer, thermal instruments for material characterization. Wherever there is a need from the scientist to identify and analyze, we have a solution to offer for. Our journey begins with understanding the customer needs in each industry, and we are happy to be associated with you from past 80 years. And are there any need or any solutions? We are there to support our scientist fraternity. As I said, we are serving various end markets, including dairy, grains, cannabis, processed food, meat, seafood, and agricultural bioresearch. Know more in detail about that, or if you want to have a local contact, Narayan Bhatt, he's taking care of Karnataka region, is our local contact, and his details are mentioned there. I'm taking care of global market for dairy and foods, and are there any queries in this regard, what we have discussed? Please feel free to have any queries which you have, or you can also write to us or contact us on the email ID and the mobile number mentioned. Thank you very much from my side.
Please stop sharing your screen.
Yep.
Yeah. Thank you, Mr. Tripathi, for giving us an insight on food safety solutions, a comprehensive outlook. I will give a summary at the end of it. May I have the pleasure of introducing Dr. Girish Mahajan. Is he with us? Yeah, Dr. Girish Mahajan will be speaking on current trends in food microbiology testing. Continuing with what Mr. Tripathi mentioned, how important it is, I think you will be focusing more on the food microbiology testing. I mean, this is a very appropriate one, especially in the ongoing pandemic. You know, it is very, very important that even the food microbiology testing should see a revived look and more easier solutions and very sensitive and authentic solutions we need. May I introduce Dr. Mahajan? He is currently associated with High Media Laboratories as Senior Vice President of Microbiology Division. Prior to this, he was associated with Piramal Enterprises, Omniactive Healthcare Technologies, Unilever, Hext, Johnson & Johnson, all notable companies. He is an active member and mentor of the American Society for Microbiology and Microbiological Society India and Association of Microbiologists in India. He is a member of several committees. He has 19 patents and 144 scientific publications, book chapters, media publications, posters to his credit. He also has several national and international collaborations. He has been honored with several prestigious awards. To name a few, the Distinguished Industrial Microbiologists Award for the year 2020, bestowed by Microbiologists Society of India, the AMI Louis Pasteur Award, OPPI Scientist Award by Organization of Pharmaceutical Producers of India. Currently at High Media, he is a team member in the research and innovations contributing to High Media's mission of providing research-based quality products to the world. Over to you, Dr. Mahajan.
Hello, good evening, everybody. Thank you, Dr. Preeti, and thank you, Dr. Asna, for giving me this opportunity. So actually, I had shared the voice recorded slide with your technical team. So would you like to run the same, or should I run from my side?
The organizers should inform us, like, will they be sharing, or would you want Dr. Mahajan to share it?
We have your PPT. So shall we share it?
Yeah,
yes, please. Yes, please. That's better.
You put it on slideshow. No, I think you start from the beginning, actually. I think we're not able to hear the voice.
Is it audible, sir?
No.
Just hold.
Dear friends, very glad to be on this forum of ICFOST. Let me take you from little basics. Food microbiology is the study of the microorganisms.
Is it audible now, sir? Hello?
Yeah,
It was
it's
audible
audible.
earlier, now it has stopped. You changed something, it stopped.
That contaminated food are used in the production of food products. The study of spoilage microbes, pathogens that may cause disease are also included in this study. Microbes are used to produce fermented foods such as dosa, idli, cheese. It will be interesting to know some historical aspects of food microbiology too. For centuries ago, with no knowledge of microbes, humans discovered different ways of food preservations such as salting, drying, etc. to avoid food spoilage. Food microbiology leapt up in 19th century when we started identifying different microbes. In that era, pasteurization was discovered by Louis Pasteur. Microscopy and microbiology media research became stronger. The field of microbiology is still rapidly evolving with new tools and techniques for discovering and preventing foodborne microbial diseases. I'll be talking on 4 aspects of food quality testing: food sample preparation, microbial food quality testing methods, environmental monitoring, and finally, rapid methods in food microbiology. Let us first see some information about food sampling, which is very key step in deciding the quality fit of the tested food. The idea of proper sampling is to abstract microorganisms which are trapped in the food sample. The aim of sample preparation in quality testing protocol is to retain and check presence of total microbes load, including aerobic bacteria, yeasts, and molds, and important to check the presence of key pathogens such as Salmonella and Listeria. For total count, it involves, as you can see, 3 steps: sample preparation, spreading out the suitable dilution on total count agar or any equivalent media. Later, after incubation, we can take count and express final colony forming units number per gram or per ml of the sample. For pathogen detection, there are additional steps after sample preparation. It involves pre-enrichment, selective enrichment based on pathogen we look for, selective plating, and finally pure culture, if we obtain, is subjected to biochemical and serological confirmation. In old methods of sample preparation, it involved use of vessels with mixing blades. However, in those methods, the container was in contact with the blender surface. Today, we have homogenizers which allow sample preparation without contact with the sample. This is the example of the flapping homogenizer. Samples are added in sterile homogenizer bags along with appropriate diluents which are homogenized through flapping of the paddles as seen in the images herewith. This is how flapping takes place. Let us also see some microbial food quality testing methods. Before going ahead with testing methods, let us know standards and guidelines which govern these methods. The FSSAI has established under the Food Safety and Standards Act 2006, which is a consolidating statute related to food safety and regulation in India. FSSAI is responsible for protecting and promoting public health through the regulation and supervision of food safety. For quality testing of food products, we need to test as per the BIS, the national guidelines, or as per the international guidelines such as ISO or FDA's BAM or AOAC. The use of chromogenic media helps for differentiation and confirmation of identity of some of the key pathogens. The principle involves release of chromogen from its substrate by enzyme action, which is present only in some specific microbes. It can be seen here. Sharing here with example of food testing workflow for detection of Chronobacter sakazaki from the infant milk food, infant formulae, infant milk substitutes. The majority of Chronobacter sakazaki cases are adults, but low birth weight, preterm, neonatal, and older infants are highest at risk. Several outbreaks of these pathogens are reported in the history. Very famous outbreak in India was in 2006 in Chandigarh. The ISO protocol is displayed here for its confirmation. CCI agar allows easy and reliable detection of Chronobacter sakazaki. Same media provides well differentiation against Enterobacter cloacae. Green colonies are due to release of chromogen by enzyme action alpha glucosidase on the substrate mentioned in the above slide. Let us see some information about Salmonella media evolution. When we used XLD earlier, we used to expect typical pink colonies with black center indicating Salmonella species with lactose negative and H2S positive trait. However, microbiology has witnessed 3 more varieties of Salmonella which are both lactose and H2S negative, lactose positive and H2S negative. Third one is both lactose and H2S positive. These new varieties of Salmonella mislead the identification of typical media such as XLD. So we introduced very specially designed chromogenic media called Salmo-conform selective agar, on which any species of Salmonella will give you mauve to purple colonies, confirming presence of Salmonella in the sample. As mentioned before, on XLD agar, Proteus mirabilis gives colonies which mimic as if they are Salmonella species. However, on this new chromogenic media, Proteus mirabilis gives light brown color, which clears the dilemma. Such specific chromogenic media are available for many other food pathogens such as Listeria species, Clostridium species, Vibrio species, and Enterobacteriaceae family. Let us also see some information about environmental monitoring. In spite of harsh manufacturing processes like drying, heating, pathogens are known to survive such conditions. Also, cleaning and disinfectant cannot kill microorganisms fully. Pathogens still enter the food product via environment. So environmental monitoring is very important. Sharing here with one example of major recall of baby milk powder Lactalis. It was due to the presence of Salmonella in the powder. Air sampling can be done in both passive and active ways. In passive air sampling, ready-prepared soybean casein digest agar of 90 mm diameter are exposed at specific points in production and other required locations for at least 4 hours. The plates are closed and incubated at 30 to 35 degrees Celsius for the less than or equal to 3 days for bacteria and at 25 to 25 degrees Celsius for 5 days for fungi. Based on the number of colonies obtained, the hygiene status or quality of the area is decided. In the active air sampling unit is used which collects air at the rate of 100 liter per minute. The time period is dependent on the area. 90 mm soybean casein digest agar is used for the same. The plates are incubated in the way mentioned before. For surface monitoring of the ISO area, scored plates of 55 mm diameter are used. These are also called contact plates. They are also grid molded for ease of colony counting. The raised media in it helps to pick up microbes on the surface. Just remove the lid, put the media on the face of the surface, pick up and let it. The type of media and the incubation period is same as mentioned before. Transport swabs are also useful in testing the surfaces which cannot be easily reachable by contact plates. Pre-weighted swabs with media or buffer are available. The swabs are spread on the respective media for pathogen testing. Biocide-free cellulose sponge in sponge stick and only sponge versions are available. Dry or hydrated with 10 ml of different culture media with and without gloves are also available. They are also used for surface sample collection. The fluid in it neutralizes the disinfectant and antiseptic compounds in the collected sample. The method of sample collection is as shown here with Let us also quickly see rapid ways of identification of pathogens from the food sample. In the past 5 decades, there is significant gradation seen in the ways of identification of microbial isolates. The classic ways, including use of biochemicals, chromogenic media, selective media, are still useful, but they have very narrow range, low throughput and time consuming. The discovery of PCR and very selective probes made 16S rRNA and 18S rRNA very attractive and authentic. They are laborious and demand high skills. The multi-top mass spectroscopy for microbial ID is one of the easy, robust and rapid way of microbial identification. Of course, if one is looking for totally new microbes in his or her collection, then polyphasic approach is the best way. The slide here displays the disadvantages of earlier ways of microbial identifications. The multi-top mass spectroscopy works on the principle of detection of specific release of proteins from microbial sources in the molecular weight range of 2000 to 20,000 Daltons and their speed in the vacuum. The strong laser beam ionizes the proteins in the microbial samples and allow them to fly from the sample to the detector. The time of flight is measured for these proteins. Here displays the general workflow of this particular identification work. The spectrum of molecular weight and the time of flight is acquired in the form of chromatogram. It is compared with the database available in the software and identification report is displayed. The multi-top of high media and AutoBio has the world's largest database. It is very robust and highly reproducible. It encompasses over 1003 genus, 4943 species and around 16,000 strains including bacteria, fungi and ATCC reference strains data. It has a very stable algorithm. It is available in our lab for any demo purpose. The unique selling points of this rapid microbial identification tool are shown here. The cost per test is hardly 7 to 10 rupees. There are many new things which can be discussed in some other forum. Thank you for the patience listening. I'll be happy to answer any queries based on the available time. So thanks to all of you. So if you have any queries, definitely I'll be happy to answer.
Yeah, Dr. Mahajan, I just want to ask, like in the context of this current pandemic, like, PCR tests have been in the news and in the demand, like how much has high media contributed to this? Like how have you risen to the occasion? In any way you have been you have contributed to this diagnosis?
Right. So of course that is a totally different segment of the clinicals. So we have contributed very significantly in this last 2 years, especially in VTM, viral transport media, RNA extraction kits, as well as the RT-PCR kits and the RT-PCR machine itself.
Okay, machine itself. Yeah, that is very, very important.
Yes, thank you.
And I just, as I was hearing seeing your slides, I just wanted to know about the identification of the microorganism assumes importance in diagnosis and in food testing and in gut microflora. Well,
Sure.
You are also contributing. You have some packages, something for these gut microflora. Any? Can you highlight on this?
See, gut microflora as such.
You have any
Multi-top.
kits? Because some of them are having, some companies have kits, which especially will be useful for these who have IBS or disturbances in the gut microflora, especially the autistic children.
Okay.
So any
See, we don't have any direct kits of that type, but what I presented, like we have the range of media for capturing all the type of gut flora.
Okay,
including bifidobacterium, Clostridium species.
Lactobacillus.
Yeah, lactobacillus, even Bacillus coagulans. So we have a range of media, but nevertheless, once you get pure culture, it can be easily identified by multitop. Because the multitop what we have, it covers major of the gut flora.
Because these kits, the reason I'm asking is since we have been working on these autistic children for quite some time, and we have found that because of the restrictiveness of their diets, just 3 or 4 items, you'll be surprised to know, but they do have a lot of GI problems. When we have given personalized diet plans to them, we have found that there is small changes in their gut symptoms like abdominal pain or loose stools or constipation or whatever. But when we inquired about these kits for detecting the gut microflora, particularly from the fecus only, 16S rRNA, were quoted as quite expensive, which is not possible for to purchase. So that is the reason why I asked you if you have got any solution to that. And you said you have separate this one, no? You have
So
for each.
We have a range of media for this, and
using this media we can.
Correct. And people all over the world are actually using our media. So whatever type of culture you have in the mind, you can come to us and approach us. We'll provide you the media, or we can actually possibly convert into a kit format for you and provide you the exact solution. And also we can isolate also. We'll help you in isolate.
Yeah, see, this will be, we'll have to collect the fecal matter and then isolate, and then the 16S rRNA is the one which is generally recommended. Probably I will discuss with you in person. Thank you so much, Dr. Mahajan, for giving us this insight about the various advances in microbiology testing. I would request now Dr. Preeti to give her opinion or say a few words on the topic of the session.
Thank you, ma'am. Dr. Mahajan, a very nice presentation, nice video that you showed, and very interesting to know that Multitop has also entered the microbiology field. And it's very exciting to see that you can actually find out the bacteria responsible for contamination. And so just have one question, sir, for you. Is it how much time it takes really to understand what microorganism is the causative organism? Like if the sample is given to you, how much time do you require on a multi-top to understand?
In the multi-top, if I have a suspension of bacteria, so it is hardly, we can say maximum 2.5 minutes. Because it is simply spotting the microbe suspension, and we have the 2 matrices for it, and dry it and you scan it. And scanning hardly takes about 10 seconds. And the report is ready in front of you on the screen.
Okay. So that's a very exciting technique, I would say.
Yes, definitely.
Yeah. So I just hope that, Multitop really brings out much more information that we need, because a lot of foodborne, deaths, they are actually not reported because we don't have the data, we don't have the libraries, there is no gathering of the data. So I hope that with this, we begin a new era of, actually recording everything and then, analyzing that data and targeting like, the other European countries or even, developed countries have. So a good presentation, Dr. Mahajan.
Thank
And
you so much.
Jyoti Tripathi also a very nice presentation. I think instrument manufacturers are one of the important stakeholders in the entire food authenticity and safety requirements, because unless we have the right kind of detection tools, we cannot do anything. Like multi-top, I'm sure Tripathi also is aware of this. And so I think if you see the regulations also, FSSAI and any other regulation, the regulations are getting stricter. The list of molecules, contaminants is ever increasing, and the detection limits, the requirements of the law is going down. So it's the reverse trend. And so you have a tough job to do, Birkin Elmer and other such instrument vendors, and they're doing that at their level best. So I think it's just that we have to, be honest with our work and just keep doing what best we can do in this field for, preventing the, adulteration or contamination. So thank you for a wonderful session to both the speakers. Over to you, ma'am. Asta ma'am. Thank you.
Thank you, Dr. Preeti, for your insight. I've just been informed Dr. Meenakshi will not be joining us. Is it confirmed, Dr. Preeti?
Yes, it is confirmed. Yes.
Okay. Well, so in that case, we can wind up the session. May I just summarize the two speakers? We had Mr. Sharad Tripathi from Perkin Elmer. He spoke on food safety solutions, giving a comprehensive outlook, emphasized the importance of food safety. And you also brought out very rightly that mycotoxins also are playing a major role in our, food, what should I say?
Value chain, food value
Yeah,
chain.
making it unsafe. Yes, making food more unsafe. And I like the terminology food fraud. Well, food adulteration is outdated now. So this is the new term, food fraud. Yeah, I think food fraud assumes greater importance, especially in the rise in the roadside eateries, the demand for fast food, rapid food, or whatever you call and junk food. So that's where, the same recipe or menu will be available at a higher cost elsewhere, and on the roadside it will be available at half or 1/4 the cost. How will he be able to provide with all the necessary ingredients at such a lower cost, if not for adulteration? So he also emphasized on the wider range of latest technologies for assessing the food quality and safety. And particularly what caught my attention was you have mechanisms to identify the authenticity of spices, honey, olives, oil, coffee, etc. Because we have many brands, manufacturers offering these, and the costings of all these, olive oil, everybody is trying to use it, but we forget that all oil, each gram provides 9 kilocalories only. Only thing we have to use it in moderation. But there is kind of a fancy for people that once you switch over to olive oil, everything is fine. But whether it's really olive oil or not, that has to be
virgin olive oil or reused one.
Exactly. So that is where we need to have more stringent and more sensitive methods to identify how authentic they are. And that indeed was a comprehensive outlook about food safety solutions from Perkin Elmer. And Dr. Mahajan emphasized on the need and necessity for microbiology testing in foods. And definitely this assumes greater importance in the context of the current ongoing pandemic, and also in the context of the demand and the need and availability of processed foods in various forms, and the fast foods, the roadside eateries, etc., as I mentioned earlier. You also gave an insight about various improvised methods on homogenization. I think this, especially for food sampling, for analysis, this helps a lot in using better homogenization methods, because then you can draw a better sample for analysis. Then you outlined about the food testing workflow, and also threw light on the infant foods and microbial identification, especially in the present context, as I mentioned earlier, that in gut microflora and this one PCR testing assumes greater importance. So these are the two speakers. I wish we were joined by the other two, perhaps due to some unavoidable circumstances, they haven't been able to join. And all of us can vouch that most of us have been using instruments from PerkinElmer and the high media labs, not to forget about the chemicals and the various this one available from high media. So high media has a brand name. Not brand name is because of its quality, and so to say about PerkinElmer, whenever we shortlist any equipment, we save and we say, like, let's we pay for quality even if it is a little higher. So we go for these because we know that the results we get are very valuable for a researcher. So with this, I end this session, and I thank Dr. Preeti to supporting me in giving her opinion and introducing the speakers. I thank wholeheartedly on behalf of ICFOST Organizing Committee, both the speakers, for sparing your time and participating in this session late in the evening. I thank the sponsors of this session, the silver sponsors of this session, PerkinElmer, for facilitating and also supporting the ICFOST. I thank the organizers for organizing this at this time of pandemic. It was planned as in a hybrid mode. I wish it happened, but nevertheless, we are still connected through the virtual mode. So I thank the organizers, the president and the CEC committee and all the organizing committee members in making this a success. And not to forget all the participants, especially the delegates who have all registered to participate in this conference. And many of them are also presenting their posters. So with these few words, I thank everyone behind the screen for projecting, and the event organizers, because they play a major role in making this event a success. Thank you so much.
Thank you, ma'am.
Thank you.
Once again, thanks, Dr. Preeti, Dr. Asna, Dr. Nilesh, for giving us this opportunity. Thank you very much.
Thank you.
Thank you very much to all the organizers. Thank you, Dr. Nilesh. Thank you, Dr. Preeti, Dr. Asna.
Thank
See you sometime. Bye.
Yes, bye-bye.
Bye-bye.
Thank you.